Hello, hello. Can you guys see me and hear me? Yes, I guess I am live. All right, so like I always say, everybody, namaskara everyone. Andariki namaskaram, ellargu swagatam, and a very warm vanakkam to Rankplus J English. Today I'm starting with the most high weighted chapter of chemistry. This is your inorganic chemistry, and you guys know that this is my favorite chapter. We're starting with coordination, compounds, everybody. Yes, and in this chapter, what are the things that we will be covering? Everything. Yes, we will be covering basically everything. Each and everything from this chapter will be completed. So quickly go ahead, like the session, everybody. Yes, it is about to be 5 o'clock, and I think we will be done by 10:30, 11 o'clock with a 15-20 minutes break in between. Okay? All right. So yes, hi Trent, hi Atharv, hi Srihari. Very warm welcome to the session, everybody. This is our first academic session in Rankplus J English channel, everybody. Now, before I start with the session, what did I tell you? What are we going to start with? We are going to start with first the difference between double salt and complex salt. Then what is it that we will be studying? We will be studying about Werner's theory. Yes. After that, there will be nomenclature. Okay. After that, what is it that we will be studying? Bacha, do you know how to change this? How to change the default background color should be black. Yes. What about now? Still did not change. What happened? Did I not just change it? I did, right? Okay, it's still not changing. No worries, no worries. Okay. All right. So after nomenclature, what is it that we will be studying? Then we will start with valence bond theory, limitation of valence bond theory, and everything will be covered. Okay. After that, what is it that we will be studying? We will be studying with crystal field theory, limitations of crystal field theory, then isomerism, and of course, there will be a lot of PYQs. And finally, I will also give you the mind map of this chapter. So this is going to be the flow of the session. What is the flow of the session? This is how I have written. These are the main topics that I'm writing here. Yes, everybody, this one shot will be sufficient for you even if you are studying for the first time. That is a promise. After today, I don't think that you will have any problem in this session. So quickly, guys, if you understand, whenever you are able to understand a topic that I'm telling you, what do you need to do? You are going to write down EPBT. That means easy peasy biryani tasty. Okay, everybody, are we all ready for the class, guys? Are we all ready for the class? I hope that no doubt. By the way, let me tell you, who am I? I am your master teacher, Nabamita Bhattacharya. Yes, I am your chemistry educator here, Nabamita Bhattacharya. I do have a 5+ years of experience in teaching by now. I have completed my master's, that is MSc in nanoscience and technology, which is an interdisciplinary subject. Yes, I have completed my B.Ed in physical sciences. So I basically know a little bit of physics as well as chemistry. And I do have JRF. What is JRF? JRF is Junior Research Fellowship. So you are given a post in IIT Guwahati, and that's called as Research Associate. So basically I was sort of a junior scientist. Yes, and where did I did it from? Where was it? I did it from IIT Guwahati. Okay. All right, so this is my introduction. So I hope that everybody is clear. Boards का भी हो जाएगा बच्चा, boards का भी हो जाएगा. तो चलो, let us start with today's session. Yes, First thing everybody is, now you all must be confused that ma'am, what really is a coordination compound? Acha. Coordination, do you all understand what is coordination? Bacha, coordination is basically, see, when now that I'm teaching you right now, you and I are supposed to have a coordination, is that right? Yes. If I teach you properly, if I solve the PYQs, only then you will be able to understand, is that right or wrong? So you and I, we are both supposed to have some amount of coordination. Yes, acha. Now you must have seen IPL, T20, World Cup. What happens? Yes, all the players, the cricket team, the football team, whenever there is a group of people involved in an activity, you understand that there is supposed to be some amount of coordination. Exactly my point. Exactly my point. So coordination, that means within a compound there is supposed to be some amount of coordination. Get the point? Yes. So what kind of compounds are coordination compounds, or what kind of compounds are coordination complexes? You will notice that even the blood that has hemoglobin, have you seen the structure of hemoglobin, bacha? Yes. Yes, my Werner Sena. Yes. Yes or no? Yes or no? Have you seen the diagram, the structure of hemoglobin? You must have noticed that it looks very complex, right? Yes, does it not? In between there is an iron, and then there are like hexagon structure, pentagonal structure, and all of these. It looks like a very big compound, isn't it? Exactly. So hemoglobin, chlorophyll, what are these? These are coordination complexes. So like I said, everybody, when there are a group of people involved in an activity, there is supposed to be some coordination among them. Similarly, in a compound, you understand that there are a lot of elements that are involved. These elements, among them, they will have some coordination. They will have some coordination, hence the name coordination compound. So guys, is this clear? Is this much clear to you all? Is this much clear to you all? Yes. Kalai Roshan, I think, didn't you guys see my farewell video? I did a farewell video so that you don't ask me these kind of questions again and again when I'm teaching. So chalo, first of all, let me tell you, before you ask this again and in every video of mine, this is my first video, so letting you all know, but after this, do not keep asking me this question again and again. Why did I leave? There is no gossip. There is no controversy that you will find here. Okay? So don't ask this question again and again. Why did I leave? I just wanted to start something from the scratch, and the age that I am in, I think I can explore my career, look for more growth and all of these things, and growth is a constant thing, everybody, change is a constant thing. In my life, I thought that it was enough time. I spent 5 years in the previous organization. So I thought it was time to come out, learn more things. Yes, by the when you spend 5 years in an organization, you basically have learned pretty much everything that an organization can teach you. So I wanted to learn more, I wanted to grow more, I wanted to explore a little more, and that is why I have changed my organization. I hope that's fine by you. So let us start. No more disturbances, everybody. We have to do a lot. There is a lot of syllabus behind it. So let's start. Now what happens is, before even getting into coordination compounds, we have to understand a little more basic about double salts and complex salts. Now, what is a double salt, bacha? What is a double salt? See, all this while you only knew about something that is called as what? Something that is called as your simple salt. Sodium chloride, Desh ka namak, Tata namak, Shuddh namak. Everybody knows this, isn't it? All of us know about that. Great, yes. But now, what is a double salt? Let's understand that. Okay? Double salt, by the name of it, if you see, okay, double salt, by the name of it, I think you will all be able to understand that if you take, yes, if you take 2 or 3 salts, 2 or 3 simple salts, and you put them together, then you will get a double salt. Yes, is that right, everybody? Absolutely, ma'am. Why not? That is true. So what can I write? What can I write here, bacha log? What can I write? Come on, come on, come on. Anybody who can tell me what is the definition of a double salt? I think I've taught you this enough number of times. Yes. Haven't I taught you this enough number of times? Absolutely. So what do I write? I can write here that when you take a double salt and when you put it in an aqueous solution, or basically when you put it in water, put it in water, what will happen? It will dissociate into its ions. Yes, it will dissociate into ions in solution. Dissociates into ions in solution. Okay? All right. Do you understand this? Yes. Now what will it do? It will also give you test, right? So if you know those flame tests that you do, or the test color test that you do for ions, exactly. So if you do those tests for double salt, you will get a positive test for each and every ion that is present in the double salt. Am I making sense, everyone? Yes. So gives a test for each and every ion. Okay, gives test for each and every ion. Okay, what is the example? Example, my dear students, is your Mohr salt. Mohr's salt. Now, who can tell me the formula of Mohr salt in the chat box, everybody? Yes, Prasad, Harini, can you tell me? Thank you so much, Lily. Thank you so much. Yes. What is the formula for Mohr salt, everyone? Yes. What is the formula for Mohr salt? The formula for Mohr salt is FeSO4. Yes, guys. Anybody in the chat box? Come on. Anybody? Nobody? Anyone who can tell me? Anyone who can tell me? FeSO4, NH42, NH42. Yes. SO4 dot, how many water of crystallization? 6H2O. So let me write that down. Mohr salt formula is FeSO4 NH4 whole twice SO4 dot 6H2O. Okay? So this is the example of double salt. Now the question is, ma'am, then what is a complex or a coordination salt? Okay, what is a complex salt are also called as your coordination salts. Okay, so what is a coordination salt or what is a coordination compound? What is a complex salt, bacha log? Yes, yes. Starting JEE from the scratch. Absolutely right. Dark night. Absolutely. Very good, Navya. Very good. Okay. So what is it? These guys, they do not dissociate in a solution. Yes, what will happen here? They do not dissociate in a solution. Do not dissociate in solution. Does not give test for each and every ion. Okay? All right. And now here what can be the example, everyone? Yes. Here what can be the example? Here the example can be the most famous example that I usually always take is, look at this. Example can be K4FeCN6. Right? So this, does it look simple to you? Does this look simple to you? It does not. Now if you put this compound in water, what will happen, bacha? If you put this compound in water, you know what will happen? You will be able to see K plus ions, and you will be able to see this whole thing that is in the square bracket, FeCN6 minus. This is the ion that you will see. So you will see 4 positive cations and you will see 1 anion. But you will not be able to see this Fe ion. You will not be able to see the Cn minus ion, and hence the difference arises between a double salt and a complex salt. Am I clear with this, everybody? Yes. Hi, Anandu. Yes. Yes. Sangeeta, I don't think that I feel bad, because I guess this is the amount of student that you also used to get in the other channel, right? English has a lesser number of students always, and regarding any other organization, I don't think that who gives you that, I don't know, how do you define it, that ma'am, why here, why not there? Isn't it a personal choice? I mean, why did you join a school like KV or DPS? Why did you do it? And like I told you already that I wanted to start something from scratch. I wanted to build something. So this is again, you know, a good opportunity for me to build something from the scratch. So doing that, guys, doing that. Okay? Yes. Okay, guys. So I hope that this is enough. This is good for you. Okay. Now, guys, let us do one thing. Okay? Let us understand some important terms, because throughout this chapter we will be using this important term. So can we take the example of that coordination compound that I showed it to you? Yes. So let us take the example of K4 Fe CN6. Okay? All right. Can we do this? Acha. Now, you know what is this called as, everyone? What is this called as? Let me show you. This whole thing that you see here, okay, this whole thing that you see, this is called as your coordination entity or coordination sphere. What is it called? This whole thing is called as your coordination entity or coordination sphere. Do you understand? Okay. These things that are outside, everyone, okay? These ones, this particular ion that is outside the square bracket, what is this called as? This is called as your counter ion. What do you call it? Counter ion. This counter ion, it can be positively charged. Sometimes if the counter ion is this side, okay, then what will you call it? It will be negatively charged as well. Okay? All right. This iron that you see right here in the middle, okay, what is this called as? This is called as your central metal atom. What is it called as? This is called as your central metal atom. Okay. Acha, now tell me, iron belongs to which block, bacha log? Yes, if you have studied periodic properties even a little bit, or if you have seen periodic table in your life, then you tell me, bacha, please tell me that where does this belong to? Where does this belong to? Yes. Where does this belong to? You tell me. Which block does it belong to? Does it belong to D block? Yes. And you know that D block elements, they have what? Empty D orbitals. Do you all know that? This has a vacant D orbitals. Am I correct, everyone? Yes, absolutely. Very good. So this has empty D orbitals, and these cyanide ions that you see, these are called as ligands. What are they called as? They are called as ligands. Now, CN, cyanide with cyanide. Acha, chalo, cyanide you forget. Let's say that if I take chlorine or bromine, what do you think? Cl minus, Br minus, F minus. Don't you see these charges? So that means they have some electrons extra. These extra electrons can be donated to the metal atom. Is that right, everyone? Yes. Can it be these ligands, they can donate some electrons to the central metal atom? Yes. And that is how a bond is formed. Yes. And that is how a bond is formed. When the bond is formed, then what will happen? A coordination will exist between them, and this is how you get a coordination compound. Does that make sense to you all? Yes, does that make sense to you all, everybody? Absolutely. Yes, anybody who has a doubt here? Anybody who has a doubt here, guys? Yes? Anybody who has a doubt here? I hope so not. Everybody has understood what is a central metal atom. Everybody has understood what is a ligand. Everybody has understood what is a coordination sphere, what is a coordination entity. Now, let us write down the definitions, everyone. Okay, the definitions I've already written. Otherwise, it will take us a lot of time to write down all the definition. I did not want to spend some time. Nobody is going to ask you definition in your JEE Mains examination. I hope you know that. So, let us just read them through, and I'm going to underline them. Okay? So now look at it. Coordination entity. What do you mean by coordination entity? Coordination entity basically has the central metal atom or the ion which is bonded to a fixed number of ions or molecules. That means if you go back here, this central metal atom with a fixed number of ligand, that much is your coordination entity. Is that correct? Is that correct, everyone? Yes or no? Yes. Is that correct, everybody? Absolutely. Absolutely. So that means that I can write here FeCN6. This much is your what? This is your coordination entity. Great. Okay. Moving on to why did I write coordination entity twice? Yes, why did I write coordination entity twice? It should not be. It should not be coordination entity twice. This should be coordination sphere. Okay? This should be your coordination sphere. Okay. Now, the central metal atom ion and the ligands attached to it are enclosed in a square bracket and is termed as the coordination sphere. That means if I now put it like this, FeCN6, and if you remember, there was a counter ion K4. Instead of writing K4 here, what if I write 4 minus? What if I also put a charge here? Then it will be termed as your what? Then it will be termed as your coordination sphere. So guys, do you all understand this? If you do understand this, can you quickly write EPBT, please? Yes. Yes. Can you all quickly write easy peasy biryani tasty? Everybody has understood what is coordination entity, what is coordination sphere. Bacha, please study it properly, because trust me, there are even questions from here. There are questions from here as well in your JEE Mains. I will show you. I have the questions. Don't worry. Okay? All right, guys. Moving on from here. Now, let's understand. We will continuously use this term called coordination number, coordination number, coordination number. What is a coordination number? Coordination number bole to bacha, did you see the number of ligands attached to it? Yes. K4FeCN6. That means 6 CN, 6 cyanide atoms, 6 cyanide ions were attached to the iron. Iron was the central metal atom. There were cyanide atoms. There were cyanide molecules. Yes, cyanide. 6 of them were there that were attached to the iron. And that, my dear students, the fact that 6 of them were attached to it, that 6 is the coordination number. Similarly, there can be some compounds where only 4 ligands are attached. That 4 will be your coordination number. There is a possibility again that, you know, there is another 4, and that then what happens, the space mein how they are arranged. Okay? Sometimes what happens, it can be 1, 2, 3 and 4. So this will be what? Square planar. Then there is a possibility that 1 is on the top and 3 is at the bottom. Then what will it be? It will be called as tetrahedral. Correct? So this is the spatial arrangement. That also we will come to it. But is this much understood, everybody? Easy peasy biryani tasty coordination number. Do you understand? Yes, what is it? The coordination number of a metal ion. In a complex, it can be defined as the number of ligand donor atoms to which the metal is directly bonded. Gotcha? Clear? Okay. Next is something called as coordination polyhedron. Please understand this. Okay? There is a very little difference. Coordination polyhedron is just what I told you right now. What did I tell you? I just told you about the spatial arrangement. In space, how are they arranged? Hai na? In space, how are they arranged? See, this remote can be on the top. Hai na? This remote can be on the top. This can be right here. Yes, this can be right here. And then right here, this side also there can be some ligand. This side also there can be some ligand. So this will be what? This can be called as tetrahedral, right? And similarly, if I arrange 6 of them like this, then it will be called as octahedral. So octahedral, tetrahedral, square planar, these are called as your coordination polyhedron. The spatial arrangement of the ligand atoms which are directly attached to the central atom. Yes, defines a coordination polyhedron about the central atom. The most common coordination polyhedra are, see, I told you, octahedral, square planar, tetrahedral. These are your what? These are your coordination polyhedron. Understood? Yes or no? Easy peasy biryani tasty. I hope keep writing that, bacha. Acha. Then what happens is there is something called as homoleptic complexes. Bacha, homo means what? What do you mean by homo? Homo means same to same. Correct. So if I write here, once again, taking the same example as FeCN6, okay? Taking the same example of K4 FeCN6. What do you see? This is the same ligand that is attached, right? So if you look at it from the top, you revolve it this way, or you rotate it again, you will see that everywhere you only can see a cyanide as a ligand. So this is your homoleptic complex. But if I write, suppose if I write CN4Cl2, yes, CN4Cl2, then what is it? This is cyanide, this is chlorine, correct? So then what will it be? It will become what? Heteroleptic, because now what is happening? The donor groups are different. Yes, the donor groups have become different. Yes, is that right? Okay. All right. Okay. This much is clear to you all? Okay, chalo, amazing. Now moving on, next. Now let's understand Werner's theory of coordination compounds. So Werner was that guy whom if you find him, just beat him up, but you will not find him. Why? Because he is already dead. So Werner was that person who experimented and he dedicated his life to understand the coordination compound. Yes, poor fellow. He could have done so much, right? Yes, he could have partied, and because of him only now we have to study this one whole chapter. He could have done so much. He could have roamed around. He could have been Columbus and, you know, gone to Sri Lanka or Colombia or, you know, discovered maybe a place. But what did he do? He discovered this. Such a boring guy. Anyway, so Werner, what he did was he proposed certain postulates. Okay? Those postulates we will be reading here. But before reading these postulates, let me tell you, he experimented. Okay? What did he do? He took a series of compounds. What do you mean by series? Bacha, series, you understand, you have learnt about arithmetic progression series. You have learnt about geometric progression series, isn't it? Haven't you learnt about these series in your mathematics? Absolutely. So series means what? 1, 2, 3, 4 is a series. A, B, C, D is a series. 1 square, 2 square, 3 square, 4 square, that will also be a series, right? So he took a series of compounds, and when he studied, he figured out certain things. And what were those things? So let us study about that. So he figured that first thing he said this was that in a coordination compound, the metal shows two type of valences. One, that is your primary valency, and the other one is the secondary valency. So what happens is this secondary valency is actually your coordination number. What is it? The secondary valency is your coordination number. And what is the primary valency, bacha log? The primary valency is actually the oxidation number, or basically the counter ions that are there, no? Yes, what is it? The primary valency is the oxidation number. Or it is the counter ions that are there. So sometimes this is the case. Okay. Then he said that the primary valences, they are normally ionizable. What do you mean by ionizable? That means they dissociate, they break apart. When you put this coordination compound in water, you will see that it is the counter ions that are dissociated from the coordination sphere, and they give you test in the solutions as well. Do you understand? Yes. Okay. All right. And how are they satisfied? They are satisfied by the negative ions. Okay. Now, third point mein, Werner said that the secondary valences are non-ionizable. That means, as I told you, whatever is inside that square bracket, that you will not be able to break it down. FeCN6, I'm taking the same example again and again so that it just fits in your mind and you will be able to understand it. Yes, even in the exam hall, you should remember that K4FeCN6, K4FeCN6. So the FeCN6 that is inside the bracket, that is not ionizable. Iron and cyanide will not be showing their true colors in the solution. They are non-ionizable, they do not dissociate. And how is this satisfied? This is satisfied by sometimes neutral molecules. Yes, Cn is a negatively charged, but H2O, water, NH3, these are neutral molecules. Okay? So by neutral molecules or by negative ions, the secondary valency is equal to the coordination number, and it is fixed for a metal. So a metal can have a fixed number of coordination number. Darshan, there will be mathematics teacher also. Don't disturb the chemistry class. Mathematics teacher will be coming very soon and will be launched. So currently think that your mathematics teacher is a rocket because he or she is about to get launched. Okay. All right, fourth point everybody is that the ions or the groups that are bound by the secondary linkages to the metal, they will have characteristic spatial arrangement. That means in the space they will have a particular shape, they will have a particular spatial arrangement. And what are those spatial arrangement everybody? Just some time back only I told you, yes everybody, what was it? Octahedral, tetrahedral, square planar. Haven't I told you? I have told you. So come back everybody, focus here. Yes, corresponding to different coordination numbers. So this octahedral, tetrahedral, square planar, this spatial arrangement, what does it depend on? It depends on your coordination number. If it is 6, it has to be octahedral. If it is 4, it can be tetrahedral or it can be square planar. Guys, is this clear? Everybody, can I have some EPBT in the chat box? Can I have some EPBT in the chat box? Come on guys, everybody, let me know. ठीक है कि नहीं है? ठीक है कि नहीं है? ठीक है कि नहीं है? Yes or no? Acha. Now let me also teach you, okay? Let me also teach you before this everybody. Suppose you have to draw the structure. ठीक है? Suppose you have to draw the structure of a coordination compound. Let's say that you have CO NH3, okay? Let's say that you have CONH3 6 Cl3. How are you going to draw the structure of this? So chalo, let's learn it, okay? How are you going to draw it? You are going to draw it like this. This is your CO. Okay? After this, now what are we going to do is take a look at it, okay? For Cl, I can draw it like this. Here one Cl, here one Cl, and here one Cl. So this is your, what does this become? Yes, this becomes your spatial arrangement. This becomes your coordination polyhedra. Understood everybody? Yes or no, bacha log? Understood everybody? Yes guys, everybody is clear with it how to draw this. So this is your coordination compound and I just showed you one example how to draw the structure. Clear hai? Nahi hai? Yes, everybody is clear with it or not? Acha guys, I hope that you all are liking it. Very good. Thank you so much. Everybody should like the session. Huh? Hit your attendance. Please show me that you guys are attending my sessions. Otherwise, what is the point of me taking a 6-hour session? Huh? Hello, Pasanglas. Hello, Pasanglas. Show me your attendance. Chalo. Acha. Now the next topic, everybody. So from here, NTA may ask you question, bacha log. So please pay attention here. Yes, Werner say na. Everybody, pay attention. This is a topic from where NTA can ask you a question. ठीक है? What is it? Reaction with excess AgNO3. ठीक है? What is it? Reaction with excess AgNO3. So suppose you have a compound. Okay, the compound is here. Okay, this is inside the square bracket, and outside right here you have some Cl minus ion. ठीक है? अच्छा. So this compound, when you make it react with excess amount of AgNO3, what will happen? What is it that you will be getting? What is it that you will be getting? Acha, now instead of writing it like this, one second, huh? Instead of writing it like this, let me write X amount of Cl minus. What is the product that you will be getting? Don't you think that the product that you will be getting will be X amount of AgCl? Is that right, everybody? Yes, is that right, everyone? Absolutely. And what is this AgCl, bacha? This AgCl will show you a white color PPT. What PPT? This PPT? No. What PPT? Precipitate. Here, what will you get, everyone? What will you get here? This AgCl, this will show you a white precipitate. Correct? Aita? This much you understand? चलो, okay? अरे बाबा, math faculty will come, maths teacher will come, don't worry about it. He or she is about to join, he or she will get launched. So right now, imagine that your maths faculty is a rocket. This rocket is going to, this rocket will be joining and will get launched very soon. And I promise you that you will fall in love with him or her. ठीक है? All right, but till then you can keep guessing. In fact, you can just look at the banner of this and keep guessing. Keep guessing. ठीक है? You will get some hint from there also. You will get some hint from there. ठीक है? अच्छा. Now suppose, let me take an example only, okay? Let me take an example, everyone. What example shall I take? What example shall I take, everybody? Let us take that. I showed you the example of CO NH3 5 Cl. ठीक है? Can I take like this? Okay. And let's say that Cl2 is outside. ठीक है? Now what if I treat this with excess AgNO3? If I do this, then what is the amount of AgCl that I will be getting? You tell me in the chat box. Ha baba, organic chemistry also there will be there. Don't worry about it. Yes, I'm starting with the high weightage chapters, and as and when we keep going down, we will go down with the lower and lower weightage. So as I told you, coordination compound first, then I will do DNF block, then I will do haloalkanes and haloarenes, because you have been asking me about that chapter for a very long time. I will do that. After that, we will do again periodic properties and P block. After that, I will do another organic session again. That will mostly be GOC. ठीक है? Yeah. So I will do it. Don't worry. Don't worry. Pakka promise. I told you, no? This year I'm there with you. I'm here. See? Not leaving anywhere. Ha. Now tell me in the chat box, everyone, what is the product that you are thinking to get? What product will you get, everyone? Yes. Do you all agree with me if I write here 2 AgCl? 2 AgCl will come out as white precipitate. Is that right, everybody? Will you get 2 AgCl? Acha, theek hai. Now, by chance, suppose NTA asks you, what if NTA asks you, theek hai? The question that NTA is asking you is fraction of Cl precipitate. What if they ask you fraction of Cl precipitate? You tell me. How many chlorine atoms are there? There are 3. So what will be the fraction of chlorine precipitate? You can write 2/3 Cl. 2/3 fraction of Cl you write. ठीक है? 2/3. What did I say? 2/3 fraction of Cl. Fraction of chlorine precipitate. Understood? Yes? Do you guys understand? Yes or no, everyone? This much is clear? Chalo, let's move on. Okay, chalo, let's move on. Acha. Now, let's understand electrical conductance. After that, we will solve some examples also. Okay? Let's understand electrical conductance. Acha. Now, let me give you one question and you are going to solve it. The question, everybody, again, I'm taking the same example, that is that cobalt coordinate complex. Okay? You tell me that if I take CO NH3 whole 6, and here if I take Cl3, yes, all right. Now you tell me, when you put this in water, how many ions are you expecting, bacha? How many ions are you expecting? Yes, how many ions are you expecting, guys? Come on. How many ions? I think you all will agree. You all will agree if I tell you that, bache, there will be one ion like this, CO NH3 6. This is positive. Plus there will be 3 Cl minus. Yes, is this right? So that means this is your one ion. This is one ion, and here there are 3 ions. Is that clear? So altogether, how many ions are there? There are 4 ions here. Okay? Yes. There are 4 ions here. Ma'am, Ag product में कैसे आया? Very good question. बच्चे, Ag यहाँ लिया ना आपने? Haven't you taken AgNO3? You have taken silver nitrate ना? तो this silver nitrate, when it is reacting here, तो silver has a tendency to form AgCl. Silver has a tendency to react with Cl and form AgCl. तो NO3 will come outside the coordination sphere. समझे बच्चे? Athar Pruthi, now do you understand Ag product में कैसे आया? Here you have taken na excess of AgNO3. So this Ag will react with this Cl and it will come as AgCl. Gotcha? Clear hai? EPBT? Chalo. Now, electrical conductance we are understanding. Okay? So how many total number of ions are here? How many total number of ions बच्चे? 4. Very good. ठीक है. Next question everybody. Let me ask you another question. You are going to tell me. ठीक है. Let me ask you another question. Another question everybody. Please take a look at it. हाँ. Now see what is happening. If I take CO, NH35, Cl, and here you have Cl2. हाँ. Now tell me how many number of ions will you get? How many ions will you get? Tell me if I am right or wrong. Will this be correct? CO, NH35, Cl here, and plus you will be getting 2Cl minus. So total how many ions are there, bache? Total how many ions are there? This is your 1 ion, है ना? And this here there are 2 ions. Is that right? So total how many ions are there? Total how many ions you are getting? Total you are getting 1 plus 2, 3. 3 ions. Total 3 ions here. Total ions, how much are you getting here? Total here you have 4 ions. ठीक है? अच्छा. Just for example, I will take another one. Just for example, I will take another one, everybody. You tell me. Last one. ठीक है? Last one, everyone. Yes. Last one, everybody. Take a look at it. ठीक है? So here what do you have? Let's say that you have CO, NH3, 4, Cl2 inside, 1 Cl here. Now tell me how many ions are you thinking? How many ions will you be getting here? Here tell me, will you be getting CO, NH3 whole 4, Cl2 here, plus 1 Cl minus. Now tell me how many ions are here, bacha log? How many ions are you getting? So this is your 1 ion and this is another 1 ion. है ना? तो total how many ions बच्चा लोग? Total how many ions are you getting? Total only 2 ions. अच्छा. Now if I ask you, out of these 3 compounds, which one has more electrical conductance? What is it that you're going to tell me? Out of these 3 compounds, which one has higher electrical conductance? You tell me, will your answer be, is your answer going to be that, ma'am, one will have higher conductance, then the second one, and then the third one? Third one will have the least conductance. Why? Because you only have 2 ions here. More is the number of ions, more is the electrical conductance. That is something that we all know. The number of ions is directly proportional to the electrical conductance. Is that right? And that, my dear student, was exactly the experiment that was conducted by Werner. Is that right? Now take a look at it. So this is the experiment that was conducted by Werner, and he told us that, look at this. So this will be your 1:3 electrolyte. Which one is 1:3 electrolyte? Bache, 1:3 electrolyte. What is this? This is your 1:2 electrolyte. What is this? This is 1:1 electrolyte. Correct? Yes. Now, you notice that here you have a green color and here you have a violet color. What does it mean? That means that one of them is cis, one of them is trans. Okay? So, because of cis and trans, here you get 2 different color. Otherwise, there is nothing that you have to learn here. So, guys, quickly tell me, easy peasy biryani tasty, yes or no? Is this much clear to you all? So till now, what are the things that you have understood, everybody? Till now, what is it that we have understood? Till now, we have understood the difference between double salt and complex salt. Till now, we have understood Werner's theory, and we have understood what? We have understood. What is it that we have understood, bacha log? Electrical conductance, primary valency, secondary valency, all of this we have understood. Correct? Yes or no? Acha. Now, fatafat say, let's do one thing. Let us go to the last slide. Let us go to the last slide, and I'm going to start giving you the, I will also give you the mind map of this. Okay? Let me give you the mind map of this. So what is this? This chapter is your coordination compound. This is your coordination compound. You will notice that once this is it. Yes, the first thing that we have understood today is, double salt versus complex salt. ठीक है? Yes, and in this case, what is it that you have understood? In this case, you have understood that double salt, what do they do? Completely ionizes. Okay? And what about complex salt? Does not ionize completely. Okay? This much is understood, everybody? Yes? Okay. How long is the lecture going to be? 5 to 6 hours at least. Okay? Acha. Next, everybody, what is it that we have understood? Next is your Werner's theory. What did we understand in Werner's theory? Primary and secondary valencies of metals. Okay? Once again, primary is ionizable. And what about the secondary? Non-ionizable. This much is understood, everybody? Yes. After this, okay? Huh? When? Mohammed Ashik, what are you saying? When did I say anything bad about it? When did I say anything bad about it? I did not say anything bad about it. I said that I wanted to start something from the scratch. No gossip, nothing else, bacha log. No gossip, nothing you are getting. Okay. Next, what did we study? We also understood what? Electrical conductance and reaction with excess AgNO3. Okay? Reaction with excess AgNO3 and electrical conductance. ठीक है? So these are the topics that we have. These are the topics that we have covered. Is that right, everyone? Yes. So this is your mind map. We are also making mind map all together. ठीक है बच्चा लोग. Now let us go back and let us understand our topics. You see, I also have a lot of questions that I'm going to do today. ठीक है? I do have a lot of questions. So chalo. First question, everyone. The first question, everybody, is the secondary valency and the number of hydrogen bonded water molecule in copper sulfate dot 5H2O respectively are. So bacha log, if there are 5H2O, you tell me what do you think is going to be the answer here? Yes. Thank you so much. Hi Shri Ram Selva, how are you bacha? Yes, thank you so much. Thank you so much for all the support bacha log. You guys are the best. Yeah, tell me what is going to happen here. Hanji, yes, CuSO4 dot 5H2O. How are we going to solve this? How are we going to solve this bacha log? So, see, if you have, 1 second. CuSO4 है ना dot 5H2O. अच्छा, this can be written as CuSO4. Let's take it inside, है ना. These 5H2, out of the 5H2, I think I can take 4H2O inside. Is that right? If I take H2O 4 inside, write it like this, and then 1 H2O is outside. So 4 H2O plus this SO4 will have 2 oxygen that will act as the donor site. Yes, 2 oxygen will act as a donor site. So what will happen? 4 and 1 of these, but this will have 2 donor site. This will have 2 donor site. Is that right, everyone? Yes. Is that right, everyone? So what will be the secondary valency, bacha log? What will be the secondary valency? Acha, 1 second. No. Let's not do that. No. No, mistake happened. Mistake happened. No, mistake happened. What we can do is CuSO4.5H2O. We have to write it as Cu. Let's take H2O inside 4H2O, and we will take SO4 dot H2O. Ha! This is what will happen. This is what will happen. This SO4 and this H2O, this will be your primary valency. This will ionize, and here H2O4. So I think that this is the correct answer. Is that right? 4 and 1, will it be? Yes. 4 and 1 secondary valency. This is your secondary valency. That means this is equal to your coordination number. Yes. And the number of hydrogen bonded water molecule. Hydrogen bonded water molecule. Yes, 4 and 1. Option B is the correct answer. Nare, Vinny, check again, no? Check again. Check again. The secondary valency is going to be equal to 4, and hydrogen bonded per molecule, that will be this one. So it will be 1. 4 and 1 will be the correct answer. Yes? 4 and 1 I think will be the correct answer. You tell me, bacha log. You tell me. Come on, come on, come on. Bacha, then chemistry you will have to make it strong, no? At least physics and chemistry, if it is strong, then mathematics, even if you do 50% of the paper, there are chances that you will be able to clear it. 2 subjects you will have to make it strong, bacha. Okay? Yes, guys, this is clear. All right, this is clear. Did some mistake. Yes, so did I. So did I, but no problem. This is clear, everyone. Yes, this is clear. Chalo re. Next question, everyone. Can we do it? Next question, everybody. Okay, next question. Let us take a look at the next question. Oh, 4 and 1 is the correct answer. Huh? Next question is on treatment of, okay, on treatment of 100 milliliter of 0.1 molar solution of COCl3.6H2O with excess AgNO3, 1.2 into 10 to the power 22 ions are precipitated. The complex is, acha, in this basically what we have to do is, okay, in this basically we have to use a little bit concept from the mole concept chapter also. So first of all, let us do one thing. Let us find out the moles of the complex. Can we do this? Yes. Let us find out the moles of complex. So who can tell me how to find out moles of complex? Who can tell me how to find out moles of complex, everybody? How do you find moles? How do you find moles? Molarity multiplied with volume divided by 1000. Does that work? Molarity multiplied with, yes, multiplied with, what did I say? Multiplied with volume divided by 1000. If I do this, what is the molarity? It is given to you 0.1 molar multiplied with, where is the volume? The volume is also given, bacha log, 100 milliliter it is given, isn't it? 100 milliliter. So 100 divided by 1000 if I do, then can you calculate? 100 and this 0 will go on. 0.1 divided by 10 will be how much? 0.1 divided by 10 will be how much? 0.01 mole. 0.01 mole, is that correct? Yes, this is correct. Hai na? This is correct. Acha. Now, what is the question asking? The question is asking on treatment of 100 milliliter of 0.01 molar solution of COCl3.6H2O with excess AgNO3, 1.2 into 10 to the power 22 ions are precipitated. Acha, precipitated. What is the complex? Ha. So next step will be what, guys? Come on, answer me in the chat box. What will be your next step, bacha log? Moles of ions precipitated with excess AgNO3, hai na? So, moles of ions precipitated with excess AgNO3. How are you going to calculate? Sometime back only we have done this, bacha log. Yes. Sometime back only we have to put it inside. Bacha, Athar, I will tell you. Nomenclature also I will tell you. Don't worry, I still haven't told you. Okay? To see what is it given? It is given to you as 1.2 into 10 to the power 22 divided by Avogadro number. Can I do? Can I do Avogadro number, which is what? 6.023 into 10 to the power 23, or what? 10 to the power 23. Yes. So if you calculate, how many moles will you get? If you calculate this, how many moles will you get, bacha log? How many moles will you get? I think you will all agree with me that if I tell you, it will be 0.02 mole. Yes. 0.02 mole hai ki nahi? Yes. Acha. So that means now what is it that you are getting, bacha log? Tell me guys, now what is it that you will have to do? So you have 0.01 and here you have 0.02, correct? Yes. So can I take it as, so 0.01 multiplied with n will be equal to 0.02. That means that n is equal to how much? N will be equal to how much? 0.02 divided by 0.01. If you do kata putti, then what will you get? You will be getting 2 only, correct? Will you be all getting 2? Yes. So that means if I'm getting 2, that means I'm supposed to have 2 Cl minus outside, right? I should be getting 2 Cl minus outside. Is that right, everyone? Acha. So if there are 2 Cl minus guys in the chat box, everyone, yes. This you can also. Thank you so much, Yashna. I miss you too, bacha. But you can come here. What happens? Life only moves forward. Okay? Life only moves forward, bacha. Look, so don't say all these things. Just study, everyone. Yes. So 2 Cl minus will have to be present in the what? Will have to be present outside the bracket. So that means, which one is the correct answer? Where do you have 2 Cl minus outside? Here you have Cl3 inside, Cl3 outside, not possible. Here you have 2 Cl outside. So option C should be your correct answer. But chalo, quickly check it. Quickly, can you all please check it? And tell me if this is the correct answer. Quickly, please check it out. Till then, I will drink some water. By the way, Tank is not present here. I have come to Jaipur. I'm taking this class from Jaipur, Rajasthan. Yes, ma'am is in Rajasthan right now. Ma'am will go back to Bangalore on Thursday, bacha log. So after Thursday, you will be able to see the Tank. So I'm in the Rankplus office and I'm taking this class from the office. ठीक है? हाँ. So that is why Tank is not present. You guys must be missing Tank also, no? Tank also you guys must be missing, isn't it? Thanks, bacha. Thank you, Vinay. Yes, everybody, this is all clear? Yes, thank you, Bhumika. Thank you so much. So, chalo guys, moving on to the next question. See, coordination sphere, coordination entity, ionization sphere. Sorry, Werner's theory, primary valency, secondary valency. From here only, I'm giving you so many questions. Next question, bache. Next question is, which of the following complexes will consume more equivalence of aqueous solution of AgNO3? Baapre, what a tough question. My God, my students will not be able to face this problem only at all, hai na? Huh? Face this problem only at all. You tell me, bacha. Just now only, some time back we have solved this. Oh, ma'am, camel is right below the office only. Today I will go to the hotel room on camel's back only, huh? It's not that stereotyped also, yeah. To find the camel, you have to go to the desert. Jaipur is like a city. It's like Bangalore, it's like Chennai, it's like Trichy, Madurai. It's the same city only, okay? To find a camel, you have to go to that Thar desert. That is in Jaisalmer, Bikaner. Everybody, you guys know, no? Durgesh ma'am is from Bikaner. So if you go near her hometown, then maybe you will be able to find some camels. The camels, they live in sand dunes. No, they don't stay in the city. Okay. You are new. Yes, you will be able to crack. Okay, guys, tell me. This too, you should be able to just see the question and I think that you will be able to answer. Look at this. AgNO3. Which one will be able to consume the most amount of AgNO3? That particular compound which has more number of Cl ions outside the coordination sphere, that will be able to consume more number of silver nitrate, isn't it? Yes. So here you have Cl6, all the chlorine is inside the sphere. Then how will it consume? This will not be able to consume. Okay. Here you have only 2 Cl. Okay. Here you have what? Here what do you have? Here you have Cl3. Okay, here you have Cl5 inside. So no, this and this cancel it out. Okay, this and this you cancel it out. All right, out of this two, obviously this will be consuming more, है ना? Out of this two, obviously option C will be consuming more number of silver nitrate to give you AgCl more. Clear है बच्चा पार्टी? Everybody clear है? Yes or no? Yes or no? Yes, yes. No, no. Everybody is clear? Alrighty, let us go to the next question. The next question is, everyone, the next question is, which of the following are examples of double salt? Okay, you tell me, bacha. Which of the following is the example of double salt? Bro, isn't this the more salt? This is the more salt. I gave you the example of it. This is your more salt. CuSO4.4NH3. No, this will be a complex salt. This will be a complex salt. है ना? ठीक है. K2SO4.Al2SO4 whole thrice 24H2O. What is this? This is called as potash alum. This is called as potash alum. This is also a double salt. FeCN2 4KCN. Baba, this is your complex salt. I kept giving you the same example. K4 FeCN6, K4 FeCN6. So what is the correct answer? Your correct answer is option D, A and C only. Option D for dum biryani is the correct answer. Correct? Aita? Everybody? Yes? Clear hai? No doubt, I hope. Perhaps no doubt. Perhaps no doubt. Yes? All of you are clear with it? Any doubt here? Any doubt here? No doubt here. Come on. Yo guys, are you all here or not here? Where is everybody going? C is correct. Okay, D is correct. ठीक है. Next question. Shall we do the next question, everyone? Okay. Huh. Next question is what? An octahedral complex with the formula COCl3.NNH3 upon reaction with excess AgNO3 solution gives 2 moles of AgCl. Acha. Octahedral complex it is saying, है ना? It is saying octahedral complex. So, bacha, if it is octahedral complex, you know what is given to you? There is n number of NH3. So, NH3 has to come out. 2 moles of AgCl you are getting. 2 moles of AgCl you are getting. That means whatever it is, 2Cl is outside. ठीक है? 2Cl is outside. That is why you are getting 2 AgCl. Acha. Now what are they saying? There are only 3 Cl. So 1 Cl will be inside. And for it to be octahedral complex, bacha, how many NH3 will have to be inside? Do you all agree that NH3 5? NH3 whole 5, 1 Cl inside, 2 Cl outside only, then you will be getting 2 AgCl. Acha. Now what are they saying? Upon reaction with AgNO3 gives 2 moles of AgCl. Consider the oxidation state of cobalt in the complex is X. Okay. So N we have just calculated 5. Now we have to find the oxidation state of cobalt. How do you calculate oxidation state, bacha log? Yes? Huh? 0.01 and कैसे करे? System hanger, bacha, I have told you, no? Haven't I taught you? 0.01 N you have to find out. Arey baba. Now you have to get to some basic concepts of chemistry also. First chapter I have to teach you or what? Huh? We have to go back to the first chapter or what, bacha log? Okay. Ha. Chalo. Love Jen, you see me dancing or what? You see me dancing? आपके मम्मी पापा यही सिखा रहे हैं आपको घर पे ना? चलो कोई बात नहीं, ठीक है. तो n is equal to 5. Now let us find out the oxidation state, बच्चा. ठीक है? तो for oxidation state, what you do know? You have to find the oxidation state of the metal. So what will you write? You will write here X. Now NH3 is actually a neutral ligand. I'm telling you this, that it is a neutral ligand. As we move forward, I will tell you the classification of ligand as well. ठीक है? I will hi Dharaneshwaran. Hi, hello bacha, welcome to the session. Yes, I'll tell you the classification of ligand also. But right now understand that this is a neutral ligand. So 5 multiplied with 0 plus you will write here -1 is equal to, see, if this is 2, so this will be 2Cl minus, that means here there will be +2, is that correct? Yes. So here you will write +2. Okay. Now if you calculate for x, so what will it be? X plus 5 zeros are 0, -1 is equal to +2. That means that x is equal to this -1 will go here, so it will become +3. Is that right? Now in the question, what are they asking? They are asking the value of x plus n. So x is a +3 plus what is n? N is equal to 5. So that means that it is equal to 8. Is that right? 8 is the correct answer. So that means option number D is the correct answer. है ना? Thank you, Abdul. Thank you so much, bacha. Yes. Thank you so much, bacha log. Thank you so much. Yes, guys. Is this the correct answer? Yes, Ria. Do we all see? 8 is the correct answer. Option D is your correct answer. Correct? Yes or no? Yes or no, everyone? ठीक है, चलो. Now, let us move forward. Now, let us move forward, everyone, and let us understand what the next topic. What is our next topic, everybody? What is our next topic? Our next topic is a classification of ligands. So, yes, now we are going to understand classification of ligands. ठीक है? Acha. When it comes to ligands, ligands can be broadly classified. That means on a very big scale. On a large scale, you can divide them into two categories. ठीक है? What are those two categories? What are those two categories? Yes. Number one category is on the basis of charge. On the basis of charge, then they become, on the basis of charge, you will have anionic ligands. Anionic ligands. You will have cationic ligands. ठीक है? And you will also have neutral ligands. ठीक है ना? You will also have neutral ligands. क्या बात है? ठीक है. On the basis of denticity, on the basis of denticity बोले तो dent से what do you remember बच्चा? Dent से you sort of remember dental, isn't it? Like your teeth, correct? Yes. So let's say that what if I remember that meme. You know, there is a meme where there is one fellow who has only one teeth. How will he be able to chew? Huh? If you ask that uncle to chew, how will that uncle chew? That uncle will chew with only one teeth, no? With only one teeth. So that means that what is he? He is monodentate. He has only one teeth. Only one teeth to chew the food that he is eating. So what happens? On the basis of denticity, you can say that he is going to be monodentate. Monodentate. Acha. Now, suppose, you know, another uncle is there. That uncle has only one teeth on the top and the other teeth is in the, you know, the bottom jaw. So what will you call him? You will have to call him bidentate. Is that right? Yes. So there will be bidentate also. Hai na? There will be bidentate also. Acha. Now, suppose somebody has only 3 teeth. With only 3 teeth they can chew. Then what will you call them? You will have to call them tridentate. Correct? Acha. Yes, and similarly it goes on. Then it goes on to tetradentate, pentadentate, hexadentate, or you can just say that, you can just call them as polydentate. What can you call them? You're going to call them polydentate. ठीक है बच्चे? Yes, this is going to be enough for JEE Mains. Pakka promise. Yes. ठीक है? This much is understood. So this is the classification of ligands. So chalo, now let us understand this in detail. Okay. Now, on the basis of charge, what did I tell you? On the basis of charge, you have neutral ligand, you have anionic ligands which are negatively charged, and you have cationic ligands which are positively charged. So, let us take a look at some of the examples. Neutral ligands. Which ones are neutral ligands? Bacha, neutral ligands are your water, H2O. You have NH3. Yes. Then what else do you have? What else do you have? You have CH3, NH2. Okay. You have CH3, NH2. This is a neutral ligand. Okay. Then what else do you have? You also have CH2, NH2. This is also a neutral ligand. Is that right? Okay. Then you have PPH3 and etc. Okay. These are all your neutral ligand. Cool hai? Yes or no, everyone? Okay, moving on, everyone. Now, let us take a look at positive ligand. What are these positive ligands? These positive ligands are also called as cationic ligands. What you call them? You call them as cationic ligands. So which ones are cationic ligands? Cationic ligands, you have very little cationic ligands. Okay? You do not have many cationic ligands. So cationic ligands may you have nitronium. Yes, what do you have? You have nitronium NO2 plus. This is called as nitronium. Okay? What else do you have? You also have something like this. This also has a positive charge. Okay? So this is also a cationic ligands. Apart from that, I think there is another one. Do you all remember? NO plus. NO plus, this is also a cationic ligand. But what happens is, hi spread right, how are you bacha? Yes, pyridine also, yes. Hanji, okay. Now let's come to the negative ligand. Which ones are the negative ligands? The negative ligands, you will find out that they are called as your anionic ligands. Anionic ligands. Okay. Acha, these guys, they are in a lot of amount. That means these guys are found in abundance. So the anionic ligands, you will see that Cl minus, Br minus, F minus, I minus, Cn minus, C2O4, 2 minus. है ना? So these are all your anionic ligands. SO4, 2 minus. ठीक है, etc. These are your negative ligands. ठीक है? Okay? Yes. Arey, what break bacha? It's only 6:11. I'll give you a break at around 7:30, not right now. ठीक है? I'll give you a break around 7:30, not right now. ठीक है? हाँ. So this much is done. अच्छा. Now let's understand on the basis of denticity. Monodentate. Everybody, did you all understand monodentate? What is monodentate? हाँ. Aman Khan. Hey, don't spam. चुप हो जा. चुप हो जा. No break, not right now. SCN minus also, yes. Acha, हाँ. Now on the basis of denticity, you have monodentate. So monodentate is what? Monodentate is when a ligand is able to ligate through one donor site. Okay? What do you say? You say that when a ligand is able to ligate through one donor site only. They are called as monodentate ligand. ठीक है? Example, anybody? Yes? You don't understand. Ankita, what is it that you don't understand, Ankita? If you suddenly come in the class, then obviously you will not understand, no? Yes. Ankita, very bad lecture. I don't understand. I'm pretty sure somebody has sent you here. But yes, please tell me what is it that you don't understand. Let me ask you, let me cross question you, and I know that you have nothing to say. Yes, what is it that you don't understand? For a fact, I know that somebody has sent you. चलो कोई बात नहीं ठीक है हाँ when a ligand is or see ligate through I can also say that it is bound to the metal for example everyone that imagine if this is the metal है ना this is the metal so this side I am holding on to the metal with a ligand and this side also I am holding on to the metal so if I hold it like this see I am only holding it with one finger है ना everybody can you all see that I'm only holding it with one finger. So if I do this, that means that what is this? This is your monodentate. Yes, only with one finger. That is called as your monodentate ligand. Okay? It is bound with, okay? It is bound with only one donor site. Examples, everybody. What are the examples, bachche log? The examples are NH3, H2O. Okay, what else? Any other example? Yes, there are plenty. You have Cl minus, F minus, Br minus. Any other example? Anybody can think of any other example? Yes. NO plus. What else? PPH3. These are all your monodentate ligand. ठीक है? These are all your monodentate ligand. Got it? Yes. Very good. Thank you so much, Kunal. Thank you so much, bacha. Chalo, moving on to the next one. Next one is your bidentate. Look at this, bacha. Look at this. So this is one donor site, है ना? This oxygen is one donor site. This oxygen is also one donor site. That means that suppose you have, this is the metal, okay? If this metal I hold with these two fingers like this, okay? And this side also if I hold it like this, then what is happening? Look at this. Look at this. Does it look like it is called bidentate? Look at this. I'm holding this metal with two fingers. So this will be called as your bidentate ligand. ठीक है? Yes, oxalato is a bidentate ligand. So that means what can be the definition? The definition can be when a ligand can bind through two donor atoms. Yes, what is bidentate? What is bidentate? When a ligand can ठीक है? It is called as bidentate. Okay? All right. ठीक है बच्चा लोग. चलो guys, moving on. Here, look at this. This is your ethylene diamine. So ethylene diamine, here you see this nitrogen and this nitrogen. Or suppose if I want to write it better, I can also write it as this. Okay? CH2, CH2, and here you have NH2, NH2. ठीक है? तो this nitrogen and this nitrogen, these guys will be holding on to the metal like this. This is called as, in short form, it is also written as En. Okay? En is basically your ethylene diamine. Okay? What is it? This is called as ethylene diamine. All right, bacha log? Yes. So these are all, both of these are your what? Bidentate ligand. Cool hai everybody? Do you all understand this? Do you all understand this, everyone? ठीक है. So now everybody has understood that what is denticity. Monodentate you have understood. Bidentate you have understood. Chalo, moving on. Now you have tridentate. Tridentate में what will happen? Look at the donor side. This nitrogen is a donor side. This is also a donor side. This is also a donor side. So from three sides you can hold on to the metal. The metal is here. So this is your diethylene triamine. The short form is written as a diene. Now if you have tetradentate, so you have one donor side here, one donor side here, one donor side here, and another donor side here. So that means the metal is right here. This is your triethylene tetraamine. It is called as triene. Yes, everybody, are we all able to understand this? Are we all able to understand this? Very good. Chalo, moving on. Next is your pentadentate. In pentadentate, you will see that this is one donor side. This nitrogen is a donor side here. This oxygen, and this oxygen is also a donor side. So right here you will find the metal. This is your EDTA. But everybody pay attention. EDTA. Okay, there are two types. EDTA. 3- is a pentadentate. 3- is a pentadentate. If you write here EDTA 4-, if you write 4-, then it is going to be hexadentate. So look at the structure carefully, bacha. Look at the structures carefully. You will notice that only one side ka donor atom is not there. Yes, what will you notice? You will notice that only one side ka donor atom is not here. Okay? See, right here. Here see 1, 2, 3, 4, 5, 6 hexadentate. 1, 2, 3, 4, 5 and 6. Yes, 4 oxygen, 2 nitrogen. 4 oxygen, 2 nitrogen are the donor site in the hexadentate EDTA 4-. But here if you see, you have 1, 2, 3. 3 oxygen, 2 nitrogen. Once again, here you have 3 oxygen, 2 nitrogen is your donor site. Here what do you have? Here you have 4 oxygen and 2 nitrogen. This is your donor site, everybody. So altogether this is hexadentate. This is pentadentate. Guys, are we all clear? Hi Aerospace IITN. How are you, bacha? Welcome to the class. Super happy to see you, and thank you so much, Amana. Thank you so much. Thank you so much. You guys are the sweetest for supporting me. Thank you so much. You know, without you, I wouldn't have been able to do this. Without you, I don't think I would have the confidence to start a new channel, to start my career from the scratch again. And all of it is only because of you. So thank you so much. Super proud of you, everybody. Okay, so guys, everybody, this is something that we understand. Yes, EDTA 4 minus hexadentate, EDTA 3 minus pentadentate. In EDTA 3 minus, that is pentadentate, you have 3 oxygen, 2 nitrogen. Here you have 4 oxygen, 2 nitrogen. This is your donor site. Clear? EPBT, easy peasy biryani tasty, everybody? Yes? Acha. Now, let us come to something that is called as ambidentate ligand. Ambidentate ligand, I always give you the same example, everyone. Do you remember 3 idiots? Yes? Do you remember 3 idiots? There was that Professor Virus professor, you remember? Professor Virus, do you remember that he could write with both his hands? Yes? He could write with both his hands. Do you all remember? He could write with this hand and he could also write with this hand. See, I could also write and write. So what am I? I am going to be what? I am your ambidextrous. Am I? No, actually no. My left hand does not really work so much. But you see, this is with my left hand, this is with my right hand. So if I happen to do this, then what will you call me? You will call me ambidextrous. Ambidextrous, yes. So or you must have heard, no, some people will say that I'm an introvert also, I'm an extrovert also, I'm really ambivert. What does ambivert means? That means they're both. They can be extrovert, they can be introvert also. So when the word ambi comes, that means that here the ligand has this hand that can be donor side, this hand that can be donor side. So if let's say that you are a metal, and you tell me that, ma'am, I need some electrons, ma'am. So I'll be like, beta, I have electrons here also, I have electrons here also. Which one do you want? Yes, which one do you want? Now suppose Aman asks me that, ma'am, I want I want electrons from the donor side. So I'll be like, yeah, take. Yes. Now suppose after some time Vinny is asking me, ma'am, electrons, ma'am. Now this time I'm giving you this. So this is basically situation based. Yes, this is basically situation based. Okay. Sometimes they can donate through this side, sometimes they can donate through that side, and these guys are called as your ambidentate. Acha, now removing this, everyone, removing this, what are the examples? Examples are, look at this, SCN minus. So that means this nitrogen is holding on to the metal like this, okay? Or it is also possible that you can write it as NCS minus. That means the metal is being held by the sulfur side. This is also possible. Acha, now another one, everyone. Yes. Another one, everyone. Yes. Everybody. Now look at this. Look at this. Now suppose you have NO2. This nitrogen, let's say, is holding on to the metal. Or it is also possible to write it as ONO. That means this oxygen is holding on to the metal. Is that right? So these are the examples of your ambidentate ligand. Guys, can I get some easy peasy biryani tasty, everyone? Can I get some easy peasy biryani tasty, everybody? Yes or no? Yes or no, guys? Yes or no? Everybody is understanding? Easy peasy biryani tasty. Yes. Okay. Chalo. Moving on to the next, guys. Okay, ambidentate we have understood. Acha, after ambidentate, now there is another one that is called as flexidentate. What is this flexidentate? Basically flexible hai. These are flexible. The flexidentate ligand, now they are samay pe. That means based on situation, sometimes they can act like they are monodentate and sometimes they act like they are bidentate. Example, let me give you example, everyone. Let me give you an example of a flexidentate ligand. ठीक है? तो flexidentate में no, you will see flexidentate में suppose you have CO, Cl, ठीक है? Suppose you have CO, Cl5, SO4, ठीक है? CO, Cl5, SO4. Here, what was the charge? What will be the charge? what will be the charge? Let's say that it is going to be 4 minus. Now this time if I write CO Cl4 SO4, COCl4 SO4, and this time suppose the charge is 3 minus. Acha. So what is the difference? You see both of these are, okay, both of this one or be it this one. Yes, both of these are what? These are octahedral complexes, correct? Both of these are octahedral complexes, is that correct? Both of these are octahedral complexes, right? Now here SO4 is acting like a monodentate ligand, but here SO4 is acting like a bidentate ligand. Yes, here it is acting like a bidentate ligand, but here it is acting like a monodentate ligand. So SO4 is actually a flexidentate ligand. Yes guys, do we all understand this? Yes or no? Yes or no? Yes or no? Hanji, everybody is clear? Everyone is clear? Yes? Okay, chalo. Moving on to the next topic, bacha. Next topic is your chelating ligand. So suppose you have a bidentate or a polydentate ligand. So sometimes what happens like this, imagine this remote is the metal, hai na? If this remote is a metal and suppose these are the 5 donor sites that you have, okay? These are the 5 donor sites. So how will you hold on to the metal? I think you will be holding on to the metal like this. I think you will be able to hold on to the metal like this. Yes. Now, if you hold on to the metal like this, so bacha look, do you see that here there is a ring-like structure that you are getting? Yes. Do you see like a ring-like structure, everybody? Exactly. So when you have a di or a bi or a polydentate ligand, what happens is when they all the donor sites hold on to the metal like this, you get a ring-like structure. And that particular time you call them to be as a chelating ligand. When they produce a ring, you call them to be as chelating ligand. Are we clear on this? Any doubt here, bacha log? Any doubt here? I hope so not. Yes, everybody is understanding. Clear hai? Everybody is understanding? Yes or no? Acha. Now we come across a theory which is called as Sidgwick's theory. So Sidgwick theory, basically you don't have to study the whole thing, but in case of Sidgwick theory, something that is very important is called as your effective. Yes, what is it called as? It is called as effective atomic number. What do you study here? You study here effective atomic number. So, who can tell me what is this effective atomic number? Anybody in the chat box? Anybody in the chat box? Yes? How do you calculate this? This effective atomic number, in short form, we also call it as EAN. So this EAN, how do you calculate it? You calculate it as the number of electrons that is present in the central atom. Yes. What do? You say that number of electrons present in the central atom minus, ठीक है, minus central atom or central atom, not minus, plus, ठीक है, central atom plus number of electron that is donated by the ligand, okay, plus number ठीक है. तो this is how you find out the effective atomic number. अच्छा ठीक है. तो now what, ma'am? After finding that effective atomic number, what? After that what? अरे बाबा, after that there are 2 points. Yes, firstly what happens is if the effective atomic number, ठीक है, if the atomic number that you find, if the effective atomic number you calculate, okay, and if you find that it is very close to the atomic number of a noble gas, that means that that complex is going to be stable. What did I say? Repeating again. Dubara, bacha log, everybody, telling you again. Yes, what did I say? That you will calculate this effective atomic number of a coordinate complex. After calculating the effective atomic number of the coordinate complex, if you find that the effective atomic number is close to what? To a noble gas. That means that complex is going to be stable. Yes or no? So suppose, let me give you a example. Can we do an example, everyone? Yes, can we do an example? Shall we? Chalo. Take the example, everybody. Take the example. Guys, come on. Everyone, pay attention. Hey, hello. Ha. This way you can actually calculate. Okay? This way you can actually calculate. Now, let me show you. What is it? Ha. Suppose the example we are taking is FeCO5, let's say. Okay? Yes. Suppose if you take FeCO5. Now, calculate the atomic number, effective atomic number. How will you calculate the effective atomic number, everyone? Yes. Number of electrons that is present in the central atom. Yes. Number of electrons that is present with the central atom. Acha, now you tell me, Sachin Tendulkar, very crazy man. Free is a 26, right? Fe is 26. That means 26 is the atomic number. If 26 is the atomic number, how many electrons are present with iron? 26 only. 26 is the 26 number of electrons are present. Very good. Okay. Plus, what do we do? Number of electrons donated by the ligand. Acha, this ligand, CO, carbon monoxide. There are 5. Yes, 5 ligands are present here. If 5 ligands are present here, all of them are going to provide you with 2 electrons. Is that right? So 5 into 2 is how much? 10 electrons, correct? 10 electrons. So 10 plus 26 is equal to 36. Now tell me, is 36 a number that is, does it feel like it is a noble gas ka atomic number? Huh? Does it feel like it belongs to a noble gas? Does it? Yes or no? Does it feel like it is a noble gas ka atomic number? You tell me, guys. You tell me. You tell me. Yes. Anybody? Do you all agree that 36 is the atomic number of a noble gas? Yes or no? No? Baba, 36 is the atomic number of what? Krypton. So that means this is going to be very, very stable. And similarly, if you are given any other compound and if you calculate for it, if you find out that it is not equal to the noble gas, that means you can say that it is going to be less stable. But these kind of compounds where the effective atomic number is equal to an atomic, to the atomic number of a noble gas, they will be more stable. Okay? All right, bacha log, shall we move forward? Yes. Okay, chalo. Moving on to the next topic. Sidgwick theory is over. That's it from Sidgwick theory. Okay? Acha. Now, last but not the least, we also come across homoleptic and heteroleptic complexes. But as I told you, homoleptic complexes are basically, suppose you have CO and you have 1, 2, 3, 4 and 5, 6. Suppose you have CO NH3 whole 6, right? So this is a homoleptic complex. Okay, this is going to be a homoleptic complex. Is that right, everyone? But if I have to give you the example of a heteroleptic complex, then I'm going to write it like this, okay? It is going to be, let's say, okay, what is this? This is a heteroleptic complex. Yes, guys, everybody, are we all clear? Okay, are we all clear? Chalo. Moving on to the next topic, everyone. The next topic, oh, we have questions. Guys, pay attention, everyone. We have question. Please do one trick video. What trick do you want, Swarupa? What trick do you want? What trick do you want? What trick do you want? For all chapters, what trick do you want me to do? Anyway, the coordination environment of Ca2 plus ion in its complex with EDTA4 minus. Bacha, if you see EDTA4 minus, what ligand is it? EDTA4 minus You all agree with me if I write down that this is a hexadentate ligand? Yes, this is a hexadentate ligand. So if it is a hexadentate ligand, that means that what is it going to form? It is going to form octahedral complex, isn't it? It is going to form octahedral complex. Hence, option B is the correct answer. Chalo. Next question, everyone, is which of the following complex is homoleptic? Is this homoleptic? No, there is NH3, there is Cl also. Again, NH3, Cl also, NH3, Cl also. So all the three of them, these are what? These are your heteroleptic complexes. But NiCN4 2-, what is this? This is a definitely homoleptic complex. Okay? This is definitely a homoleptic complex. So option D is your correct answer. Makes sense, everyone? Yes? Makes sense? Okay, bacha. Chalo. Moving on to the next question, everybody. What is the next question? The set which does not have ambidentate ligand. Which one does not have an ambidentate ligand? Bacha, you all know that NCS. This is an ambidentate ligand. Acha. C2O4 2-, ethylene diamine. This is a monodentate ligand. Ethylene diamine, EN. This is a bidentate ligand. Okay? C2O4 2-, this is also a bidentate ligand. So I think the correct answer is option B. But look at this. NO2-, this is a ambidentate ligand. Here also you have NCS-. So option B is the correct answer. Is that right, everybody? Yes? Is that right, everyone? Option B is the set which does not have an ambidentate ligand. Absolutely correct. Okay. Next question, everybody, is the IUPAC name of K3CO C2O4 is. Acha, this we will have to do a little later. Yes, this we will have to do it a little later because we still haven't gone through the nomenclature yet. Okay? So we will do this in some time. Now, let us start with the nomenclature, everybody. Are you all ready with me? Yes, guys, are you all with me? Shall we start with the nomenclature? Shall we start, everyone? Yes, guys. Acha. Before we start with that, let us quickly write down what are the things that we have studied now. What are the things that we have studied now, Bacha Bati? Let us quickly jot it down in our mind map so that by the end of the class, we already have our mind map ready. Yes, guys. What is it that we have studied? Who can tell me what is it that we have studied, guys? Yo, people, we have learned that ligands. Yes, we have learned about classification of ligands. One second. Yes, based on charge, yes, and based on denticity. Okay? Now here, what is the example? Here you have cationic, anionic. Yes, here you have mono, bi, tri, poly, dentate. है ना? This is what we have studied. Is that correct? ठीक है? This is what we have studied. Acha. Next, after that, what else did we study? After that, we also have studied about Sidgwick's theory. In Sidgwick's theory, EAN, effective atomic number, yes, electrons of metal atom plus electrons by ligand. है ना? This is your Sidgwick's theory. है ना, guys? This is the amount that we have studied. This is the amount that you have studied. Yes? Okay. Okay, guys. All right. Shall we move on then? This much is clear? This much is clear? Chalo. Let's move ahead, everybody. Let's move ahead. So this is our mind map. Mind map is over. moving ahead to nomenclature now. ठीक है, अभी क्या करेंगे? Nomenclature. After nomenclature, I'll give you a break, okay? After nomenclature, we will give you a break. Hanji. Okay, so when we come to nomenclature, bacha party, what is the first thing that we do? Yes, guys. Thank you, Bharati. Guys, I hope that this mind map will be very, very, useful for you. Will it be? Or no, it won't be. Why are you laughing, ma'am? Some surprises are coming in. Surprises will come in. You will know. Don't worry about it. Hanji. That you will get to know in some days. Acha, chalo, guys, come back to the nomenclature. Okay. So, what did I tell you? Whenever you have a coordination compound, shall we take the example of the same K4 FeCN6? Yes. Can I again take the example of this? Look at this. If I have K4 FeCN6, okay. Look at the rule. The rule says that cation has to be named first in both positive and negatively charged coordination entities. That means that, okay, look at this example, and suppose if I have CO NH3 Cl and Cl2 here. Okay? Acha. Now, do you all understand that this particular part is the positive part, this is the cationic part, and here this is the positive part? So that means, according to the rule, bacha, what is it that you have to do? You will always name the positive part first. So here, you will start naming it with potassium first. Yes, you will name it potassium first, and here you will name the coordination complex first, and then you will name the anionic part. Yes, do you all understand this? Do you all understand this? This much is clear. First rule. Okay. Next rule is ligands are named in an alphabetical order. Acha. So suppose if I have NH3, NH3 is called as amine. Okay. And you have, let's say, H2O, which is called as aqua. You tell me, out of NH3 and H2O, which one will you name first? Hanji. Yes, guys, you tell me. Aqua will come first or amine will come first? This is amine, not amine, okay? Amine. Come on. Tell me. Yes, guys, in the chat box, everybody in the chat box, you tell me, which one will you name first? Which one will you name first? Thank you so much, 01. Thank you so much, bache. Yes, guys, you tell me. Which one will you name? Aqua you will name first. Huh? Q comes first or M comes first? Bare. Lavanya, I will have to teach you A, B, C, D, E, F, G, H also now. Bro, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q. Hey. Alphabet to at least don't forget, guys. Don't say all these things. Yes, you, and please, even in the chat box, write it correctly. Amine, A-M-M-I-N-E. Amine. Okay? Not amine. Amine. Hanji. So, here you will write amine first, then aqua. Get my point? So, if these two ligands are present, suppose you have an example, let's say that you have CONH3 H2O2. Suppose you have this as a compound. What will you do? You will write tetraamine, diaqua, and then you will write the metal name cobalt. After that, you will write the oxidation number of the metal, and that's how you finish writing the nomenclature. Do you guys understand this? Do you guys understand this? Yes or no? Okay. Now, suppose you have an anionic ligand. What is anionic ligand? Anionic ligand such as, acha chalo, now we have to start writing this, okay? Now you will have to start writing this, everybody. First of all, let us start with neutral ligands. Shall we? Let us start writing with neutral ligands. So your neutral ligands are Which ones are your neutral ligands, bacha log? Yes. Which ones are your neutral ligands? In neutral ligands, you have H2O, aqua. Okay. All right. After that, what do you have? You have NH3. NH3, as I told you, this is your amine. Okay. What else do you have? You have CO, carbon monoxide. This is called as your carbonyl. Okay. What else do you have? You have NO, everyone. What's the difference between amine and amine? Amine is the ligand. Amines is a chapter in your class 12. Amines are basically the compounds that contain nitrogen that you study in organic compounds. And here when you have NH3, this is the ligand. The ligand is written as amine. That's the naming. Okay? That's the rule. Okay? For neutral ligands, you also have NO. What is NO? NO is called as nitrosyl. Okay. What else do you have? You have PPH3. PPH3 is triphenyl phosphine. What is this? This is your triphenyl phosphine. Yes. Acha. What else do you have? You also have CH2, NH2, CH2, NH2, right? Who can tell me the name of this? Who can tell me the name of this? Yes. What is this? What is this? What is this? Ethane 1,2-diamine. Ethane. This is ethane. Yes. 1,2. 1,2. Diamine. Okay. All right. Achha, there are lot of them, bacha. There are lot of them actually. Okay. Now, suppose if I write CH3NH2. Now, what is this? CH3NH2. What is this? CH3NH2 can be written. Sorry. CH3NH2. CH3NH2. What is this? This can be written as methylamine. Yes or no? Ha. Methylamine. Dun, 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 dun. What else? What else? We have a lot of them. Pyridine. Pyridine is also a neutral ligand. What is this? What is this? This is your pyridine only. Okay. So like this, if I keep writing, there are lot of neutral ligands also. Okay. There are also a lot of neutral ligands. So I can continue writing this, but what I can do is, bacha, what I can do is, I can give you the previous note where I have written it all of them, and that way we don't have to waste so much time and we can move forward. Shall we do that, or do you want me to continue with the list? You guys tell me, do you want me to continue the list? Should I write it down till I'm exhausted? Or can we move forward? Because I don't think that all of this will come. Most important ones are this may be sometime, this may be sometime, yes, this may be, and that's it. That's it. And pyridine may be sometimes. That's it. These are the most important neutral ligands. Okay? When this crash course ends, before your January attempt, we will be finishing the crash course. After your January attempt, we will be starting with basics to advanced crash course. Okay? All right. Right now, this is completely and absolutely for JEE Mains. Yo, guys, are we done? Shall we do that and go forward? Thank you so much. Yes. Hi, Gladiator. Oh, by the way, did you guys know that I'm also teaching 9th and 10th chemistry? If you did not know, let me tell you, I'm also teaching you 9th and 10th chemistry. Okay, acha, naming of, okay. Before this, next, neutral ligands is over. Now look at anionic ligands. Okay, now please take a look at how to write down for anionic ligands. If you have anionic ligands, okay, which ones are anionic ligands, guys? Sabse pehle, first of all, let us start with F minus. F minus, how will you name F minus? How will you name F minus? Fluorido. Thank you so much, Aditya. Thank you so much. Yes, F minus is what? Fluorido. 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 Ay, sorry. One O has to be here, no? Fluorido. This is your F minus. Then you have Cl minus. You will write chlorido. This is your chlorido. Then you have Br minus. It will become bromido. Okay. Then you have I minus. This will become iodido. Okay. Anything else? Anything else? H minus. H minus also exists. Yes. H minus is what? Hydrido. Hydrido. Acha. Now tell me what is common. Do you all see ido, 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 ido? Do you all see this? Exactly the point. So whenever you have an ionic ligand such as this, fluorido, chlorido, bromido, all of this will happen. Yes or no, everybody? Yes, guys. Have you? Yes, I have actually. To be very honest, I have. My parents did teach me. Okay. Acha, what else, everybody? Look at this. If I write O2, O2 2 minus. O2 2 minus. If I write, then what is this? This is what? Peroxido. Peroxido. Hai na? Yes. Acha. Now, if I write O2 minus, then what is this? Superoxido. है ना? What else can I write, बच्चा? Cn minus. Yes, how can I forget that? Cn minus. Cyanido. Cyanido. What else can I write, बच्चा लोग? Yes. What else? What else? What else? Nc minus. Nc minus. This will become isocyanido. है ना? This will become isocyanido. Then you have NH2 minus. NH2 minus is what? Who can tell me the name of this? NH2 minus is what? Imido. Imido. Certain bits and pieces looks like it is organic chemistry, no, but it's not. It is actually inorganic chemistry. What else is there, guys? What else is there? Nitrido. Yes, N3 minus. ठीक है, तो common ground, have you all understood that everywhere you have ido, 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 ido? Look at this, superoxido, cyanido, isocyanido, imido, nitrido. So that means that whenever you have anionic ligand, you are going to end it with ido, ido. Acha. Apart from this, what if I tell you this is not the only way to write down the name? What if there are something else also? Suppose, everybody, suppose, okay? Baap re, Anandu, Madhu, I will start flying only, huh? Then who is going to teach you chemistry? Who is going to teach you some chemistry, huh? Acha. Now look at this. Suppose you have NCS, SCN minus. What is this? So what is this? Huh? This will be written as thiocyaneto. 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 N. And if I write NCS minus, you are going to write it as thiocyaneto S. Get my point? So that means that if you have something that ends with 8, you know they say, no, she ate and left no crumbs. Yeah. So if you have something that ends with 8, write this, everybody. This is an important point, everyone. Yes. If it ends with 8, then what are you going to change it as? You will change it as eto. Okay. Ending with 8. Then change it to eto. Cool? Yeah? Hanji? Okay? Okay. Bond order for CO plus, you calculate, no bacha? I'm not teaching chemical bonding right now. Yes, but how do you calculate bond order? You have to calculate it as number of bonding molecular orbital plus number of anti-bonding divided by 2. If you do that, you will find the bond order. Yes, and what else can you do? Just count the number of electrons divided by 2. You will find out if it is 14, then it will be 3. If it is 15, then it will be 2.5. If it is 13, then it will be 2.5. So like that also you can find out. Okay? Yes, Sharat, we are meaning to do that. I will do that. Okay? We will do that. We will definitely do that. Don't worry about it. Okay? We will definitely do that. Acha. Okay? Yes. What else, bacha? Ha. Now, suppose there is another one. Okay? There is another rule here. The next rule is, everyone, if it ends with ITE, suppose you have sulfite, then what will it become? It will become ito, okay, ending with ite, then change it to ito. Whew, okay, all right. Okay, guys. Okay, everybody understood this? Chalo, guys, moving on to the next one. Now, if you have number of individual ligands, so if you have only one ligand, if you see that there is only one ligand, then you don't have to write anything. You can write mono, or even if you do not write mono, it's okay. But if there are two ligands, so let's say that, you know, it is like CONH3 whole twice. If it is this whole twice, then you are going to write diaqua. It will become diaqua. So now if you say CONH3 whole thrice, then what will you write it as? You will write it as triaqua. Okay? Now suppose if you have CONH3, let's say 4, okay? Then how will you write? You will write it as a tetraaqua. Okay? Acha. So this much you have understood, everybody? Yes? Yes, this much do you understand? CO plus, to Mohammad Ashik, CO plus is actually an exception. Yes, CO plus is an exception. So don't worry about it. What I will do is, for this I will have to teach you the chemical bonding chapter. When I teach you the chemical bonding chapter, CO plus is an exception, where what happens is, one of the anti-bonding molecular orbital, it actually goes on the topmost anti-bonding orbital, and that is when you calculate the bond order, it changes. So I will teach you the chemical bonding chapter. At that time I will explain it. Don't worry. Right now can we focus here? Otherwise all the other students will get deviated. They will not understand what ma'am is talking about. Okay? Yes. When does the session end? I think the session will end at around 10:30, 11 o'clock. Acha. Now, by chance, if you have a ligand, suppose, let's say that you have ethylene diamine. Hai na? Ethylene diamine. Acha. Now, in the name of the ligand itself, you have a di. So, if I again add, will it be okay if I write it as diethylene diamine? Diethylene diamine. If I write it like this, isn't it confusing? There are two dyes. So, instead of writing it like this, what I will do is, instead of writing it like this, I will write here bis-ethylene. I will write bis-ethylene diamine. And just like this, if there are 3 ethylene diamine, I will have to write tris. If there are 4, then it will be tetrakis. If there are 5, then it will be pentakis. ठीक है बच्चा लोग? Yes, guys. Yes. Okay, so everybody in the Reddit platform, you have JEE NEET, JEE NEETards. Yes. Where many students are writing a lot of good things about JEE and NEET. If you want to know anything about JEE and NEET, then you should go to the Reddit JEE NEET, JEE NEETards. And yes, thank you so much. Padh le bachche. I'm not taking your whole name. Aapke naam mein gali hai, so I'm not taking it. Okay? Yes, so padh le. I have given you a shout out. Chalo guys, next everyone. Oxidation state of central atom should be written in Roman numeral. So let's calculate everyone. Suppose you have NH3 5 Cl and Cl2. Let's calculate the oxidation state. Can we calculate the oxidation state? Let us do that. So cobalt co, we will take it as X plus, this is a neutral ligand, 5 multiplied with 0 plus, this is what? Anionic ligand, so minus 1 is equal to, this is your minus 2, so that means here you will have plus 2. So plus 2. Okay, now what will happen? X plus this 5 multiplied with 0 will become 0. Here you will have minus 1 is equal to plus 2, right? So this X will go, so X will become what? This minus 1 will come here. So it will become plus 3. So what is the name of this compound? The name of the compound will be, everybody, it will become pentamine. Bacho, one more thing, point to be noted, everybody. One more thing, point to be noted. Do you see that I am writing here? Sorry. Everyone. Take a look at it. Do you all see that I'm writing double A here? That means the A of penta and the A of amine, both of them you have to mention. Okay? Both of them you have to mention. If you don't mention, marks will be deducted. Mark my point. Okay? So penta amine. Okay? Then what do you have? What is this? Pentaamine chlorido. Pentaamine chlorido. Okay? Then what will you write? You will note down the metal, that is cobalt. Cobalt is in what oxidation state? 3. So write it down in Roman numeral 1, 2, 3. And then finally you have chlorine here. So write it as, write just the name of it. Okay? Yes. So this is going to be your nomenclature. This is going to be your nomenclature. Everybody, guys. Hey, why you people are fighting with Aditya? Yeah, don't fight. Okay? This much have you all understood? Everybody understood this? Yes, acha. Now, by chance, if the complex is, okay, if the complex that you have is if the complex is an anionic complex, then you will have to add 8. For example, once again, the K4Fe CN6, okay? In this case, this part, okay, this complex itself is an anionic complex. If this is an anionic complex, then what will you write? You will write it as potassium, okay? Then what will you write? Hexacyano or cyanido. Yes, chalo, let's write cyanido only, okay? Let's write cyanido. Hexacyanido. See, ferrous, I will not write ferrous, I will write ferrate. I will write ferrate. After that, you find out the oxidation state and write it. If it is a cationic ligand, for example, this one. For example, this one. Did I write here cobaltate? No, I have just written it as cobalt. Okay? What have I written it? I have just written it as cobalt. Okay, ji. Next, look at this. If it is a neutral ligand, then to no suffix at all. Acha, this was not ligand, huh? This was not ligand, bacha log, this is complex. Please write down, this is your complex. This is your complex. Sorry, while typing it became a mistake. This is your complex. Okay? Chalo. Next, naming of mononuclear. Here what do I have to do? Here I have to take you through some of the, one second. Here I have to take you through those metals, no? Yes. When will I teach organic chemistry? Bacha, I have started anionic complex. I will tell you. We will do some problems also. Don't worry. Okay? We will do some problems as well. Don't worry. So when will I teach organic chemistry? Bacha, I am starting here with high weighted chapter. So coordination compounds, DNF block, then haloalkanes and haloarenes. After that, we will do P block, periodic properties. Then we will do, then we will do another organic chemistry chapter, which will be GOC, because GOC is very, very exceptionally high weighted. So we will have to do GOC. Acha. Now everybody, let us draw a table. How do you do this? I guess I will not be able to. This is your notes that I'm teaching in. I still have to know how to do this. Okay? Acha. So here you write down central metal atom. Okay? After that you will write if it is cation or neutral. And here you will write anion. Okay? Acha. Now, suppose your central metal atom is iron. Central metal atom is iron. If it is cation or neutral, you will write it as iron. If it is anion, you will write it as ferrate. Okay? Now, let's say your central metal atom is, can you give me some names? Can you give me some name, everyone? Yes. Guys, everybody. Whee. Shh. Approximately how many units? Bro, we have to complete all of it, yeah? Syllabus will be complete before January 1st attempt. That is my promise. Okay? Yes, syllabus will be complete before your January 1st attempt. Now, here if I write Ag, silver This here you will write silver. Acha, now will I write silverate? How does silverate sound? Silverate sounds good? No, no. Then what will you write here? You will write here argentate. Argentate. ठीक है? अच्छा. What else do you have, बच्चा लोग? What else do you have? Gold. हाँ, gold is also there. AU. Gold. This will, you will write it as gold only here. Here you will have to write what? Goldate. No re. Orate you will have to write. ठीक है? अच्छा. Next what do you have? You have PB. PB is what, बच्चा? PB is your lead. Leadate. Na. Plumbate. You will have to write plumbate. ठीक है? So similarly, you can write it down for all the other ones also, like you have tin, stenate, you have chromium, chromate, you have molybdenum, molybdenate, palladium, palladate, right? You have zinc, zincate, manganese, manganate, then you have cobalt, cobaltate. So sort of like this, I think you can write it for all of them. Is that right, everybody? Great. Okay, chalo. Moving on. Huh. This is the cheat sheet, everyone. This is your cheat sheet. These are the most repeated ligands, okay? These are the most repeated ligands, and I have it right here. I'll give you this sheet. Don't worry about it. Yes, you will get it, everybody. So this is basically your cheat sheet. Please print it out. Keep it right in front of you. Paste it in front of you so that you do not forget the name of them. Huh? Whew. Now what? Next, what do you have to do? Acha. Now suppose you are given the name of the compounds. ठीक है? Suppose if you are given the name of the compound, what is it? Ma'am, copper oxidation state is +1, +2, +3. But in this complex K3 CuF6, I got Cu is a +3. Mohammad Ashik, sometimes you will have to calculate it, bacha. ठीक है? Sometimes you will have to calculate it. So calculate and find out if you're calculating and finding it. Don't worry, by the way, I think I have this question here. I think I do have this question here, so I'm gonna solve it. ठीक है? Yes. Thank you, Tarun. Tarun, I'm so sorry, but I'm trying my best. I'm trying my best. Okay? I'm trying my best. Thank you, Naman. Thank you, Naman. Thank you so much. Acha, guys, come back here. Formula of mononuclear coordination entities. So suppose you are already given the compound name. From the compound name, if you have to write down the formula, then what are you going to do? Then what is it that you are going to do? Now, sabse pehle, firstly, what will you do? You will find out the central metal atom. Okay? Yes, what will you do? Firstly, what will you do? You will note down the central metal atom. So, first point is the central atom is listed first. Okay? The central atom is listed first. Okay, all right. Next point, what will you do? Next point, alphabetical order में the ligand name is already written. So similarly, you will start noting down the ligands in the formula as well. Yes, VIT detailed strategy, I'll tell you that also. ठीक है? Then what do you do? The ligands are then listed. Tarun, is this better now? Yes. Is this better now, Tarun? Hanji? The ligands are then listed in alphabetical order. Okay? All right. After that, what will you do? Yes, in case, suppose if you have an abbreviated ligand such as ethylene diamine or triene, right? Then what will you do? Then what will you do? Then what you will do is the first letter of the abbreviation. Yes, guys, everybody. Yes, everyone. Hey, Dilip, guys, yeah, please go and watch my this thing, no? Go and watch my farewell video. Why do you keep asking me again and again? Huh. The letter of the abbreviation will be used. What will you do? Ethylene diamine. So EN, tri-N, the first letter of the abbreviation that you will be using. Okay? That you will be using. Acha. Now, if you have the ligand, if the ligand is polyatomic, If the ligand is polyatomic, it must be put in parenthesis. Example, H2O will be in bracket, but F minus Cl minus you will not put bracket. If it is NH3, you would have seen that I have put it in bracket. You get my point? Yes, you get my point, everyone? Okay, all right. You want? I haven't. The font is actually making it better. The font is actually making it better. If I do not write it in font, no, I don't think you will be able to understand at all. Acha. There should be no space. Okay? There should not ever be any space between the ligands. There should be no space in between the ligands. Okay? Okay? What else? What else? What else? What else? Next, what do you have? Huh. Now is it understood? You think that this is better or this one is better? I think this is better. With the font, it is better, no? With the font, it is better. Fourth point is looking nicer, or this ones are looking nicer? Acha. Next, what do you have? When the formula of a charge coordination entity, yes, is written, then you will put it in the bracket, that square bracket, and finally the charge of the cation is supposed to be balanced. So all that is not very much necessary. This is fine. Let us move ahead. Okay? Let us move ahead. Bonding and coordination compounds. Acha. Now before bonding and coordination compounds, bacha, I think let's take a break. Bonding and coordination compound, we will start with valence bond theory in some time. Okay? We will start with valence bond theory in some time. I think let's take a break. But before the break, everyone, let us quickly write it down in our mind map. We already have a mind map here. Yes, so here what is it that we have studied, bacha log, right now? We have just studied about nomenclature. Nomenclature. First, what did you learn? Cation named first. ठीक है? Yes. Alphabetical order. These are foremost. After that, what else do you have? Anion. Anions, ido. ठीक है? All right. So these are the ones that we have learned. ठीक है? Okay. Nomenclature is over. Now we will be starting with valence bond theory. So shall we take a break? It is 7:12. Let's meet at 7:30. We will be meeting at 7:30, everyone. Till then, you can take a break. But 7:30, I want you all here, okay? 7:30, I want you all here. Yes, guys, let's take a break. 7:30, we will meet, okay? 7:30, we will meet. So, till 7:30, we will take a break. Acha. Now, do you have a timer here? We don't have a timer here, no? Okay, 7:30, bacha. ठीक है? I'm writing it down here. See you soon in some time, taking a break. Okay, bye. Guys, call your friends. Let's start. It's 7:30. Am I audible and visible? I am audible and visible, right? Okay. Yes. Are you all with me? ठीक है, चलो, let us start everyone. Yes. So we are starting with valence bond theory, right? Now, when we want to know about this bonding and coordination compound, why are we learning about this bonding and coordination compound, right? This question also might have come in your mind because there are certain questions related to this question. The fact is that why is it that only certain metals can show you this coordination compound? Why not all the metals? There are plenty of metals in the whole periodic table, isn't it? Yes. Why is it that only some of the metals can show you coordination compound? Or why is it that some, you know, Varnakam, yes, Varnakam to you guys, yes. Yes. Or we also know that sometimes what happens is the bond that is present in the coordination compound, you know what? They are directional in nature. So why is the bond directional in nature? So these kind of questions, when it started to, you know, bother the chemist, what did they do? They wanted to bother our life, obviously, as usual. That's what they do, isn't it? That's what they are meant to do. So this is what they did. And when the bonding and coordination compound we had to study, you know this bonding and coordination compound we had started from the chapter chemical bonding. Yes. So even in chemical bonding, what did we do? We started with what? Vesper theory, then there was VBT, then there was CFT, then there was MOT. MOT was where we ended the chapter, correct? Absolutely. But here we are going to learn from valence bond theory. So in valence bond theory, bacha, what happens in valence bond theory? In valence bond theory, we understand that the central metal atom, what is the central metal atom? Did you realize that? I asked you in the very beginning that the central metal atom in most of the cases of coordination compound, did you notice that they all belong to d orbital? Did you notice that they all belong to d orbital, I mean d block elements? So if they are d block elements, don't we all know that the d block elements, they can use n-1 d orbital, they can also use n d orbital. Exactly my point, everyone. Exactly my point. So what can I write? Can I write down that the central metal atom, it can use n-1 d orbital, it can use ns orbital, it can use n p orbital, and it can also use nd orbital. For what? For bonding. So write that down. Okay, this is your first point. Your first point is the central metal atom uses n-1d, ns, np, and nd orbitals for bonding. Yes, everybody, this is clear. ठीक है. All right. After that, what happens? The ligand. What does the ligand do, bacha? You all have understood that the ligand donates 2 electrons. That is why, remember, when we were counting the effective atomic number, in that I told you that iron's atomic number is 26. After that, what happened? For carbonyl, CO, carbon monoxide, how many electrons did I count? I counted 2 electrons. That means what is it donating? It is donating electron pair, isn't it? What is it donating? It is donating electron pair. So what can I write here? I can write that the ligand will donate. Yes, what does the ligand do? The ligand will donate a lone pair. Yes, all right. I deleted. Thank you so much for coming here. Okay, ligand will donate lone pair to where? Lone pair to whom? Whom will it donate lone pair, bacha? It will donate lone pair to the vacant orbitals of the central metal atom, hai na? Arey baba, the bond is between the metal and the ligand only, right? The bond is between whom? The metal and the ligand. Exactly. So ligand will donate lone pair to vacant orbital of central metal atom. Ligand will donate lone pair to vacant orbital of central metal atom. Is that right, everyone? Absolutely. Third point in valence bond theory is, yes, the third point is what happens is pairing. Where does the pairing occur, bacha? Anybody? Can someone tell me in the chat box where does the pairing happen? Yes. When does the pairing happen? I'm talking about in terms of valence bond theory, not talking about in terms of crystal field theory. So you tell me, when do you think that the pairing happens? Yes, pairing occurs when? Pairing of... Huri Baba, what is meaning, ma'am? Which meaning? Huri Baba. Huri Baba is like, oh my God, what are you talking? Like that. Yes, guys, tell me. Yo, people. So in this case, you notice that pairing occurs when you have a strong field ligand. Okay? When you have a strong field ligand, you will see that the pairing of electrons are happening. Okay? All right. So here write down pairing occurs when strong field ligands such as Cn minus, etc. are present. Okay? All right. So these are the, who is this? Valence bond means, don't worry, I'll tell you. Don't worry. Okay. Now, just to give you a little picture of what you have studied in the chemical bonding chapter. Okay. Just to give you a little example of what you have studied in the chemical bonding chapter. Everybody who can tell me that hybridization and geometry, do you all remember? Hybridization and geometry, do you all remember, everybody? Yes, guys, we have studied that, isn't it? Absolutely. So here, take a look at it, that here I am writing hybridization okay, and here let's write the geometry, because now again we will be using it. Okay, again we will be using it. So everybody, if the hybridization is SP, then what is the geometry, my bache? What is the geometry? The geometry will be linear. Yes, the geometry is going to be linear. So that means how will the atoms be? How will the atoms be? Yes, how will it look like? It is going to look like this, isn't it? Metal, ligand here, and another ligand here. Correct? This is how it is going to be. Very nice. Next, everybody, what if you have sp2 hybridization? Then what is the geometry going to be? Then the geometry is going to be, Harshit, I'll tell you that also. Wait, we haven't reached crystal field theory yet. This is valence bond theory. I'm just giving you a quick recap of the chemical bonding chapter. So if it is sp2, then what is the geometry? Trigonal planar. Do you all agree with me? This is going to be trigonal planar. Acha, so trigonal planar, how is it going to be? It is going to look like this. Do you all agree? Tell me. Correct? This is how it is going to look like. Yes, very good. Next, everybody, if I have sp3 hybridization, then do you all agree it is going to be tetrahedral? Is it going to be tetrahedral? Yes or no? Absolutely. Then how is it going to look like? One second. Is this how it is going to look like? Yes. If I have, now what else do you have after sp3? After sp3, can you also have sp4, bache? No, not possible. The p, there are only 3 p orbitals. So please never ever write sp4. That will be wrong. Here, what can you have? What can you have? You can now start to have dsp2. Suppose now d orbitals. What are the d orbitals name? Do you remember? You have dxy, dyz, dzx, dx square minus y square, and dz square. Do you all remember, everybody? Yes. Please use dark background. But I tried. I really tried to change the background, but it is not changing. However, for the next class, I will definitely know the Vikas Bhaiya, who is our who operates the studio. He is the studio manager. I'll let him know so that he can change it. Okay? For today, please adjust. For today, please adjust, bacha. I tried. I really did. See, here also. Again, I can use the settings. Check it out. See, even if I change it, it's still not happening. See, it's still not happening. I've already changed it to default background color is this. It's still not happening. What to do? This is the problem. See, I've changed it to black already, but it's not happening. Okay? So for today, can you adjust? From the next class, I'll make sure that that this does not happen. Okay? Yeah. Okay, bacha. Chalo. Now suppose if I have d, let's say that we have dx square minus y square. And with this, what do I have? Let's say that I have sp2. Then what is it going to be? Then what is it going to be? Yes, I haven't reached that, bacha. Smuru Duragan, I still haven't reached it. I will reach there and I will teach you that. Don't worry. Here, what will I have? I will have square planar. Yes, this is going to be square planar. Hai na? So for square planar, what can I have? For square planar, it's going to look like this. This is your metal, ligand. Correct? This is how the square planar will look like. Very good. Amazing. Next, everybody. dsp2 is over. After that, what can you have? What can you have? Yes, yes. I'm looking at the chat. Come and tell me, everybody. Yes. After this, what can you have? Can you have dsp3? Yes, you can have. So when you have dsp3, you actually take dz square. 1 second. dz square sp3. If you take dsp3, then what is it that you are going to have? What is it that you're going to have? Trigonal bipyramidal. Are we going to have trigonal bipyramidal? Yes. So it is going to be trigonal bipyramidal. Hai na? Yes. So how will you write that? How will you write that? How does this look like? This looks like this. Metal. है ना? This is how it's going to look like. ठीक है. Next, what can you have? Next, what can you have, everyone? हाँ Janaki, I have just explained, बच्चा. Sorry, this is not happening today. I will do that from the next time. ठीक है? Yes. अच्छा. Now, if I take, let's say, d x square minus y square sp3, then what will I get here? Guys, same thing, but I have just changed the orbital. The d orbital, if I have changed, now what will you get? Now what will you get? Will you get square pyramidal? ठीक है? You will be getting square pyramidal. Yes, how does the square pyramidal look like? The square pyramidal look like this. Like this. है ना? This is how it will look like. ठीक है? Then what can you have? You can also have D2sp3, which is your octahedral. And you can also have sp3d2. This is also going to be octahedral. Acha, when you take d2sp3, here you will be taking n minus 1 d orbital, and when you take sp3d2, you take nd orbital. Yes, okay, both of them are going to be octahedral. What is it going to look like? It is going to look like this. Yes, and exactly similar. This is also here. It will be done. ठीक है? All right, बच्चा लोग. Now let us understand the valence bond theory a little better. So you understand that the metal here is going to have a vacant orbital, right? The metals usually what is happening? You just saw that the metals have a vacant d orbital, which can be n minus 1 d orbital, it can be n s orbital, it can be n p orbital, it can also be n d orbital. But the ligand here is going to have, let's say, the ligand here is going to have a pair of electron, and this pair of electron will be donated to the metal, and then what happens is they form a bond like this where they are sharing it. Are you getting it, everybody? Is this clear to you all? So basically, if you want to understand valence bond theory in an absolutely layman's term, you have to understand that the metal will first empty its orbital, then it will give it to the ligand that please come and fill the electrons, please come and fill the electrons. The ligand will come, fill the electron, and that is how they're going to form a bond. Do we all agree on this, everyone? Do we all agree on this, everybody? Yes, absolutely, we do so. Now, so this is the hybridization that I have just already given it to you. I have given you a whole thing. I have given you a whole recap of the chemical bonding chapter. Is that right, everybody? Yes, I have. Chalo, moving on from here, okay? Now, suppose if you have coordination number 6. Yes, if you have coordination number 6. I was just teaching you this only. But let's do this again. So, if you have coordination number 6, what is going to be the geometry? Yes, guys, can I see it in the chat box? Can I see it in the chat box? What is going to be the geometry? If coordination number is 6, what is going to be the geometry? Come on, guys, everybody, let me know. Let me know. Yes or no? What is going to be the geometry if coordination number is 6? Absolutely right. It is going to be octahedral complex. Okay? It is going to be octahedral complex. Now, in octahedral complex, as I showed you that there are two different ways, right? There are two different things that you can form. Number one is your sp3d2, okay? And the second one can be d2sp3. Now, I have told you already, haven't I already told you? I have told you that this d2 is basically n minus 1 d2sp3. And here what is happening is you have sp3 ND2. So that means that if you have, let's say, electronic configuration, yes, let's say your electronic configuration is a 3s, 3p, and then you have to take 4d. 4d is the next orbital. 4d is outside. If I have to draw the orbitals, will it be like this? This is going to be, let's say, your 3s. This is going to be your, let's say, 3p, है ना? This is going to be your 3p here. And this is going to be on the outside, isn't it? This is going to be on the outside. Let's say that this is your 4d orbital. Now, because it is outside, the orbital is at the higher level. Can I, my dear students, can I call this as outer orbital complex? Can I call this as outer orbital complex? Yes, absolutely, I can do that, right? Absolutely, I can do that. Can I not? I can afford to do this. Yes, okay. Next, everybody, take a look at this, okay? Next, everyone, take a look at this. Here, what will happen? I will have to draw the d orbital first. 1, 2, 3, 4, and 5. So, this will be your 3d. Yes, then I will be doing the s orbital. Yes, this is going to be your, let's say, 4s, and then here you are going to have your p orbital. So do you see that the d orbital is in the inside? The d orbital is not the outermost shell. The d orbital here is not the ultimate shell. It's inside it, right? It is inside. So will you all agree with me if I want to call this as inner orbital complex? Yes. Can I call this as a inner orbital complex, everybody? है ना? Can I do this, Pasanglas? Can I do this? Yo, Werner Sena, everybody, are you all listening to me? Yes or no? Please tell me, do you all understand this? Yes, acha. Now, everybody, here what is happening is, suppose you have 3s orbital, okay? Here you have 2 electrons, here you have 2 electrons, here 2 electrons, here 2 electrons. But here what will happen? No, here you will have 1 electron, let's say. Acha. Now here what happens is, try and understand this. You will have 1, 2, 3, 4, 5, 6, 7 and 8. All of them are filled. All of them are filled. All the d orbitals are filled here. Yes. All the d orbitals are filled. Agreed here? Okay. Now, here also, let's say that these are also filled. Acha, now tell me, bacha, if in all the rooms there are 2, 2, 2, 2, 2, 2 electrons, and here if you have 1, 1 electron, if you have 1 electron, then do you all agree with me that it will be able to rotate like this, high spin? Will it be high spin because they have enough amount of space? Because they have enough amount of space, do you all agree with me that they will be able to spin properly? Like Shaktiman, they will be able to spin? Yes or no? Will they be able to spin? Absolutely. But if you look at this, here they have 2 electrons. That means the room is filled. So if the room is filled, you tell me, bacha, do you think that here they will have enough space to spin around? Will they have enough space to spin around? Yes? Yes? Will they have enough space to spin around? No. That means that, can I call this as, I will be calling this as low spin complex. Yes, I will be calling this as a low spin complex, and here I will be calling this as high spin complex, everyone. Yes, here I will be calling them as high spin complex, outer orbital complex, and this is going to be inner orbital complex, low spin complex. Do you all agree with me? Yes or no, bacha? Yes or no? है कि नहीं? Yes or no, बच्चे? बताओ. बताओ everybody. Do we all agree with this or not? समझ आ रहा है सब लोगों को कि नहीं आ रहा है? Please बताइए. So this is what? This is your high spin complex. Why is it high spin? Because these guys, the electrons have enough room to spin around. Here if you see, the electrons are paired already. Yes, because they are paired already, here they have low spin complex. Am I making sense here, everybody? Am I making sense here, everyone? Yes or no? Great. Chalo. Now let us take some examples, everybody. Okay? Let us take the examples and let's understand this a little better. Okay? The example is obviously for your coordination number 6. Example of coordination number 6. Okay? What example can we take, everybody? Yes? Yes, what is the example, bacha? Let's take an example, everyone. What example can we take? Can we take the example of a homoleptic complex called CONH363 plus? Can we do this? Yes, let us take the example of CONH3 whole 6. Yes, and here can I take 3 plus? Is this okay? Is this okay? First of all, is this okay, everyone? मनोज कुमार बहुत इजी लग रहा है, क्या बात है, थैंक यू बच्चे. ठीक है, अच्छा अब आओ यहाँ पे, आओ, कम हियर. हाँ, तो फर्स्टली व्हाट इज द फर्स्ट थिंग दैट यू शुड डू वंस यू गेट द कोऑर्डिनेशन कंपाउंड? व्हाट इज द फर्स्ट थिंग दैट यू आर गोइंग टू डू? The first thing that you're going to do is, bacha, find out the oxidation state. Okay, let's find out the oxidation state. See, X here is going to be your X plus, yes, this is what? 6 times, this is a neutral ligand, so 6 multiplied with 0, and the overall charge here is plus 3. When you write this down, then you will get, look at this. This X is going to be what? This X is going to be plus 3 oxidation state. है ना? अच्छा. Now, what is cobalt's atomic number? What is cobalt's atomic number? So everybody please learn it. Please learn it, बच्चे लोग. Yes, please learn it, everybody. Sachin Tendulkar, very crazy man. Free coaching, Nick's cousin. ठीक है? Free coaching. तो 2627 is cobalt's atomic number. If it is 27, when you learn DNF block, okay, I will be teaching you DNF block also. So there you will learn that 27, that means the electronic configuration is going to be, it is going to be 3d7 and 4s2. Do you all agree? Yes. Okay. Acha. Now you see that cobalt is in plus 3 oxidation state. So can I write CO in plus 3 oxidation state? So that means that what will happen, bacha? 2 electrons from here will go and 1 electron from here will go. So we will have what? We are going to have, do you all agree that it is going to be 3d6? Is that right? Yes, it is going to be 3d6. Okay, it is going to be 3d6. So chalo, now let's draw. ठीक है, तो cobalt in its neutral state, cobalt in its neutral state, everybody, how is it going to look like? See, 3d7 4s2. तो inner orbital or outer orbital complex, definitely inner orbital. Yes, 3d7, तो 3d, yes, then you will have 4s. This is your 4s, correct? And then of course you also have 4p. 4p is empty. ठीक है, 4p is empty. So here you have 1, 2, 3 and 4, 5. So you will have 3d7, right? 3d7, alva. 1, 2, 3, 4, 5, 6 and 7. 3d7, 4s, 2 electrons. Done? Done, everybody? Great. Okay. Now look at this, everyone. Now if I take cobalt in plus 3 oxidation state, it will still be, look at this. Yes, this is your 3d7. This is 4s. And here you have 4p. So this is 3d. Now how many electrons do you have in 3d? You have 6 electrons, है ना? You have 6 electrons. Acha, by the way, NH3 is a strong field ligand. So do you remember what did I tell you? I told you that in valence bond theory, ligands like NH3, CN, CO, these are strong field ligand. When you have strong field ligands like this, what will happen? In case if you have a strong field ligand, pairing up will happen. So here you will have, my baches, here you will have 1, 2, 3, 4 and 5 and 6. Now what will NH3 do? The NH3 electrons will come and the electrons will come here. 1, 2, 3, 4, 5, 6. Yes, 5, 6, 7, 8, 9, 10, 11, 12. So this is your NH3. This is NH3. this is NH3, this is NH3, है ना? This is also NH3, this is also NH3, and this is also NH3. ठीक है? तो NH3 has come into the picture and it has filled its electrons here, 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 and here. Am I right? Am I right, my bache? Yes, absolutely. So now here, you bacha tell me, is this going to be a low spin complex or a high spin complex? Yes, bacha. Yes. Is this going to be a low spin complex or a high spin complex? I think you all will agree with me that this is going to be a low spin complex. What else is it going to be? It is going to be an inner orbital complex. Is that right? Absolutely. What else is it going to be? Because you do not see any unpaired electron, do you all agree that this is also going to be a diamagnetic complex? Yes. So this is how you can tell about a compound. Yes, this is how you can tell about a compound. Is that right? Yes. Is that right, everyone? Yes? Okay, chalo. Now, let's take another example, okay? Let's take another example. This time, let us again take the example of cobalt, but with cobalt, example coordination number 6 here. Yes, and the compound here is COF6. Yes, what is the charge, bacha log? What is the charge? Who can tell me the charge, everyone? Yes, can I write COF6 3 minus? Yes, I can. Acha, exactly similarly, everyone, you all know that cobalt has an atomic number of 27. That means the electronic configuration is 3d7 and 4s2. Correct? Yes or no, everybody? Is that right? That it is going to be 3d7, 4s2? Yes, acha. First things, everybody. First thing, guys, what are we going to do? We are going to find out the oxidation state, okay? So, X plus 6 multiplied with fluorine. Fluorine is an anionic ligand. Bache, fluorine is an anionic ligand. It has a negative charge. Agreed? Absolutely. So, 6 multiplied with -1. Yes, and that is equal to -3. So what will happen here? You will basically get X is equal to -6 will go that side. So +6 -3 will become +3. Correct? Is that correct? Yes, we will be completing it today only, bacha. We will be completing it today. We have already reached VBT. After this, what is left? CFT is left. After that, what is left? Isomerism is left. So we will be done. And 2 more topics only. Okay, guys, come back here. So +3 oxidation state. Acha, chalo. Now that means that if I have to write again cobalt in +3 oxidation state, 2 electrons gone from here, 1 electron gone from here. So it is again going to be 3d6. ठीक है? Acha. So cobalt in its neutral state, you can draw it like this. है ना? So this is your 3D, this is 4S, and this is 4P. Next, we have to write cobalt in +3 oxidation state. So you will have Is that right? Okay. Now, let's start filling the electrons. Here, how many do you have? 1, 2, 3, 4, 5, 6, 7. Is that right? 4s, you have 2 electrons. Correct? Is that right? Absolutely. Here, what do you have when it is in +3d6? And you have to understand that fluorine is the weak field ligand. Yes. So if fluorine is a weak field ligand, you will not see pairing. Pairing up will not happen. So here you will see that 1, 2, 3, 4, 5 and 6. So this 3D is completely filled, bacha. 3D is completely filled. Now fluorine will do what? Fluorine will come and fill its electron here. 1, 2, 3, 4, 5, 6, 7, 8. Yes, only 8 electrons. After that, what will it do? After that, it will have to go to the outer orbital, that is 4d. It will have to go to 4d here. And right here, what will you notice? You will notice that now fluorine will need, see, 1, 2, 3, 4. 4 orbitals only it has got. 2 more it will need. So 1, 2, 3, 4. Now what is it forming? It is forming sp3d2. It is forming sp3d2. That means what is this? This is outer orbital complex. What is this? This is outer orbital complex, because here you see, do you see that there are 1 unpaired electrons, है ना? Yes, if there are unpaired electrons, that means, can I say that it is paramagnetic, है ना बच्चा? This is definitely paramagnetic. Can I also call it as high spin complex? Yes, this is a high spin complex. What is the hybridization? sp3d2. Yes. And here what is the hybridization? Here the hybridization is, look at this everyone. Here the hybridization is d2sp3. It is d2sp3 hybridization. So my dear students, is this clear to you all? Is this clear to you all? Yes or no, bacha log? Yes. Vinny Mishra, bacha, DNF block I'll have to do just after this, okay? Because if I do coordination compound and if I don't do DNF block, there will be no relation. Yes, there will be no relation. Okay? All right? Haan ji, bacha. This is clear? Is this clear to you all? Is this clear to you all, everyone? It is a high spin complex only. This is a high spin complex. What are you saying? It is a high spin complex. Look at this, no? It is a high spin complex. These are all what? Unpaired electrons. Rock, you forgot. I think you did not pay attention. Rock, whenever you have outer orbital complex, it is going to be high spin. If you have inner orbital complex, it is going to be low spin. Understood? Yes? Yes, okay? Acha, chalo. Now let us do coordination number 4. Okay? Let us take a look at coordination number 4. See, in coordination number 4, if it is sp3, that means what will happen? This will be tetrahedral. This is going to be tetrahedral. Here you have dsp2. If it is dsp2, then what will happen? Then you will have square planar. Then you are going to have square planar. Agreed, everybody? Yes. Chalo, let's try and take a look at examples. Shall we look at some examples? Yes or no, everyone? Yes or no, everybody? Are you all with me, guys? Okay? Chalo, let's take an example. Bacha, please pay attention here because this question has been asked many times. In fact, if you want, you can also pin it in the comment section. Write down the timestamp that yes ma'am, at this point you were telling us. At this point you were telling us about the most important question. This question has come in JEE Mains so many times that I cannot even begin to tell you how many times it has been repeated. Okay, this particular example has been repeated many times. In fact, you can open any year JEE Mains question and I think there will be one question related to nickel complexes, NiCl4, NiCO4, NiCN4. They always ask you this question. So please pay attention. Okay, everybody bring your focus here. Bring your focus here. Chalo. Okay, guys. So here, let us take the example of first thing. Okay, first thing. NiCl4 2 minus. What is it? We are taking the example of NiCl4 2 minus. ठीक है? अच्छा, तो nickel, what is nickel's atomic number बच्चे? What is nickel's atomic number? Free coaching Nick's cousin. तो 28, 3d8, 4s2. First thing, let us find out the oxidation number oxidation number is going to be X plus 4 multiplied with -1 is equal to -2. This -4 will come here, so it will become +4 -2. X is going to be +2. Okay. So if X is in +2, that means that, chalo, let us start drawing, okay? Nickel in its natural state, yes, in its natural state or uncombined state, 1, 2, 3, 4, and here you will have 5, okay? This is what? This is your 3D. Then you also have 4s here, and then what will you have? You will have 4p, correct? Absolutely. Okay. Next, what you have, nickel is in which oxidation state, bacha? +2 oxidation state. If it is in +2 oxidation state, look at this, you will have 1, 2, 3, and 4, and 5. Here you will have 4s, okay? And here you will have 4p. This is 4p, this is 4s, and this is your 3D, correct? Chalo, let's start filling up the electrons, okay? So nickel in its natural state 3D 8. So 1, 2, 3, 4, 5, 6, 7, 8, 4s2. Done? Okay. Now when it is in +2 oxidation state, and you know that Cl is a weak field ligand. Is that right? Yes, Cl is a weak field ligand. So try and take a look at it. Yeah. So what will happen here? No pairing up will happen. Yes, no pairing up will happen. Only 2 electrons. It will go from here +2 oxidation state. So it will remain 1, 2, 3, 4, 5, 6, 7, 8. These two are already filled. Even these two are already filled. Cl is a weak field ligand, so no pairing up will happen. That means that now what will happen? Chlorine. What will chlorine do? Chlorine will fill its electron here. 1, 2, 3, 4, 5, 6, 7, 8. 8 electron, na? Because 4 is the coordination number. So what is the hybridization? Hybridization is sp3. Do you see? 1s orbital, 3p orbital. What is the hybridization? sp3 hybridization. If it is sp3 hybridization, what is the shape? What is the geometry? The geometry is going to be tetrahedral. Correct? Yes, this is going to be tetrahedral. Acha. Now here do you see unpaired electron? Absolutely. So ma'am, is this inner orbital complex, outer orbital complex? This is definitely inner orbital complex. And because there are unpaired electron, is it going to be paramagnetic or diamagnetic? Definitely paramagnetic, right? This is going to be paramagnetic. So Ashik, I have just explained how to find the hybridization, correct? Is that correct? This is clear to you all? I have just explained, bacha. See, no. Cl is a weak field ligand. No pairing up happened. This was empty. This was empty. I found out the oxidation state. Bro, not paying attention, huh? You're not paying attention, bache. You are not at all paying attention. Acha, guys, by the way, are you all liking, are you all subscribing to the channel or not? Come on, bring it to 1,000 subscribers. We are only 2 subscribers less than 1,000. And you know that this is a new channel. We have just opened up on 4th or 5th of November. I have started to take session. From 5th of November, I have started to take session, and today is 11th November. Guess what? Today is also my mom's birthday. So let's make it auspicious and let's have 1,000 subscribers right now, everybody. Can we do that? Can we have 1,000 subscribers right now? Can we do that, guys? Quickly. Quickly, 2 more subscribers. We only need 2 more subscribers. Yes. Ashik, I hope that you have also subscribed to the channel. Can we do that, guys? We only need 2 more subscribers, everyone. Come on. Okay, guys. Chalo, theek hai. Acha. Next, another example. Let's take Ashik. Now, Mohammed Ashik, can I please have your focus here right now? Let's do another one where we are trying to find the hybridization. Theek hai? We're going to find the hybridization, but let's try this once again because you told me that, ma'am, please tell me how to find the hybridization. So let me do that for you. This time our example is going to be. Let's say, Ni, okay? Ni, nickel. I'm taking nickel only, but with nickel, what can I take? Can I take CN, cyanide? Yes, can I take cyanide? So let's say that I take NiCN4 2 minus. Acha. Now Ashik, you tell me that Cn is a weak field ligand or strong field ligand? Cn, is it a strong field ligand or is it a weak field ligand? Yes. How many of you can answer me this? How many of you can answer me this, everybody? How many of you can answer me this? Okay. First thing first, everybody. Let's do this. Nickel. What is nickel's atomic number? Nickel has an atomic number of 28. If it is 28, that means electronic configuration is going to be 3d8 and 4s2. Is that right? Absolutely. Now let's find out the oxidation number. The oxidation number, everyone, is going to be X plus cyanide. Cyanide is a -1 charge. So 4 multiplied with -1 is equal to -2. This -4 will go that side. So X is going to be again in +2 oxidation state. Okay. Nickel in its natural or, uncombined state, it is going to be like this. 1, 2, 3, 4, 5. This is 3D. This is 4s. Oops. This is 4s. And this is 4p. Similarly, nickel is in +2 oxidation state. Do you see that? Yes. In its +2 oxidation state, it is going to be 1, 2, 3, 4, and 5. 3D. Here you are going to have 4s. And here you are going to have 4p. Yes? Okay. Let's fill up the electrons. Let's fill up the electrons. So nickel, you will have 1, 2, 3, 4, 5, 6, 7, 8. Here you will have 4s. Okay. Now nickel is in its +2 oxidation state. The 4s electrons will go from here. Here you will have 1, 2, 3, 4, 5, 6, 7, 8. Is that correct, everyone? Is that correct, everybody? Yes or no? For more than one complex. What more than one complex? What do you mean by more than one complex? What do you mean by more than one complex? Thank you, Varshit. Thank you so much. Wow, we have reached 1,000 subscribers, guys. Clap, clap, clap emoji should be here. A little clap emoji, everybody. We have reached 1,000 subscribers. Amazing. Amazing, everybody. We have reached 1,000 subscribers. This is great. Acha. Now, bachos, what will happen is Cn is a strong field ligand. Yes. And because it is a strong field ligand, what will Cn do? Cn will push this electron here. Yes, Cn will do what? It will push this electron here. So basically, now what will you have is, you will have something like this, okay? And now the cyanide, that is Cn will come and fill its electrons here. 1, 2, 3, 4, 5, 6, 7, 8. That means that it is going to be dsp2 hybridization. What is the hybridization? dsp2. What is the geometry going to be? It is going to be square planar. And is this going to be paramagnetic or diamagnetic, everyone? This is going to be definitely diamagnetic. Okay? This is going to be diamagnetic complex. Am I clear, everyone? Am I clear? So yes, bacha log, did you understand how to find out the hybridization? Yes. Did you understand how to find out the hybridization? Yes or no? Anupa, I'm so sorry, bacha. I don't think I'm allowed to say this in a live class, but maybe you can ask me later. Acha? ठीक है? All right? Yes? Okay, guys. Chalo. Next, everyone. Okay? Now, here I'm going to tell you a trick. Okay? What is your trick, bacha? Your trick, everyone, is that if you have, let's say that you have a ligand, right? Now, you all know that your ligand can be strong or weak. Is that right? Yes, the ligand can be strong field ligand. Is that right? The ligand can also be a weak field ligand. Is that right? Yes. If the ligand is strong, then what will happen, bacha? If the ligand is strong, then you will notice pairing up of electrons. What will you see? You will see pairing up of electrons. If the ligand is weak, no pairing up will occur. Yes, no pairing up will occur. Which ligands are strong field ligand? Example of strong field ligand are NH3, right? CN, carbon monoxide. These are your strong field ligand. In fact, even ethylene diamine, EN, is also a strong field ligand. Okay? All right. Now, here, which ones are weak field ligand? Weak field ligand are, bacha, F minus, H2O, है ना, Cl minus. These are all your weak field ligand. Okay? These are all your weak field ligand. Usually what happens is, if you have a strong field ligand, then you will notice that usually, generally, the complex is going to be diamagnetic. The complex is going to be diamagnetic. Okay, and if you have a weak field ligand, you will notice that the complex is usually paramagnetic. Okay, the complex is usually paramagnetic. Yes, all right. Shriram, I'll definitely make a strategy video regarding this. Is that all right, bacha? Is that all right, bacha? Yeah. Yeah, okay. And guys, we have reached 1,003 subscribers. I'm super happy. I don't think I would have done this without you, everyone. Once again, telling you this is our new channel. Don't forget to subscribe to the video. Do not forget to like this video and share this with your friend if you have liked this video. अगर आपको अच्छा लगा तो प्लीज 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 अपने दोस्तों के साथ भी शेयर करना, ठीक है? It will really mean a lot to me, and to be very honest, I am super thankful to you all for your support. I would have never imagined that even in this category I can bring 1,000 subscribers. So thank you so much. All the love, all my blessings, everything is with you. Thank you so much from all my heart. Thank you so much. Okay, chalo guys, moving on everyone. Yes guys, do we all understand this? This is clear to you all? So this is basically your trick. Now just remember it. Anyway, we will be learning it in the Spectrochemical series. That time you will understand it again. Okay? Okay, chalo. Moving on from here, bacha. Moving on from here. Magnetic properties, yes, magnetic properties of coordination compound. Let's understand that. How do you calculate the magnetic properties of unpaired magnetic properties of coordination compound? So you notice when it is diamagnetic, that means there are no unpaired electrons. Okay? When is it diamagnetic? When there are no unpaired electrons. Okay? When is it paramagnetic? When is it paramagnetic? Yes. Paramagnetics are Sundar bacha. See, the problem is, to be very honest, I'm in Jaipur. Okay? This is Rajasthan, Jaipur. It's not like Bangalore that you get even Uber, Ola or Rapido cabs at night. To be very honest, today at 11 o'clock when I'll be finishing my class, I don't even know if I'll be staying in the office or will I be able to go home. Because at that night, even after, I mean the city sleeps at 9:30, 10 o'clock. So I'm not very sure if I will be able to go home. Now, if I finish the sessions at 12 o'clock, it's a definitely given that I will have to sleep in the office only. So, Sundar, I really, all I can say is, bacha, that, you know, I think you can watch the beginning of the session a little later, or you should watch the recorded session in 1.5x. That will be really beneficial for you. Okay, but otherwise, do you want your teacher to stay in the office only? It's not safe for me also to travel that late at night, no? Yeah. Plus, I'm staying in a hotel here, so that's another difficulty. I think it's not that safe for me to travel at 12 o'clock, so I hope it makes sense to you. Yeah. Okay. And here, when it is paramagnetic, is when you have one or more unpaired electrons. ठीक है? अच्छा. Now what happens is to calculate the magnetic moment. Yes, everybody. All right. To calculate the magnetic moment, there is a formula. What is the formula? The formula is given as mu. Okay. Mu is equal to root over n multiplied with n plus 2. Now you're going to ask me, ma'am, what is this n, ma'am? What is this n? Bacha, this n is equal to number of unpaired electrons. What is it? It is equal to number of unpaired electrons. ठीक है? Yes, guys. Do we understand? Yes, Lavanya, you should be, bacha. You definitely should be. ठीक है? No problem, Sundar. You don't have to tell me sorry. I think it's okay. I understand. You just ask me what will be beneficial for you. But like I said, I'm very sorry. I don't think I'll be able to do that right now. Okay. Now let's understand the limitations of valence bond theory. See, obviously what happened was that valence bond theory was not the best theory that everybody could come up with, which is why we also had to study for crystal field theory, which is why we also have to study molecular orbital theory. Now, when we talk about valence bond theory, we notice that there was a lot of assumptions that we had to take, okay? Yes, so number one limitation is that it involves a lot of assumptions. ठीक है? All right. Next, everyone. Secondly, what happens is it does not give you a correct interpretation of magnetic field. So basically what happened, this formula that you have, no, that calculates the magnetic moment in Bohr magneton. But to be very honest, valence bond theory was basically a loophole. First, it calculated the number of electrons. Okay? First, no, what it did was in valence bond theory, they calculated the magnetic moment separately. And then they said that, acha, if the magnetic moment is this much, that many number of electrons, number of unpaired electrons be there. But Baba, that's not the correct way to do it. No. First, you should find out the number of unpaired electrons and then you should be able to tell the magnetic moment. But they did it ulta. What they did was they calculated the magnetic moment separately and then they came back and told that, this is what should be correct. You get the point? Yes. So that is why we can say that it does not give quantitative interpretation of magnetic moment. Yes, what do we say? We say that it does not give quantitative interpretation of magnetic data. ठीक है? Okay. Next, what else was it? Hi, Magic of Money. Thank you so much. No problem. Yes, very good, Ashik. Ashik is telling exactly the correct. It does not explain color exhibited by coordination compound. ठीक है? Fourth, any other limitation? Yes. Any other limitation? it does not tell you anything about weak and strong field ligand. Like in crystal field theory, in fact, even in crystal field theory, you do not get to know about weak and strong field ligand. Only after the spectrochemical series, we got to know about the weak and strong field ligand. So here also you can write that it does not tell anything about okay. All right, bacha log. Yes, this is clear. Is this clear, everyone? Very good, magic of Moni. Yes, it does not explain anything about stability of complexes. Absolutely right. It does not explain anything about stability of complexes. True that. Now, what do I do here? Acha. What is this? Next, what did you all say? Fifth point, it does not explain stability of complexes. ठीक है? It does not explain stability of complexes. हिंदी में पढ़ाइए नितिन छेत्री जी. बच्चा, हमारे चैनल का नाम है Rankplus JEE English. There is another channel. एक और चैनल है जिसका नाम है Rankplus English. तो आप वहां जाइए, मैं वहां पे भी पढ़ाऊंगी. फ्राइडे को मेरा सेशन आने वाला है, ये सेम सेशन, तो आप वहां पे जरूर देखना. ठीक है? Yes, what was I telling you? It could not explain stability of complexes. Yes. Stability of complexes, thermodynamically. ठीक है? Yes. Anything else that you can remember, guys? Anything else? Yes. Anything else? It also does not, it cannot make exact prediction. It cannot make exact prediction regarding tetrahedral and square planar 4 coordinate complexes. ठीक है? Regarding tetrahedral and square planar coordination number 4 complexes. ठीक है? तो बच्चा, these are the limitations of, okay, these are the limitations of valence bond theory. So guys, are we clear with this? Yes, it also does not tell you the kinetic stability. So I hope that this is clear. Okay, all right. Now once this all are done, okay, what do? We get into our crystal field theory. Shall we, guys? Everybody, are we all with me? Are you all with me? Shall we move on towards crystal field theory? After that we will do all the questions. Questions are there, I promise you. देयर आर अ लॉट ऑफ क्वेश्चंस, ठीक है मैम. ऑर्गेनिक कॉन्सेप्ट का बेस्ट book for preparation, organic concept best book for preparation will be your MS Chauhan. Best book for organic chemistry will be MS Chauhan. ठीक है. अच्छा guys, let's start with crystal field theory, shall we? Yes. Let's start with crystal field theory. In crystal field theory, no, first thing that they told you was, yes, the first thing that they said in crystal field theory is that anionic charges, ligands will be considered as a point charge, especially the anionic ligands that you have. They will be considered as point charges. That's what they said. What did they say? They said that anionic ligands will be considered as point charges. ठीक है? All right, but acha, now tell me something, bacha. Now tell me something, everybody. Please take a look at it. Understand this. Suppose you have Cl minus, है ना? Cl minus, ठीक है? तो Cl minus is an anionic ligand, correct? Yes. So that means this will be a point charge. If this is the point charge and if the metal is here, you tell me if this is negative, then that means that the metal will have some positive charge here. Is that right? Yes. That means dipole will be induced. Is that correct? Dipole will be induced. Is that correct? Okay, very good. If that is the case, then Cl minus, should it not be a very, very, very strong field ligand? Should it not be? But what do we observe? We all know that Cl is actually a weak field ligand. So even before starting with the crystal field theory, I am telling you the limitation of crystal field theory. You get it? But we still have to study because questions do come from here. ठीक है? अच्छा. So you have understood this. You have understood this. If you have understood this, now let us begin with postulates of crystal field theory. Yes, what is it? What is it? I've just told you about point charges and I've just told you about dipole. That means what is it? What is it based on? This particular model theory, what is it based on? Do you all agree with me that it is based on electrostatic model? Yes, everyone, halogen, all of them is a weak field ligand. So everyone tell me something, that do you all agree that it is an electrostatic model? Yes. Is it based on an electrostatic model? Absolutely. Absolutely. So, first, number one, it is based on electrostatic model. ठीक है? Yes. And then what do we do? What do we do after electrostatic model? After that, what is there? It is used to describe splitting in crystal field theory. Yes, or splitting in d orbitals. Yes, splitting in, which is used to explain, yes, explain splitting in d orbitals. Okay, all right. Next postulate is going to be what? What is going to be the next postulate, bacha? Anybody? Does anyone remember this? What is going to be the next postulate? Yes. Now here, I have just told you, remember, ligands are considered as point charges. ठीक है? Ligands are considered as a point charges. Is that right, everyone? Is that right, guys? है ना? Have I told you? Absolutely. I have just told you. ठीक है? And in case of anions or dipoles, then what happens? In case of anions or dipoles, yes, no, ligands are considered as point charges in case of anions. That means when you have an anion, you will consider that to be as a point charge. Correct, everybody? Yes, guys. Okay. Now here what happens, you will also have to know about some of the important terms. Okay? You will also have to know about some of the important terms. Chalo. Some of the important terms are, everyone. Number one is your degenerate orbitals. Yes, number one is your degenerate orbitals. What is a degenerate orbital, bacha? What is a degenerate orbital? The degenerate orbitals are basically the d orbitals yes, at the same energy level. The d orbitals at the same energy level, they are called as degenerate orbitals. Okay? Let's understand this, everyone. Let's understand this. So what are the d orbitals that you have, bachalo? What are the d orbitals that you have? You have d orbitals such as, what do you have? You have, let's say, yes, you have dxy. Yes, let's say this is your dxy. Okay? Then what do you have? You have something that is your, let's say, 1 second. है ना? So this will be your d. Let's say that this is your, what is this? This is going to be your dyz. है ना? Yes. Similarly, you can have dxz. Correct? You can also have dxz. This is going to be your dxz, right? Yes. Apart from that, do you also have dx square minus y square? Right? What do you have? You have dx square minus y square. And what else do you have? You also have something that is called as dz square. Is that right? This is your dz square. Acha. Now everybody, please pay attention. Do you all agree that this is, see, look at this. This is not falling on the axis. Is this falling on the axis, guys? By chance, do you see that this lobe, is it falling on the axis? No. It is not falling on the axis. It is not at all falling in the axis. Correct? Is that right, everybody? Absolutely. So that means that what can I call it? I can call this, and this to be as what? I'm going to call them as non-axial. What am I going to call them? These are your non-axial. Okay? But look at this and this. These are falling on the axis. Where are they falling? They are falling on the axis. That means what am I going to call them? I'm going to call them as axial orbitals. Yes, these are your axial and these are your non-axial. So generally what happens is, everybody, all the d orbitals that you have, all the 5 of them, yes, all the 5 of them, they're basically lying on the same energy level. Yes, where are they lying? So you have dxy, you will have dyz, you will have dxz, you will have dx square minus y square, and you have dz square. All of them are lying on the same energy level. Yes, all of them are lying on the same energy level. Now what happens is, suppose a ligand is approaching. When the ligand is approaching, acha bacha log, theek hai? So this is what it is. Now, tell me something. Let us understand this with the help of, something else. Okay? Let us understand this with the help of your family members. So suppose you have mom, dad. Yes, this is your mom, dad, let's say. Okay? Mom and dad. Hai na? Mom, dad, and let's say that there are 3 siblings also. Okay? There are 3 siblings also. Let's say that you and your 2 brothers or 2 sisters you have. Okay? So these many people are there. Yes, suppose suddenly this particular family, they get a news that somebody is coming to their house, okay? They get the news that someone is coming to their house. Now, what will they do? What will they do? If somebody is coming to their house, don't you think that the whole family will become suddenly excited? They will be like, oh, someone is coming. We have to get prepared. We have to make some food. We have to buy them some clothes. Yes, what should we do? Should we plan some outing? Should we go to the zoo? Should we go to the movie? Should we go to, Wonderla? Somewhere they will plan. Is that right, everybody? Yes, the whole family will get excited. So that means when the ligand is approaching, do you all agree that what will happen is this whole thing, yes, the whole d orbital is going to get excited, yet they are on the same level, bacha. They will all be still in the same level, but their energy level has gone a little up. Yes, their energy level has gone a little up, still degenerate. They are still degenerate because all of them are in the same energy level. Is that right, everybody? Yes. Acha. Now what happens? Now what happens? The family member suddenly, what if, tell me something, what if you understand, you realize that your grandparents are coming? If your grandparents are coming, yes, if your grandparents are coming, then you tell me, will you not be very happy? You will be very happy because your grandparents always take your side. If you say that, Mama, I don't want to go to the school. Papa, I don't want to go to the school. They will be like, okay, don't go, right? But they will definitely scold your parents that, hey, why are you giving him so much junk? Huh? Hey, why are you making only rasam and sambar? I will take my grandson today to Domino's Pizza and all. They will say all of these, right? So your parents will be like, yo, my parents have come because your parents' parents have come. So your parents will be like, now they will be strict with me. But you will be very happy. You'll be like, yay, grandparents have come. Yay, grandparents have come, right? Is that right? Hi, ASP Music. I, of course, definitely do remember you. How are you, bacha? Is that right, everyone? Absolutely. So now what happens, everybody? Please check it out. Check it out. Check it out. Guys. Are you all with me? Guys, are you all with me, everyone? Yes or no? Yes or no? So now what happens after some time, your parents' energy level has gone up even more because now you're like, yo, my parents are coming, my parents are coming, Amma Appa is coming, Amma Acha is coming, what to do? Their energy level has gone up and your energy level has come down because you're like, yeah, grandparents are coming. So you are very happy. You are very, very, very happy. So your energy level has come down. Okay? All the three siblings, their energy level has come up. Their energy level has come down and parents' energy level has gone up. Is that right, everybody? Yes or no? Guys, tell me yes or no, everybody. Are you all with me? Can I have the answer? Yes, guys. Do you understand this? Acha. Now what happens is, at this position, yes, this degenerate level that you had, this particular position, what is it called? You know, this is called as your barycenter. What is it called? This is called as barycenter. Okay? Acha. Okay. Now what happens? You tell me, bacha log, you tell me, the energy of the siblings have come down, but in comparison with whom? The energy of the siblings have come down, but in comparison to this two, and how many orbitals are there? So can I write here 2 divided by 5? In comparison to these two orbitals, the energy level has come down. So can I write here 2 divided by 5? Yes, absolutely. Now this energy level has gone up, but in comparison with whom? In comparison to this 3, the energy level has gone up. So can I write here 3 by 5? Absolutely. And that, my dear student, is your what? This is your crystal field splitting energy. Achha, now tell me, in many books you must have seen, okay, in many books you must have seen 3 divided by 5. 3 divided by 5 is going to be how much? 3 divided by 5 is going to be 0.6. Is that right? Do it. 3 divided by 5 is how much? Is 3 divided by 5 is equal to 0.6? Absolutely. This is your 0.6. And you tell me how much is 2 divided by 5? Is 2 divided by 5 0.4? Is that right, everyone? Absolutely. So this is your 0.4. So you write it as 0.6 delta octahedral and here you write 0.4 delta octahedral. This middle center is called as barycenter. This is degenerate. This is also degenerate, but here the splitting has happened, and this is particularly, this whole thing is called as what? It's called as crystal field splitting energy, CFSC. Guys, do we understand this? Yes, bacha, per day I will complete 1 unit. Yes, absolutely, yes. I will complete per day 1 unit. Hanji. How many of you have understood this? Tell me. How many of you have understood this? Please tell me. Please tell me. How many of you have understood this, guys? This is your delta octahedral splitting. Please tell me, did you all understand this? If you have, please quickly give me a EPBT. Hi Vishnu, thank you so much, bacha. Please quickly tell me EPBT. EPBT का मतलब easy peasy biryani tasty. Quickly tell me, bacha. Do you all understand this? Yes or no? I still don't see anything. You understood? Yes. Arey rock, wait, no. I still haven't come only to crystal field splitting. I still haven't come from this thing. Hi YG Clown, how are you? Thank you so much for coming here. I still haven't told you about John Taylor distortions. Yes, I will tell you. Don't worry. Don't worry. Okay, I see EPBT, guys. Okay. So this was your crystal field splitting energy, and right here are your d orbitals if by chance you want to check them out again. Okay. All right, this much is clear, bachcha log. Okay, this much is clear. Chalo. Oh, crystal field splitting energy in octahedral complex. So I already did it. But you guys understood this, no? Do you want me to do it again? Crystal field splitting energy. Do you want me to do it again, or did you all understand this already? Have you all understood this? Yes? You don't want me to do this again? You don't want me to do this again, no? Okay? Acha. Now let's take a look at crystal field splitting energy in tetrahedral. Okay? In tetrahedral. All right. Thank you so much, Vishnu. But are there this thing, huh? Chalo, now let's take a look at tetrahedral, okay? Or square planar. First, let's do tetrahedral, okay? First, let's do tetrahedral. Now, in case of tetrahedral, what will happen, bacha? In tetrahedral also, what you will see is, initially, so you will have degenerate only, okay? 1, 2, 3, 4, 5. Initially, so you will have degenerate only, is that right? Yeah, SP, I'll give you the detail, bacha. Now, so right now, I'm teaching you, no. Right now, I'm teaching you. How can I give you the strategy right away? Let me do this chapter. After that, I'll make a different video. Don't worry about it, okay? I'll give it to you. Acha. So here this has happened. Now, once again, bacha, what will happen is all of them, when the ligand approaches, that time what happens? When the ligand approaches, the whole thing will go up. Okay? Everybody will be initially excited. Okay? Everyone will be initially excited. Now what happens is that this time in case of tetrahedral complex, okay? In case of tetrahedral complex, what do you notice? In case of tetrahedral complex, you notice that actually now what is happening? It's some auntie has come, okay? One of your dad's cousin or one of your mom's cousin has come and you don't like that uncle and auntie so much. Yes, now what will happen? Now what will happen? Your excitement, you will be more angry like, yo, why is this auntie coming? Especially this auntie will come and she will take away my room also. Now what to do? You will be very, very difficult. You'll be very sad. Is that right? You will be very sad. So this time your energy level goes up here and your parents, they actually like them. ठीक है, your parents, they like them, so what happens is their energy level has come down. They're like, you're very happy, my cousin is coming, very happy. They're like, yeah, my cousin is coming after so long, we will have a lot of fun, we will be able to talk and everything. So this is what happened. Yes, now once again beta, same thing you have to do. What is this? This is your Barry center. Okay, this is your Barry center. Is that correct? Yes, this is your Barry center. Now these three orbitals, they have gone up, but in comparison to who? They have gone up in comparison to this one, the 2 by 5. That means it is going to be 0.4 delta tetrahedral. And here what is this going to be? This is going to be 3 by 5. That means it is going to be 0.6 delta tetrahedral. So guys, is this clear? You tell me, is this clear, everyone? Yes or no? Is this clear, everybody? Yes or no, guys? Yes or no? Do you all understand this? Does everybody understand this? Yes or no? Yes? Acha. Now, by chance, you get a square planar complex, okay? In case you get a square planar complex, then the things are a little difficult, okay? In square planar, it is not a very simple structure like this, okay? Acha, so which ones are this? These are your dxy. dyz, dxz here. Here you will have dx square minus y square and dz square. Okay? This is how it is. Guys, everybody, are you all able to understand this? Yes or no? Please tell me quickly. Tetrahedral complex, everybody. Tetrahedral complex, have we all understood? Come on, guys, let me know quickly in the chat box so that I can move on. So that I can move on. Yes? People are understanding? Vinit Kumar Patil. Bacha, I will not be able to talk in Hindi because this is a JEE English channel. But in Rankplus, we do have JEE English channel as well. In that, on Friday, I think I will be taking this exact same session. तो आप वहाँ आ जाना, ठीक है? आप वहाँ आ जाना बिल्कुल से. Acha. Guys, we will be doing the square planar in some time, but I guess the studio bhaiya is going to leave and he's just looking at me again and again. So can you give me a minute? I'll be back. I'll be back in 5 minutes. Can you give me like 5 minutes? I'll be back. I just have to let him know that my session is going to go for a little longer. Can you give me that? Yeah? I'll be back, guys. I'll be back. Take it. 5 minutes. Sorry guys, had to just fill up my bottle and tell studio bhaiya that my session will go for longer. You all are here? I am back. Acha, now guys, what we have to do is, let's talk about the square planar complexes. In square planar, I need you all to pay attention. Although I do not think in JEE mains they will ask you about square planar, because usually they don't, but you never know, right? So I think we should just study, okay? I think we should just study. So as usual, initially what will you have? As usual, initially you will have the degenerate d orbitals, right? Yes, here you will have all the 5 orbitals of D or of the D block. Is that right? Did you know Telugu? I only know Andariki Namaskaram, Ellargu Swagatam. That's all that's all that I know. Okay, I don't know more than that. I do not know more than that. Acha, anyway, now what will happen? As usual, when the family member is coming, the energy levels will go up. Is it correct? The energy levels will go up. But after that, what happens, you know? After that, what happens is that these guys, they do not split up just like the usual scenario. How do they split up now? Here, there are 3 different splitting up that happens. Truly. Here you will see that there are 3 different types of splitting up that happens. So what happens is, firstly, this goes up right here. Which one is this? This is your dx square minus y square. Yes, this is your dx square minus y square. Okay? After that, now what happens is, then you get to see dxy. Okay? Then here you will see dxy. Then what will you see? After that, you will again see the dz square. And then finally, right at the bottom, you get to see dyz and dxz. Okay? All right. So you have 3 different type of splitting. Okay? So this is your delta 1. This is delta 2. And this is delta 3. And all of these together is your what? Crystal field splitting energy of delta square planar. That means all of this together is your delta square planar. You get it? Now, what is the relation? You guys are going to ask me, ma'am, what is the relation between delta square planar and delta octahedral? What is the relation between delta tetrahedral and delta octahedral? So let me tell you, bacha. So what happens is, delta square planar is equal to 1.3 of delta octahedral. Yes. And delta tetrahedral is equal to 4 divided by 9 of delta octahedral. Yes, guys, this relation, will you all be able to remember it? Yes or no? You tell me. Hi, Vishnu. Yes. Yes or no, guys? Yes, everybody. Do we all understand this? Do we all understand this? Yes or no? Quickly write down EPBT. Quickly write down EPBT. Easy peasy biryani tasty, everyone. Hanji. Yes, bacha. This video is enough for newcomers, for board examination, for JEE mains, for everybody. Those who want to study last minute, this will be a very quick revision. This will also be enough for you to complete the syllabus. And if you actually do it properly, you will also be able to solve the questions. So now, let's understand the factors that affect CFSE. Okay? Let us understand the factors that affect CFSE. 1 second, let me just remove this, because this was the 5 minutes break that I gave you. Okay? All right. Acha, ha. Now, somebody was asking me John Teller distortion, isn't it? Someone was asking me about John Teller distortion. So I will be telling you John Teller distortion in some time. Now, please take a look at it, that crystal field is splitting in tetrahedral complexes. Achha. Have you ever noticed, bacha, that in case of tetrahedral, we do not write it as a EG and T2G? Chalo, now let us come back here. Now let us come back. So you have understood the splitting, isn't it? In case of octahedral, what happens? In case of octahedral, here is your degenerate orbitals, right? These are your 5 degenerate orbitals, correct? Then what happens? They all go up, correct? They all go up here. So you have 1, 2, 3, 4 and 5. Is that right, everyone? Yes. After that, what happens? After that, what happens? Do you all remember? Yes, guys, everybody, do you all remember what happened in case of tetrahedral? Sorry, in case of octahedral. In case of octahedral, if you remember, your parents were super not happy and you guys were very happy because your grandmother was coming and grandfather was coming. So this is called as your EG and this was your T2G. Is that right? No, not at all right. Which ones is EG, bacha? Which ones are EG? These ones are your EG and these ones are your T2G. So this T2G and EG, we write it in case of octahedral, definitely. But when it comes to tetrahedral complexes, what do you write? In case of tetrahedral complexes, bacha, please pay attention. You write it as a E and you write it as a T2. Why? Why is it that you do not mention the G in case of tetrahedral? Why is it that you only mention the G in octahedral complexes? That is because, everybody, if you notice that G means G, the G letter that you have, no, the G letter is actually a German word called Gerard. What is it? It is a German word called Gerard, which means symmetry. What does it mean? It means symmetry. Now, in case of octahedral, you do see that the symmetry is present, which is why you give them a respect and you say Gerard, G, T2, G, E, G. But in case of tetrahedral, do you notice the symmetry here? No, my God, you do not notice the symmetry, which is why you don't have to give them enough respect and you can write it as T2 and E. Am I clear? Am I clear? Am I clear, everybody? Yes, guys, please tell me in the comment section once again, do you understand that ye G, Gerard, symmetry, it is applicable for symmetry. So if symmetry exists, you will give them respect. You will write A, G, O, G, right? And if there is no symmetry, then you are not going to do that. So yes, guys, please let me know in the comment section, is this understood or not? Is this understood or not? Whew. Yes. Yes, yes, yes. Yes. क्या बात है, क्या बात है, क्या बात है. अच्छा, चलो. Now, everybody, let's try and understand. अच्छा, so this is your spectrochemical series. One second, huh? 1 second. Are we here? Yes. Acha. Now what is it that we're going to understand? Now let's understand, everyone. Guys, I'm audible and visible, no? There is no problem with the microphone, right? Acha. Now let's understand the factors that affect the crystal field splitting energy. Yes, what are we understanding? We're trying to understand the factors that affect crystal field splitting energy. Okay, okay, factors affecting CFSE. What is CFSE? CFSE is crystal field splitting energy. Okay, what is CFSE? CFSE is crystal field splitting energy. Now, the number one factor, everyone, is that crystal field splitting energy is directly proportional to the oxidation number of central metal atom. What is it? The crystal field splitting energy is number one, everyone. That crystal field splitting energy is directly proportional to what, bache? Directly proportional to oxidation number of central metal atom. Oxidation number of central metal atom. Example? What example? This is super amazing. This is super simple. This is self-explanatory. The more is the oxidation number. That means if something is in +5 oxidation state, +6 oxidation state, that means that more and more splitting will occur. Everybody, are we all clear on this? Kya baat hai? Theek hai, chalo. Okay, all right, everybody. Moving on to the next one, everyone. Moving on to the next one. Yes, geometry. When we talk about the geometry, yes, it is also dependent on geometry. That means that in case of delta square planar, the splitting will be more. You saw that, isn't it? There were 3 different splitting. Did we not see that? Yes, we saw that. Then comes delta octahedral and then comes delta tetrahedral. Correct? Yes. So what did we see? We saw that it also does depend on geometry. How? You see that delta square planar has more splitting than delta octahedral, and then comes your delta tetrahedral. Yes, so acha. Now suppose if I give you an example, everyone. Okay, suppose I give you an example. Let's say that you have okay, take a look at this, everyone. Suppose you have PTCl6 4 minus. Tell me what is this? This is octahedral. Is that correct? This is octahedral. Very good. Acha. Now, if I also have PTCl4. Okay, PTCl4. Guys, this is, by the way, let me tell you that this is what? This is a square planar complex. What is this? This is a square planar complex. So you tell me which one will have more splitting? Same central metal atom. The ligand is also same, only the geometry is different. Which one will have more splitting, bacha? Yes, the splitting will be like this. This, because it is a square planar complex, this will have more splitting, and because this is octahedral complex, it will have lesser splitting than the square planar. Clear hai? Yes or no, bache log? Yes or no, everyone? Yes. Okay. Next, everybody, what else is there? Chalo, let's take a look at that also. Let's take a look at that also. Arey, what is this happening again and again? One second. Next, there are some more points, okay? There are some more points. After this, I think I'll have to explain you John Taylor distortion. And but before that, I will do some questions because questions are important, hai na? Okay, next, bacha, you know, in D block orbital, in D block elements, you know that you have 3D series, then you have 4D series, and then you have 5D series. Acha, so if you have a 3D series and 4D series, which one will have more splitting? Which one will have more splitting? In comparison with 3D and 4D, which one will have more splitting, guys? Absolutely right. If you are thinking about it, the answer is that 3D will have less splitting, then there will be 4D, and then there will be 5D splitting. Gotcha. Is this clear? Is this clear, everyone? Absolutely. Acha. Now, last but not the least, I think this is something that you all know, nature of ligands. Yes, the splitting also depends on nature of ligands. That means that if you have a strong field ligand, the splitting will be much more than a weak field ligand. Correct? Aita, everybody? Is this clear? Yes or no? Very good, Tanishq. Absolutely right, bache log. Absolutely right. Acha. Now, based on this, everybody, after this, we understand the spectrochemical series, and this after the spectrochemical series came into the picture, we understood that hey, the crystal field theory also had its own limitations. Is that right, everyone? Absolutely. We noticed that due to the crystal field theory, or whatever the crystal field theory discussed with us, it said that anionic charges are supposed to be point charges. If something is point charges, that means that the dipole will be more. That means that the electrostatic force of attraction that is working between the metal and the ligand has to be much more. That means that the anionic ligand should be the strongest of the ligands possible. But look at this. The spectrochemical series tells us that I minus, Br minus, SCN minus, Cl minus, S2 minus, F minus, these are weakest of the ligands. Yes, these are the weakest of the ligands. And then you see, so somebody was asking me that, ma'am, can you tell me how to understand the spectrochemical series? Guys, it's very easy. Wherever you see carbon is the donor side, look at this, carbon monoxide, carbon and one nitrogen, ethylene diamine. These are the ones that will be the strongest. After that, the next stronger ligands will be, the next strongest ligand will be nitrogen donor site. Nitrogen, look at this, N, do you see? Then comes your H2O. H2O is in the middle. Here you have oxygen. After H2O, you have the oxygen donor site. Look at this, OH minus, yes. Yes, and finally this side it is. Now spectrochemical series depends on what? Spectrochemical series, who found out? How did we understand that this is the strong field ligand, this is the weak field ligand? Bacha, this was experimentally done. Okay? Yes, this was done experimentally. After finding it experimentally, then, I mean, you know, they all experimentally observed it first and then they wrote it down. Is this clear? So this is absolutely crisp and concise, and we understand that after experimentally conducting it all, then they notice that, acha, this is weak field ligand, this is strong field ligand. Yes, 10th boards, what is your doubt? Yes, bacha, tell me, what's your doubt? What's your doubt, bacha? Tell me, what's your doubt? हाँ, ठीक है बच्चे? Yes, guys, do we understand this? अबे डाउट पूछ क्यों नहीं रहा है? तब से डाउट कर रहा है. What's your doubt? Tell me, what's your doubt? Do we understand this? Do we understand this? Yes or no? Hi Arjun, how are you? Yes, everybody. This is clear? Any doubt here? Any doubt regarding spectrochemical series? Yes or no? Got cleared? Got cleared only. Acha, theek hai. Okay, guys. Now moving on, everyone. Now moving on from here, crystal field theory, this is understood. Acha, chal. Now, shall we do some questions? Shall we do some questions, everyone? Can weak field ligand act as strong field ligand? Yes. Certain times, yes. For example, water. Water with cobalt in its +2 oxidation state. When cobalt in its +2 oxidation state, water, H2O, can act as a strong field ligand. Write it down, everyone. Please write it down right away. Please write it down, everybody, that water with cobalt, when cobalt is in +2 oxidation state, it acts like a strong field ligand. Not always. These are only certain exceptions that you will find. Okay? These are only certain exceptions that you will find. Okay? Acha, chalo, bache. Okay. Next, everyone, what can I do? Ligands, so this you all know that weak field ligands are what? F minus, Cl minus, H2O, right? These are all weak fill ligands. Strong fill ligands, you have Cn minus, CO, NH3. These are all strong filled ligands. ठीक है ना? Okay. चलो. Now let's try and solve this question, everybody. Tell me, which of the following correct order of ligand field strength? Which one of the following is the correct order of ligand field strength, everybody? Definitely, anionic ligands are supposed to be on the left hand side, NH3, En and CO. I think option A is the correct answer, but please check it out and let me know. I think that there is no reason. It just acts like that. There is no reason. It's just it just does act like that. Chalo, chalo, chalo. Guys, tell me, is this the correct answer? Yes or no? Is this only the correct answer? Jayan, there is definitely, I would not like to discourage you, but I promise you one thing, that it will be your efforts more than anything else. Sorry? It will be your efforts more than anything else. Okay? You will have to put in the maximum efforts. You will have to put in the maximum effort. So guys, this is the correct answer. Is that right? Yes, option A is the correct answer. See, these type of easy questions also do come in JEE Main. So yes, there is a chance. There is definitely a chance. ठीक है, चलो. Next question, everyone. Correct order of spin-only magnetic moment of the following complex ion is. Okay. Correct order of spin-only magnetic moment. So can we just count it, everyone? Can we just calculate this, everybody? Let's do it. Okay. What do you have? You have three things. Okay? You have three compounds. What do you have? You have CO, F6, 3 minus. So cobalt. What is cobalt's atomic number? Who can tell me in the chat box? What is cobalt's atomic number? Yes. Sachin Tendulkar, very crazy man. Free coaching, 27, everybody. Why do I keep saying that? So that you also remember it. You also should remember it. So cobalt has an atomic number of 27. That means it is going to be 3d7 4s2. Okay? Let's calculate the oxidation number. So it will be x plus 6 multiplied with minus 1 is equal to minus 3. Is that right? Absolutely. So that means that x is equal to what? This will go that side. So plus 6 minus 3, it will become plus 3. Very good. Okay. So if it is plus 3, bacha, if it is plus 3, that means what will happen? Cobalt in its plus 3 oxidation state will be what? 2 electrons will go from here, 1 electron will go from here. Is that right? 1 electron will go from here, so it will become 3d6. Is that right? 3d6. F is a weak fill ligand. F is definitely a weak fill ligand. Is that right? Yes. Huh? F is a weak fill ligand. So if F is a weak fill ligand, now you tell me, will there be any paired electrons? 1, 2, 3, 4 and 5. Is that right? So it will become 1, 2, 3, 4 and 5 and 6. So there are 4 unpaired electron, bacha. Now, can I give you a trick, everyone? Can I give you a trick? See, in JEE examination hall, now that you are very close to the exam, let me tell you that whenever you find that there are 4 unpaired electrons, yes, how many unpaired electrons are there? There are 4 unpaired electrons. So if there are 4 unpaired electrons, always know, everyone, that the magnetic moment, the spin-only magnetic moment is about 0.75 more than the number of unpaired electrons. You wanna see? Let me calculate you. See, I'm writing it down here that it is going to be 4.87 Bohr magneton. Okay? I'm just writing it down. Now let me calculate, everybody. 4, yes. How do you calculate the Bohr magneton? Mu is equal to how much? 4 is the number of unpaired electron multiplied with 4 plus 2 root over. Is that right? So 4 plus 2 is how much? 4 plus 2 is how much, bacha log? 4 plus 2 is 6. 6 into 4 is how much? 4 5 is 24. 6 is 24. Is that right? Now 24 root over 24. Calculate and tell me what is the answer. Calculate and tell me what is the answer. Yes, the nearest double digit. 5 5s are 25. So 5 5s are 25. That means it cannot be 5. It is what? Root over 24. It has to be 4.87, 4.89, something like that. Is that correct? Am I right? Am I right? You tell me. Am I right or am I right? You tell me, guys. Am I right? Am I right? You tell me. Calculate this and tell me, guys. Calculate, Madi. Oh. Ha. Is it 4 point what? What is it? Calculate. Use the calculator and tell me. Use the calculator and tell me. Is it 4.87, 4.89, something like that? Is it? Is it? It is. See, I told you. I told you. Yes. Acha chalo. Now let us take a look at Fe. ठीक है? Iron. Iron. What is iron's atomic number? Iron's atomic number is 26. Correct? 26. Let's calculate the oxidation state. So X plus 6 multiplied with minus 1 is equal to minus 3 is equal to है ना minus 3. ठीक है? So if minus 6 will go that side, that means it is going to be X is going to be what? Plus 3. अच्छा. तो 26 बोले तो it is going to be 3d6 and 4s2. Is that right? Acha. Now plus 3 oxidation state. So 2 gone from here, 1 gone from here. That means what? 3d5. Bacha. 3d5 if it is 3d5, all the 5 of them are going to be unpaired electrons. Alva. All the 5 of them are going to be. All the 5 of them are going to be unpaired electrons, isn't it? It is. Is that right? So if it is 5 unpaired electron, now tell me 5 plus 2 is how much? 7. 7 5s are how much? 35. 6 into 6 is 36. That means if it is not 36, if it is root over 35, can I write it as 5.8 something? Can I write it as 5.8 Bohr magneton? Is that correct? Is that correct? है ना है ना है ना Yeah, Jayant, 6 months is enough. Yeah, 6 months you will be able to clearly do this. ठीक है? अच्छा. Now let us take a look at oxalate ion. This is C2O4 2 minus. चलो, let us do this. Let us do it for this also. So again you have cobalt. Cobalt, so you all know that it is 27. If it is 27, then it is what? 3d7 4s2. Is that right? Absolutely. Okay, let us calculate the oxidation number. So X plus, what is oxalate? Oxalate is a bidentate or a unidentate ligand. You tell me. Oxalate is a bidentate or a unidentate ligand. You tell me. Tell me, bache. Hui. Tell me. Oxalate is a bidentate or what ligand? Oxalate, C2O4 2 minus it is, है ना? C2O4 2 minus. So what will it become? It will be 2 minus 2 multiplied with 3, and here you will have minus 3. So once again, same thing. X is equal to plus 3 oxidation state. Okay. Acha. Now 27. So 2 gone from here, 1 gone from here. That means this is 3d6. Now is oxalate a weak fill ligand or a strong fill ligand? Is oxalate a strong fill ligand or a weak fill ligand? It is a weak fill ligand pretty much. Yes, that means there will be no pairing. That means there will be no pairing, right? But now what will happen? 3d6, isn't it? So again 4 it is going to be. Is that right? Huh? Is this correct? 3 minus C2O4 3d6 so 1 2 3 4 5 6. Guys, oxalate is a strong fill ligand or a weak fill ligand? Yeah, it has. Yes, Parth, that is absolutely right. What you are saying, that is absolutely right. That is absolutely right. You are right about that. But calculate, no? Calculate and tell me, what is it? Which one is going to be more? Which one is going to be less? NTA's favorite ligand is oxalate. That is true. I agree. NTA's favorite ligand is oxalate. They love oxalate. Yeah, they love oxalate. Hey, no, it's not strong. Huh? It is not going to be strong. It's not that strong. Weak fill ligand only. But now calculate and tell me. You will also find out that here it is going to be lesser, here it will be more, then it will be this, and then it will be this. Option C is the correct answer. Option C is definitely the correct answer. Yes, but C2O4 is going to be stronger than, it will be definitely stronger than what? F6. ठीक है? तो C2O4 is going to be stronger than F6. But what I'm trying to understand this, bacha log. I'm trying to understand this is that It is an intermediate ligand. Yes, it is an intermediate ligand. That you are right about. But please just behave small. Absolutely, that is also true. But you tell me that will pairing up happen or not? Will pairing up happen or not? I just want you all to find out that. I just want you all to find out that. Whew. This is an inner orbital complex, by the way. Let me tell you that also. Yes, guys, please answer in the chat box quickly. Please answer in the chat box. Hanji. Tell quickly. Pairing up will happen or not happen? I have told you, I have given you the hint already. I have given you the hint already. I have told you that it is what? It is going to be an inner orbital complex. So, bacha, if it is an inner orbital complex, baba, you tell me that how will it be paramagnetic? It won't be paramagnetic. If it is an inner orbital complex, it will be low spin complex. That means pairing up will happen. If pairing up happens, that means that 3d6 that you have, how will it behave like? It will be like this, isn't it? It will be like this. It will be 1, 2, 3, 4 and 5 and 6. So that means this hardly will have any Bohr magneton. Yes, this will hardly have any Bohr magneton. So yes, guys, option number C is the correct answer. Once again, if you can check it out, this the previous slide I made it a little too dirty, but in here you can understand that here what will happen. C2O4 behaves as fairly strong field ligand. Okay, behaves as fairly strong field ligand. Okay, pairing up will occur and there will be, yes, there will be no unpaired electron. Clear? Alrighty, everybody. Chalo guys, moving on to the next question, everyone. The next question is the hybridization and magnetic behavior of cobalt ion in CONH3 6. What is this? This is CONH3 6 complex respectively is this a plus or a minus? Huh? Is this a plus or a minus? That I can't understand. I think there is CONH3 6 plus. There is a plus here. Okay, there is a plus here. Okay, yes. Manvik, this is I'm not very sure, bacha. I'm not very sure, yeah. I'm not very sure. Hey, Tanishk, haven't I told you? What did I tell you? I told you that anionic ligands are the weakest. Then I told you that carbon donor sites are the strongest. After the carbon donor site, the next stronger ligands are the nitrogen donor sites. And then what happens? The oxygen donor sites are also there. So once again, everybody, anionic ligands in the left hand side, they are the weakest. Just close your eyes and visualize this, okay? Anionic ligands in the left hand side, they are the weakest. After that, you have the oxygen donor site. So from oxygen donor side, there is a possibility that they may start to behave as a what? They may start to behave as strong filled ligands sometimes. For example, I told you with cobalt, when it is in +2 oxidation state, even water behaves as a strong filled ligand. Haven't I told you that? I have told you that. So after oxygen, then comes your nitrogen donor side. After nitrogen donor side, the carbon donor sides are the strongest. Yes? Yes? No, bacha, this won't be enough for your advance because here I am not doing. NH3 is a strong filled ligand. Yes, NH3 is definitely a strong filled ligand, bacha. Yeah? Yes. What is the denticity of biuret? Who can tell me what is the denticity of biuret, bacha? Who can tell me what is the denticity of biuret? Who can tell me this? नहीं समझा, फिर से बताओ. क्या बताओ नहीं समझा? Tell their hybridization. What hybridization? Which ones? These ones, These ones. These ones, acha. For this it will be D2sp3. For this it will be D2sp3. Okay? For this what will happen? For this we have calculated, no? For this we have calculated, isn't it? Where is it? 4 unpaired electron, so this is going to be sp3d2. This is going to be sp3d2. Okay, and what is this going to be? This is going to be, where do we have it? Where do we have it? Where do we have it? We have it here. So this is also going to be sp3d2. Okay, this is also going to be sp3d2. All of them are octahedral complexes. Yes. Who can tell me what is the denticity of biuret? Who can tell me that? Bache, denticity to I explained long back. Now can we solve this question? Can we solve this question? Harsha, I will come to that, okay? I'm only teaching you mains level. Edit, please tell me, what are you asking? Nahi samjha. Kya batao fir se? Tell no then, what do you want me to tell you? Dekho, now he's only spamming. Now he's only telling. Spamming, sorry. Look at him. But if you do this, then how will I explain? Anyway, let's try to solve it. Okay? The hybridization and magnetic behavior of cobalt ion in CONH363 plus complex is. Chalo, let's find it out. Okay? Once again, bacha, cobalt is given. What is cobalt's atomic number? Cobalt ki atomic number kya hai? ठीक है? Yes, cobalt की atomic number क्या है? Very good. Yes, Partha and Tanishka, very good. Yes, guys, come back here. What is cobalt's atomic number? Cobalt has an atomic number of what? 27. So, scandium, titanium, vanadium, chromium, manganese, iron, cobalt. 27 is the atomic number. ठीक है? All right? Yes. Okay, so here write it down. Cobalt atomic number is 27. If it is 27, then what is the electronic configuration? 3d7 and 4s2. Correct? Yes. Acha. Now let's take a look at the oxidation state. Okay, X plus NH3, everybody, it's a neutral ligand. So 6 multiplied with 0 is equal to plus 3. So this too will become 0. That means X is equal to plus 3. Is that correct, everyone? Yes, is that correct, everybody? Absolutely. Okay. Now, if cobalt in its plus 3 oxidation state, then what will happen? It will become 3d6. Now, is NH3 a strong field ligand? Yes, absolutely. NH3 is a strong field ligand. So it will be 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5 and 6. Is this right, everyone? Is this right, everybody? है कि नहीं बच्चे लोग? है कि नहीं, guys? Everyone, are you all understanding? Yes or no? Yes, acha. So that means that now what will happen? This is your 3D. This is your 4S. And this right here is your 4P. ठीक है? This right here is your 4p. अच्छा, now tell me, bacha. So if these two d orbitals are empty, this s is there, and there are p3. Is that right? So that means what is going to be the hybridization? The hybridization here is going to be d2sp3. Correct? What is it going to be? It is going to be d2sp3. And that means that this is an inner orbital complex. If it is an inner orbital complex, do we all agree that it is going to be diamagnetic as well? Do we all agree that it is going to be diamagnetic as well? Yes or no? So that means that option C is our correct answer. Yes, bacha log? Yes, bacha log? Yes or no, bacha log? Come on, quickly tell me, bacha. Whew. Absolutely, technophile acid. That is an amazing way to study the chapter. Amazing way to study the chapter. ठीक है. Acha. Now tell me, next question, everyone, is, your next question is, which of the following cannot be explained by crystal field theory? The order of spectrochemical series, stability of metal complexes, magnetic properties of transition metal complexes, or is it the color of metal complexes? So, bache, everybody, let me tell you that. Stability of metal complexes, yes, crystal field theory could explain that, okay? If we talk about magnetic properties of transition metal complexes, yes, with the help of the number of unpaired electrons, with the help of the high spin complex, low spin complex, yes, crystal field theory does tell you that. Color of metal complexes, yes, it could explain you that also. We will be learning that in some time, yes. However, the order of spectrochemical series could not be explained by crystal field theory. Why so? Because according to crystal field theory, anionic charges are considered as point charges, and if it is point charges, that means that they are supposed to be the strongest ligands possible. However, the anionic ligands are not the strongest ligands possible. Yes, is that right, everybody? Is that right, guys? The correct answer is option A. Do not make a mistake here. The correct answer is option A. Okay? Acha. Now, guys, let us go to hi. Hi, Sharingan. How are you? Yes. Now let us understand. Now let us understand what, bacha log. Now let us understand calculation of a CFSC. Shall we do this? Shall we do this, everyone? Calculation of CFSC. Shall we do this? Yes, chalo, all right. But let me drink some water, huh? I'm good too, bacha. I'm just super happy to see you all here. So glad to see you all. Hanji, chalo. When will the class end? The class will end at around 11 o'clock. 11 baje tak it will end. Which chapter? Coordination compounds. We are doing coordination compound. Tank. Arey, tank I did not bring. No, I'm in Jaipur. I'm not at my home. I'm in Jaipur. So to Jaipur, I could not bring the tank. That's why I bought a smaller bottle. Once I go home, on 14th, I'm traveling. I'm going back to Bangalore. So from 14th, you will again get to see the tank. From 14th, you will again get to see the tank. ठीक है? Yes. Ha, I have a tank. I have a really huge bottle. That's what she's asking me about. What's tank? Yeah, sure. You can call me sis, akka, appy, whatever you want. Chalo, guys, let us understand calculation of CFSE. What is CFSE? CFSE is crystal field splitting energy. Yes, what is CFSE? Crystal field splitting energy. So, if you have an octahedral field, what is octahedral field? In octahedral field, what is going to be the coordination number? Who can tell me? What is going to be the coordination number in octahedral field? Come on, looking at the chat box, everybody. Yes, octahedral field में in case of octahedral field, octahedral, if it is octahedral field, yes, then what is the coordination number? What is the coordination number? I'm asking you such an easy question. I'm asking you such an easy question, but I do not see the answer. I am not seeing the answer, bachcha log. Chalo, theek hai, no problem, don't tell me. But let me tell you that CFSE ka formula is, okay, x multiplied with, what is it? 6. Thank you so much. Yes, the correct answer is coordination number is equal to 6. So here what do you do? Remember the splitting, everybody. So what will you do? X multiplied with what? X multiplied with 0.6. Remember 0.6 and 0.4, there were two numbers. Yes, there was 0.6 and 0.4. Yes, so X multiplied with 0.6 delta octahedral plus Y multiplied with 0.4 delta octahedral. Yes, plus. Acha, by the way, here there will be a minus. Plus, what else? plus z multiplied with p. Now you will be asking, ma'am, what are all of these, ma'am? Ma'am, what are all of these that you are doing, ma'am? What is this, ma'am? Ma'am, what are you doing, ma'am? What are you doing, ma'am? What is this? Okay, chalo. Now let me tell you, bacha. Okay? Now let me tell you. Acha, so 0.6. Where did you see 0.6, bacha? Where was 0.6 available? 0.6 was, look at this, number of electrons in EG. This is the one, okay? So that means what is this? This is your number of electrons in T2G. Okay, then what is Z, bacha? Z is number of electron pair. Okay, what is it? Number of electron pairs that are there. Okay, and what is P, bacha? P is your pairing energy. What is P? P is your pairing energy. Okay, this is your pairing energy. Write this down, everyone. Yeah, telling you. Now we will calculate also. P is your pairing energy. That means the energy that is required to pair two electrons. Okay? The energy that is required to pair two electrons, that is called as your pairing energy. Okay? Understood? All right. Achha. Now everybody, let us calculate each and everything. Okay? Let us calculate each and everything starting from D1 electron to D10 electron, everyone. Are you all ready, guys? Are you all ready, everyone? तो चलो शुरू हो जाओ. शुरू हो जाओ. ठीक है? All right, guys. WBBSSE, you mean West Bengal Senior Secondary Examination? Is that right, Benzo? Are you talking about West Bengal Senior Secondary Examination? Is that what you're asking? Chalo. All right, everybody. So first of all, we are starting with D. Firstly, let us start with D1, bacha log. Yes. Guys, please pay attention. This is very important because from here now I'm going to take you through the John Taylor distortion. Okay? Yes, the John Taylor distortion, we are going to go there now. So please pay attention. Please pay attention, bache. Okay? Yes. Do we need to do full 11th for our JEE Mains 2025? Yes, Ayushman, absolutely. You always need to do it. JEE Mains, if you want to clear JEE Mains, you need both, class 11th as well as class 12th ka syllabus. Okay? You need to cover both of them. Chalo. But chalo, number one, you have, let's say, D1. There is only one electron in the D orbital. So if there is only one electron in the D orbital, how are you going to draw it? Are you going to draw it like this? Yes, is that right? 1, 2, 3, 4 and 5. Correct? Acha. So the one electron will be here. Is that right? Absolutely. Now, how does the splitting happen, bacha? The splitting will happen like this. EG, and there will be, this is your T2G. Is that correct? So you tell me now, where are you going to keep this electron? This one electron, will you keep it here? This is your T2G and this is your EG. Is that right? Absolutely. Acha. Now what is the formula? What is the formula that I told you? The formula, everybody, is, how do you calculate CFSC? You are going to calculate it as X multiplied with 0.6 delta octahedral. Isn't it? What did I tell you? I told you that X multiplied with 0.6 delta octahedral. What is this? Number of electrons in EG. Are there any electrons in EG? None. Acha. After this, plus Y multiplied with minus 0.4. Y multiplied with minus 0.4 delta octahedral. Is that correct, everybody? Yes, ma'am. This is correct. Yes. Do you see any number of, any pair of electrons here? Do you guys see any pair of electrons here? None at all. So what do? Here you are going to write 0 and P for pairing energy, keep it as it is. Okay, P for pairing energy, you are going to keep it as it is. Now tell me what will happen. Here, this is going to be 0 multiplied with 0.6 plus here what will it become? It will become 1 multiplied with minus 0.4. Why am I writing like this again? It will become minus 0.4 delta octahedral. This is 0 into P again. So that means your answer is minus, that means your answer is minus 0.4 delta octahedral. Is that correct? Is that correct? Yes or no? Yes. Yes, do you all understand this? Chalo. Similarly, now guys, let us go to D2, okay? Suppose if you have now D2, okay? If you have D2, then how is it going to look like? 1, 2, 3, 4, 5, is that right? So 1 and 2, 2 electrons here. Now, how is going to be the distribution? The distribution is going to look like this. Here, what do you have? Here you have EG, and here, how it is going to look like? This is going to look like this. So this is your T2G, is that right? Absolutely. Acha. Now tell me, how do you write the CFSE, bacha log? CFSE, right? 2 electrons, 1 here, 1 here. How are you going to write it? You're going to write it as X multiplied with 0.6 delta octahedral plus Y multiplied with minus 0.4 delta octahedral plus Z. Z is number of paired electrons, 0 into P. Is that correct? Absolutely. Do you have any electrons in the EG? None. You do not have any electrons in the EG. Correct. So here this is also going to be 0. Here how many it will be? It will be 2. 2 multiplied with minus 0.4. Guys, come on, tell me the answer. Yes, please tell me. Camera is too long. Baap re baap, you guys have so many problems. If I teach you from home, then you will be like, ma'am, why are you not teaching in the studio? Now that I'm teaching you from the office, now you're like, the camera is too far. Baap re baap. Look at you. This thing, no, it just does not go only. Yes, how much will it be? How much will it be, guys? 2 multiplied with minus 4. 2 multiplied with minus 0.4. It is going to be minus 0.8. Is that right? Minus 0.8 delta octahedral. Correct or not correct, everybody? Correct or not correct, everyone? Yes, this is right. Very good. Chalo. No, next. Moving on, everyone. Next. We do not have much time. Okay. So now you have D3. If it is D3, once again, what do you have? 1, 2, 3, 4, and 5. Is that right? So 1, 2, and 3 electrons. Yes. Now what will happen here? You will have EG. This is your EG and this is your T2G. So you will keep the electrons like this. Is that right? This is your T2G. Calculate CFSE, everybody. How do you calculate CFSE? Yes, if you calculate the CFSE here, you will find that X multiplied with 0.6 delta octahedral plus Y multiplied with minus 0.4 delta octahedral plus 0 multiplied with pairing energy, because once again there are no pairs. Now 3 multiplied with minus 0.4 is going to be what? 3 multiplied with, हाँ तो पढ़ना माया, बार बार क्यों आके बता रही है यहाँ पे? तुम्हें पैसे मिलते हैं क्या ये करने के? हैं? तुम्हें पैसे मिले क्या ये करने के? बार बार आके क्लास में डिस्टर्ब कर रहे हो. पढ़ो जाके खुद वहां पे. Minus 1.2 delta octahedral. Is that correct? This is going to be your answer. ठीक है बच्चा लोग? Yes? ठीक है? हाँ जी हर्षा you pay attention here बच्चा, pay attention here. चलो guys, next everybody, let us take a look at D4. ठीक है, let us take a look at D4. If it is D4, you tell me बच्चा, D4 में there are 2 possibilities. Is that right, everyone? Yes, when it comes to D4, there are 2 possibilities. Is that right? So case 1, what will happen? In case of case 1, you will see that this is your degenerate 1, 2, 3, 4 and 5. Is that correct? Yes. Now from here, you will have the EG here. Yes. And you will have the T2G here. Now tell me, what can happen? It can happen 1, 2, 3 and 4. Is that right? Now these 4 electrons, you can either keep it as 1, 2, 3 and 4. And there is also a possibility, bache, look at this, you also have 1, 2, 3, 4, 5. So 1, 2, 3, 4. There is also a possibility that EG is here and T2G is here. There is also a possibility that 1, 2, 3 and 4. Is this correct, everyone? Yes, yes, is this possible? Yes or no? You tell me बच्चा लोग, is this possible? Yes or no? Yes or no? Is this possible? है कि नहीं? अच्छा, now let us calculate everybody. ठीक है, now let us calculate. So here what will happen बच्चा? Here if I have to find out the CFSC, how am I going to find it out? X multiplied with 0.6 delta octahedral plus Y multiplied with minus 0.4 delta octahedral plus pairing up. No pairing up is happening, so 0 into P. Yes, absolutely. But here, if I have to calculate the CFSC here, bacha log, take a look at this. Here, if you have CFSC, then what do you have? Here, it will be X multiplied with 0.6 delta octahedral plus Y multiplied with how much? Y multiplied with minus 0.4 delta octahedral. Yes. Plus here to pairing up is happening. Here to pairing up is happening. Yes. So if pairing up is happening, now can I write 0p? I can't. I will have to write 1p because there is a paired up electron. Is that right? Yes. Weak ligand में splitting and strong field में pairing. क्या बात है? Very good. Absolutely right. हाँ जी, तो what is this? This is what? This is definitely a strong field ligand. Is that correct? Yes. And what is this? This is definitely a weak field ligand, right? Acha. Now tell me what is the answer to each one of them. Calculate, bhaiya. Calculate and tell me what is the answer to each one of them, guys. Yes. Now when it is weak field ligand, here how many electrons are there? This is your 0.6 delta octahedral. Yes, that you will be getting. Acha. How many electrons are here? 3 multiplied with minus 0.4 if you do, then it will be what? Minus 1.2. So minus 1.2 and 0.6. What will you get? You will be getting here, minus 0.6 delta O. Correcto? Yes. Acha. Here what will you be getting? Here how many electrons do you have? That is 0. Gone case. Okay. Here you have 4 electrons. So 4 multiplied with minus 0.4 will be how much? 4 into 4 is 4 4s are 16. So it will become minus 1.6. Is that right? So this will become minus 1.6 delta octahedral plus P. Correct. This is your splitting. This is your splitting. है कि नहीं बच्चा? है कि नहीं? Yes or no? Yes or no, bacha? Tell me quickly. Come on. You let me know, guys. Hi, Anita. How are you, bache? How are you, bache? For D5, shall I do it? Or will you all be able to calculate now? Yes, Roshan, till now session is going on. Why, ma'am, plus P? Because, Are Baba, one pair is here, no? One pair. What was Z? What was the formula? The formula is X multiplied with 0.6 delta octahedral plus Y multiplied with minus 0.4 delta octahedral plus Z. Z is what? Z is number of electron pairs. And what is P? P is pairing energy. For P, we are not writing anything. We're just keeping it as P, okay? Because in the question, they will give it to you that P pairing energy is this much. Okay? They're supposed to give it to you, okay? Eaten dinner? No, I haven't eaten my dinner yet, okay? I haven't. I'm taking a class since the evening, isn't it? Next, guys, let us take a look at D5, everybody. Let us take a look at D5. Acha, if it is D5, then what will you do? If it is D5, then again you will have case 1 and case 2. Is that right? Yes. If it is D5, then again you will have a case 1. Case 1, let's say that in case 1, what do you have? Let's say that in case 1, you have strong field energy. Okay? Let's say that in case 1, you have strong field ligand. Sorry. Okay? If it is strong field ligand, then what will happen, bacha? If it is strong field ligand, then pairing up will happen. Correct? Yes? If it is strong field ligand, then pairing up will happen. So here you notice that this is the one. 1, 2, 3, 4, and 5. हाँ जी ठीक है तो you have 1 2 3 4 5 है ना and this is going to go up like this is your EG and this is your T2G. This is your T2G. So strong fill again. So it will be 1, 2, 3, 4 and 5 because splitting will be a lot. Is that correct? Splitting will be a lot. Why, Harsha? Why are you going? My next session will be on Friday or Sunday, I guess. I'm not very sure, bacha. I'll have to check my schedule, okay? I'll have to check my schedule. Chalo, everyone, let's do this. Yes. हाँ, तो here now how many pairs are there? There are 2 pairs. ठीक है, तो calculate your CFSE. Calculate your CFSE. What is your CFSE? What did I tell you? X multiplied with 0.6 delta octahedral plus Y multiplied with minus 0.4 delta octahedral. Yes, plus what will happen? Plus Z. Z means pairing up. Z means number of a pair of electrons. So there are 2 and paired energy. Acha. Now, is there any electron in the EG? None. So 0. How many electrons are here? 1, 2, 3, 4, 5. So 5 multiplied with minus 0.4 will be how much? 5 multiplied with minus 0.4 will be minus 2.0 delta octahedral plus 2p. Is that correct? This is the answer. Is that right, everyone? This is the answer. This is the answer. Yes or no? This is the answer. What do you mean by? Thank you so much. What do you mean by efforts are best? Huh? I'm not teaching you best or what? I'm not teaching you best. You tell me in English, is somebody teaching you like this? I don't think so. Nobody is teaching you in English like this with so much effort, huh? With so much of patience and everything. No one is teaching you like this, bro. Don't say all these things, huh? Is this correct? This is correct? Okay, next, case 2, everybody, okay? Case 2. For case 2, let's say that you have weak field ligand, okay? If you have weak field ligand, then what is going to happen? If it is weak field ligand, then it is going to be like this. Is that right? 1, 2, 3, 4, 5. Here what will happen? This is how the splitting will look like. Here you will have EG and here it is going to be T2G. Here no pairing, right? Weak field ligand, so 1, 2, 3 and 4 and 5, right? Now if you calculate the CFSE, what is it that you will get, bacha? If you calculate the CFSE, it is going to be X multiplied with 0.6 delta octahedral plus Y multiplied with minus 0.4 delta octahedral. Yes, are there any pairing up? No pairing up, so 0p. Then what will happen here? 2 multiplied with 0.6. 2 multiplied with 0.6 will be how much? 1.2 delta octahedral plus. Here how many? 3. 3 multiplied with 4 is how much? 3 4s are 12. Is that right? Again. So this will become what? This will become what? Guys, check it out. One major thing we have discovered, bacha. 1.2 plus and here it is again minus. So that means what? This is a 0. This is a 0. Guys, did you all see what I have done? Did you all see what just happened, everybody? Did you all see what just happened? Now tell me, so do you understand when we say that half-filled stability? This is the stability, guys. This is the stability. Do you just notice? I have written it, hence proved that if something is half-filled, then it is going to be like this. Similarly, do it for D10 configuration and you will find out that fully filled also you will find exact same value. So D5, D10, half-filled, fully filled stability is like this. Gotcha? Yes? Bacha bola to Harsha, it is bidentate, yeah? It is bidentate. And that's not even a doubt. This is like something that you can just Google and find out. Come on. Ask a conceptual doubts. Okay? All right. Acha, now let me tell you about the John Taylor distortion. Okay? Now let me tell you about the John Taylor distortion. So what happens is, because yes, no, this is not special case. Don't we keep saying that D5 half-filled stability is more, fully filled stability is more? We keep saying that, no? Yes, that is exactly what I proved it to you. This is the proof. You know, in mathematics, you do that root over 2 is an irrational number proof. So here I have just proven it to you that half-filled stability is more. Fully filled stability is more because you just found out that it was a 0. Gotcha. Clear hai? Acha. Now bacha log, So what does the John-Taylor distortion tell you, bacha log? Yes, the John-Taylor distortion is basically telling you that whenever you have symmetrical field that is present, especially in half-filled and fully filled, yes, in case of symmetrical field are present in half-filled and fully filled, that is what John-Taylor says. And in case of a symmetrical field, the John-Taylor distortion is absent. For example, if you have D3, if you have D5, weak field ligand, if you have D6, a strong field ligand, and if you have D8 and D10, that means that in those cases, you will see that what will happen? John-Taylor distortion is absent. What will you see? You will see that John-Taylor distortion is absent. So who was it who kept asking me right from the beginning of the session that, ma'am, what is John-Taylor distortion? Ma'am, what is John-Taylor distortion? So guys, this is what is your John-Taylor distortion. Right now, did you see that here in this case you saw that symmetry existed, isn't it? 5, see here also 1 electron, here also 1 electron. When you calculated, you found out that it was 0. That means right here what happens is John-Taylor distortion is absent, bache. Yes, what happens? John-Taylor distortion is absent, everyone. Yes, what did I say? Write it down, write it down, write it down. Okay? Please write it down, bacha log. Please write it down. Yes. In symmetrical field, and which are the cases where you will find that it is absent? Which are the cases where you will find that it is absent? You will find that in case of D3, absent. In case of D5, weak field ligand, it is absent. Okay, in case of D6, strong field ligand, it is absent. In case of D8, it is absent, and in case of D10 also it is absent. Okay, bache? Ishan, this is one of the major chapter through which you can clear your JEE. Yes, this is one of the major chapter. You must study this chapter, bacha. You must study this chapter. Okay? Okay, guys. Now let us take a look at, should we be doing this? Color in coordination compound. So color in coordination compound, what is it that you see? In color in coordination compound, you notice that first of all, what do? Draw a circle, then divide it, and then divide it again like this. So here you write down violet, blue, green, yellow, orange, and red. Okay? Yes. So here what happens, no, bacha log? Yes, guys, what happens is, see, if violet is absorbed, you will be able to see which one? You will be able to see yellow color. Okay? If bacha log, if red is absorbed, then what will you see? You will be able to see the opposite color, that is green. Okay? You will be able to see green color here. Okay? If orange is absorbed, then which color will you be able to see? You will be able to see blue color. That means you will always get to see complementary colors. Whatever is absorbed, the opposite to it, which is called as complementary color, will be visible. Okay? Complementary color will be visible. Okay? Yes or no? ठीक है? Yes or no, बच्चा लोग? ठीक है? अच्छा. Now in your NCERT, you must have seen that there is a compound which is written as this, TiH2O. Is it 6 or 4? TiH2O 6, isn't it? Yes. TiH2O6, correct? TiH2O6 and TiH2O6 3 plus. TiH2O6 3 plus. Acha, now tell me what is titanium's oxidation, titanium's this thing? Atomic number, scandium, then titanium. So 22 is the atomic number, is that correct? Yes, so titanium has an atomic number of 22, bacha. If it is 22, that means it is going to be 3D2, 4s2, is that correct? Absolutely. Let us calculate the oxidation number. X multiplied with 6 multiplied with 0, x plus 6 multiplied with 0 is equal to plus 3. So titanium is basically in its plus 3 oxidation state. If it is in plus 3 oxidation state, titanium in plus 3 oxidation state will have what? This 2 electrons gone, 1 electron gone from here. It will only have 3d1. 3d1, bacha. 3d1. I have just showed you what will happen to 3d1 if it is 3d1. Do you all agree? Do you all agree, everybody, that this is your degenerate, this is your 1, 2, 3, 4 and 5, is that right? Yes. Now from here what will happen? EG, this is EG and this is your T2G, is that right? Yes. So ideally the electron is here, but if this electron that is here, if it absorbs a little bit of energy, what will happen? It will jump to the EG level. Now this T2G is also in d orbital and this EG is also in d orbital. Is that right, everyone? Yes, this is also right. Acha. Now what will happen is, now this T2G electron that is there, that you see, once it has absorbed the electron, it will go to the EG level. Yes. After some time, when it has lost the energy, then what will happen? It will again come back, and in this way, do you all agree that it is going to show some color to you? Do you all agree that it is going to show some color to you? Yes or no? Yes or no? Yes or no, everybody? Absolutely. And this, my dear student, the fact that it went from T2G to EG and from EG to T2G it came, what is this? This is called as D transition. Yes, what is this called as? This, my dear students, this is called as your D transition. Do you all agree with this or not? You tell me. Yo, Are Hari, I am giving you this also. Yo, people. Yo. Yeah, I will tell all the sessions. Yeah, I will tell all the sessions. Don't worry about it. I will tell you all the sessions. You don't worry about it. Now you tell me, do you understand DD transition or not? Do you guys understand DD transition or not? You do? You do? Hanji? Ha, Baba, I will tell you, Pragna. Chill. Okay. All right. So color in coordination compound we have understood. Is that right? Achha. Now relationship between strength of ligand and what? And color. Okay? Chalo, let me tell you this. Okay? Suppose if you have a very strong ligand. Okay? Suppose if you have a stronger ligand, then what will happen? If you have a stronger ligand, bacha, then what is going to be the color? You understand that if you have a stronger ligand, then the splitting is going to be much more. Correct. If the splitting is much more, then tell me what kind of absorption of energy will happen. If the splitting is more, that means the absorption, the energy that is being absorbed, that will also be more. Is that right, everyone? Absolutely. So can I write that the energy is, sorry, no, let's not write proportional sign. Let's write that E is equal to 1 divided by lambda. Can we write like this? Can we write like this, everyone? Is that right? Is that right? So that means everyone, I can also write that ligand strength. I can also write that ligand strength is directly proportional to 1 by lambda. Can I do this? Can I do this, guys? Yes or no? I can absolutely do this. I can absolutely do this. Okay? All right, chalo guys, moving on. We have completed 105 slides. This is your 106th slide, bacha log. This is your 106th slide, everyone. Now, do you have some limitations of crystal field theory? What do you all think? What do you all think? Do you have some limitations of crystal field theory? Yes or no? Of course, yes. Of course, yes, we do have, right? Did we not see that this theory also takes into assumptions that the ligands are your point charges? Yes, this theory takes into assumption that ligands are point charges, right? This theory takes into assumption that ligands are point charges, isn't it? After that, what was the other this thing? That anionic ligands should be the strongest, isn't it? Yes, don't we all think that according to this theory, है ना? Yes, and similarly there are some more also. Yes, bacha, the lecture will be completed today. Don't worry about it. I will complete the chapter today. ठीक है? अच्छा. Next, everybody, what do you have? Next, what do you have, everyone? Organometallic compounds. ठीक है? So let us start with organometallic compounds, everyone. Shall we? Okay. Now, in case of organometallic compounds, what is it that we know? What do you mean by organometallic compound? That means that there is some amount of organic thing and there is some metal. Is that correct, everybody? Absolutely. So, the compounds in which the metal is directly attached to, yes, directly attached to the carbon. Who is organic? Who is the organic chemistry? Organic chemistry basically has all carbon only, no? That's when you start feeling like dyslexic. Oh my God, there are so many bonds. What to do? Exactly. So, the compounds in which the metal is directly bonded to carbon, you call it as organometallic compound. So, write it down. The first definition, everybody, is the compound compounds in which what was it? The compounds in which metal is directly bonded with carbon, in which ठीक है? अच्छा. Now, what type of organometallic compounds are there? There are different types of organometallic compounds. ठीक है? तो write that down, everyone. Different types of organometallic compound. Number one is your ionic organometallic compound. ठीक है? Number one is what? Ionic organometallic compound. So when do you have ionic organometallic compound? When the compounds are ionic in nature. Yes, of course. How? I mean, this is a little weird and stupid, isn't it? Organometallic, ionic कब होगा? When it is an ionic compound. Is that right? When there is an ionic bond present. Correct? So when ionic bond is present, when ionic bond is present. ठीक है? Okay. Next, what else can you have? You can also have covalent organometallic compound. Is that right? हाँ जी, Ashwan ji, what is your doubt? Yes. Now, when you have a covalent organometallic compound, and that, my dear student, is more important. So let's write that down. Okay? Here you have covalent organometallic compound. Achha. When you have covalent organometallic compound, what kind of bond will be there? What kind of bond will be there? Definitely, if I ask you this, you will be like, ma'am, what do you think? We are stupid or what? No, you are not stupid. I know that. That means that all of you agree with me that here there will be a covalent bond. Is that correct? Hai ki nahi? Yes. Hi, Sharia. Thank you so much, bacha. Super happy to see you also. Okay? Yes, so here what will happen? Covalent bond will happen. Covalent bond will be there. Very good. Achha. Now, you tell me, bacha, that is there a possibility that there will be a sigma bond also and there will be pi bond also? Is that a possibility or not? Yes. Is there a possibility? Bhai, what are you saying, bacha? Metal to different. You have organometallic. What did I tell you? That means there is a carbon. That means there is what? There is... Arey bhai, in case of organometallic only, you have what? Covalent bond. Na? Between a metal, you will have metallic bond. No. What are you saying? Yeah. Achha. Here, is there a possibility that you have a sigma bond? Can you have a sigma bond here? Yes. If there is a sigma bond, that means between who? The metal and the carbon. Between the metal and the carbon, you are supposed to have a sigma bond. Is that correct? Is that correct, everyone? Yes. For example, have you heard of organic chemistry mein Grignard reagent? What is your Grignard reagent? R, Mg and X. This Mg and this R, what is it? Sigma bond? Sigma bond? Huh? Sigma bond only, no? Very good. Acha. Next, is there a possibility that you have something called as pi bond also? Pi bond is also possible? Yes, absolutely. Absolutely. Now, have you heard of this example called as Zee's salt? Example called as Zee's salt. In this you will find pi bond. Okay? In this you will find pi bond. Yes. Hi Inti, how are you, bacha? Okay? There is also a possibility. What if you have both sigma and pi bond? What if you have both sigma and pi bond? Yes, this is the third type. If you have both sigma and pi bond, these are called as metal carbonyls. What are they called as? These are called as metal carbonyls. Now please pay attention, because this is where you start to learn about back bonding, synergic bonding, pi bonding. Yes, you have learnt about this, guys. I have taught you this long back also. So now let's understand metal carbonyls. One example let's take, okay? One example let's take. This is your cobalt, CO2, and then you have CO8. Do you understand? This is cobalt, this is carbonyl. Don't get confused. What is this? Ye cobalt hai and this is carbonyl. Okay? Cobalt and carbonyl both are there. So now let's draw the structure, guys. Let's draw the structure. Okay? How do you draw the structure? Look at this. So you have a cobalt here. You have a cobalt here. Okay? Now I'm going to draw all the carbonyl. Everybody, please take a look at it. Yes, sir. Now look at this. So you can have 1, 2, and 3. 1, 2, and 3. Is that right? Yes. These all can be your carbonyl. Here also carbonyl. Okay. So 6 carbonyls are done. 6 carbonyls are done. Now see what happens. Now you will see that here, this is how it is bonded. Okay. This is how it is bonded. So what do you have? Do you have a sigma as well as a pi bond? Yes. Do you have a sigma as well as a pi bond? Hanji? Yes. Are Pragna, ma'am, is there sigma and pi bond in ionic bond? Bacha, ionic bond mein, have you ever seen a sigma and a pi bond? In ionic bond mein, have you ever seen a sigma and a pi bond? Hey, huh? Where did you see, where do you hear about pi bond? Pi bond, where do you notice? From p block elements in carbon, isn't it? From carbon, nitrogen. Now you tell me, the non-metals, are they supposed to... Pragna, please study the chemical bonding chapter again. Please study the chemical bonding chapter again. Acha. Now guys, now everybody, let me explain to you the back bonding or the bonding in metal carbonyls. So everyone pay a lot of attention here. Okay? Let us understand bonding in metal carbonyls. Bonding in metal Okay. All right, everybody. So first of all, what do you have? You have a metal. Okay? You have a metal. Now this metal, you understand that this metal will have, let's say, vacant d orbitals. Is that right? This metal will have vacant d orbitals, guys. Is that right, everyone? Yes? Yes or no? Yes or no? And it will also have filled d orbitals. Sorry, I'm saying it ulta. Okay, this is your, let's say, this yellow color one. This is your vacant d orbital. What is this? This is your vacant d orbital, correct? And apart from that, it will also have filled d orbital. Is that correct? Yes, there will be filled d orbital like this, let's say. There are filled d orbitals, is that right, everyone? Yes, acha. Similarly, now please take a look at it. So you have here the carbonyl, CO. Yes, CO is also there. Okay? Yes, CO is also there. Acha. Now tell me, everybody, now tell me what will happen? What will happen to this carbon? Here, let's say that it has electrons. Okay? The carbon has some electrons here. But apart from the electrons that it has, you tell me, bacha, won't it also have anti-bonding orbital? Yes, there will be that pi star anti-bonding empty orbital. So these are what? These are your pi star anti-bonding orbitals. Yes, anti-bonding orbitals. This will also be there. Is that correct? This will also be there. So initially what happened, no, this carbon saw that Baba Re, this metal has empty d orbital. So it has given it. Okay? Alright. Firstly what happened, this carbon saw that the metal has an empty d orbital. So let me give the electron away. It has given the electron away. But after giving the electron away, now the metal sees that poor carbon, yeah, it has empty pi star and anti-bonding orbital. So what will happen from here? These are what? Filled d orbital. So from here, it gives the electron back again. And this, my dear student, Are Baba, firstly, to this is sigma bond. Yes, guys, pehle to sigma bond banega na. Firstly, to always you have to form sigma bond. Is that correct? Initially, there will always be sigma bond. So this is sigma bond. After forming the sigma bond, only you can form pi bond. This though cannot happen that initially only you will form pi bond. Only after formation of sigma bond, there can be pi bond. Is that correct, everybody? Is that correct or not correct, everyone? Yes, it is correct. Very good. So once again, everyone, try and understand this. What is this? This is your filled d orbitals. Yes, this is your filled d orbitals, everyone. This is filled d orbital, this is vacant d orbital. From here, carbon has donated the electron to initially there was a formation of sigma bond. After the formation of sigma bond, the metal says that, "Ayyo, poor fellow, this carbon has given me the electron." Now, it does not have electron only, it has empty pi star orbital. So again, from here it will come to there is a sigma bond as well as a pi bond. Yes, there is a sigma bond as well as a pi bond, everyone. And this, my dear student, it keeps happening to sigma bond and pi bond, a sigma bond and a pi bond. So this is called as a synergic back bonding. First, this carbon will donate sigma bond formation. Then this will again form another back bonding. So it's a synergic back bonding. So there is a give and take relationship that is happening between the metal and the carbon, guys. Whew. Now, do you understand this? Yes. Do you understand this? Acha. Now tell me something, bacha log. Now tell me something, everyone. Did you all notice? Did you all notice? You are going to tell me, everyone. Did you all notice that the metal and the carbon, between the metal and the carbon, what is happening between the metal and the carbon. What is happening between the metal and the carbon? Did you all notice that? Because firstly sigma bond happened. Now if the pi bond also happened, can I say that the bond order is increasing? Can I say that bond order is increasing? I can. I absolutely can. So bond order increases, है ना? Bond order, what is happening to the bond order? The bond order is increasing. Acha, if the bond order increases, what will happen to the bond length, bacha? What will happen to the bond length, bacha? What will happen to the bond length? The bond length will also, the bond length will decrease. Do you all agree with me? The bond length will what? The bond length will decrease. Acha. Now tell me, if the bond length decreases, bond order increases, what will happen to the bond energy? Will the bond energy increase? Absolutely. It will be difficult for us to break down the bond energy. So bond energy increases. Kya baat hai? You guys have done this. You guys have done this, everyone. Yes, guys. Whew. You understand this? You know this? You understand this? Very good. Acha. Similarly, now let us understand. Now let us understand. Now you are going to tell me what will happen between the carbon and the oxygen. The carbon and the oxygen of the carbonyl. Yes, the oxygen of the carbonyl. What will happen between the carbon and the oxygen? You tell me what will happen to the bond, this thing. What will happen to the bond order? Obviously, from here only they have to take the bond order, no? So this bond order is going to do what? Here the bond order will decrease, correct? Here the bond order will decrease, correct? So here the bond order is decreasing. Acha, if bond order decreases, then can I say that bond length is increasing? Can I say that the bond length is increasing? Yes, the bond length is definitely increasing. Acha, if bond length is increasing, then tell me what is happening to the bond energy? The bond energy is decreasing. Very, very good, guys. Very, very good. So here what is happening? The bond energy is decreasing. Kya baat hai? You guys got it? Understood? Yes, thank you so much, Pragna. Thank you so much, everybody. Yeah, I will do that. I'll do that. Don't worry. Yes. Whew. Acha. Chalo, guys. Now moving on from here, okay? Now moving on from here. Organometallic is done. Let us quickly understand. What are we going to understand, bacha? Forget about this. Okay. Now what are we going to do? Let us take a look at stability of coordination compounds. So what did you understand about stability of coordination compound, everyone? You tell me. ठीक है, चलो. You can do coordination compound. Rama Krishna, see, I think you do not know. You have come to the class very late, and we have been also solving previous year questions in this session only. Watch the session from the very beginning. I think you will be able to see it. Yes, Harry Potter, I will be sharing the notes as well. ठीक है, अच्छा चलो guys. So, सबसे पहले, first of all, what is happening here? See, you will take a metal. Yes, the metal is going to react with the ligand. Yes, and then what is the first thing that you will be getting? The first thing that you will be getting is a metal ligand complex. Is that right? Yes. Will you be getting a metal ligand complex, right? You will be getting metal and a ligand. Acha. So for this, everybody, you tell me what is going to be your K1. Remember in their chemical equilibrium chapter that you have studied? Yes. So here what is happening? Concentration of the product divided by concentration of the reactants. Do you all remember? This is going to be your K1. Is that correct? Yes. Yes. Is this going to be the correct answer? Absolutely. Acha. Now what will happen is you will take the Ml and then take another ligand. Now what is it that you are going to get? You are going to get Ml2. Yes. Acha. Now from here what will be your K2, bacha? Your K2 is going to be concentration of the product, that is Ml2 divided by Ml multiplied with concentration of ligand. Is that right? Is that right, everybody? This is what we have learned in the equilibrium. है ना? Yes, okay. Next, everybody, take a look at it. Now I'm going to take Ml2 plus ligand. If I take, then what is going to happen? It is going to be Ml3. So now what is going to be your K3? Your K3 is going to be concentration of Ml3 divided by concentration of Ml2 multiplied with concentration of ligand. Is that correct, everybody? Absolutely, ma'am. This is also true. Acha. Now if I take this Ml3 plus another ligand bacha, then what is it that I'm going to get? I'm going to get here Ml4. Is that correct? Yes. Here it will be K4. So K4 will be what? K4 will be concentration of the product, which is Ml4 divided by concentration of Ml3 multiplied with concentration of ligand. Is that correct? Acha. Now guys, do you remember the chemical equilibrium, the equilibrium chapter? In the equilibrium chapter, what is K1, K2, K3, K4? These are what? These are called as your stepwise stability constant, isn't it? What are these? These are called as your stepwise stability constant. Is that correct? Acha. Now, suppose I just say that there is something called as beta 4. What is beta 4? Beta 4, let's say, is your overall stability. What is it? This is your, let's say, overall stability. Okay? If beta 4 is your overall stability, then how am I going to write it? Beta 4 is going to be what, bacha? You all will agree with me that beta 4 is K1 multiplied with K2 multiplied with K3 multiplied with K4. Is that correct? Yes. Is that right? Is that right or wrong? Is that right or wrong, everyone? Everybody agrees with me? Oh, yes, we do. Yes, we do, right? Okay, chalo guys. So that is where we end with organometallic compound. Bonding in metal carbonyls is done. Bonding in metal carbonyls. Why do I have so many extra pages? Okay, now tell me this question. Low oxidation state of metals in the complexes are common when ligands have what? Why do you need a break? Yeah, let's finish it, no? By 11 o'clock, I should be able to finish it so that let's pull it. Yeah, let's pull it. Come on, guys. Yo, tell me. See, if you have ligands such as carbonyls, right now I have taught you, yes, so they are both sigma donor and pi acceptor, right? Yes. If that happens, don't you think that it will lower the oxidation state? Don't you think that it will lower the oxidation state and the bonding is going to be more effective? Absolutely. To have good pi accepting character, option A is the correct answer. Yes, option A is the correct answer. Manish Chaudhary, beta, why do you do this, guys? Why do you do this? I really do not understand you. Next question. The metal complex that is a diamagnetic, atomic number Fe26 and Cu29. Who was it? Somebody had asked me about this. Somebody had asked me about this, yeah. Somebody had asked me about this. Chalo, let us try and do this. Let us try and do this, everyone. Let us solve this. Chalo. Let us take this, okay? Let us take this, everyone. K3CuCN4, isn't it? K3CuCN4. Yes, first of all, what do you have to do? Find the oxidation state. So X plus 4 multiplied with minus 1. Since this is K3, so here this will be minus 3. Is that right? So this is going to be minus 3. Is that right, everyone? Yes, absolutely. Acha. Now what will happen? So X is equal to minus 3 plus 4. That means it is going to be plus 1 oxidation state. So copper, bacha, is in plus 1 oxidation state. And if copper is in plus 1 oxidation state, then what will happen? If copper is in plus 1 oxidation state, what is copper's electronic configuration? 3d10 4s1, correct? What is copper's atomic number? Copper has an atomic number of 29, which is what? 3d10 4s1. So if this goes away, it will be 3d10. 3d10 bole to what? This is fully filled, isn't it? This is fully filled. If it is fully filled, bacha, definitely it is going to be diamagnetic. So yes, option A is the correct answer. Any doubt here? Any doubt here? Perhaps no doubt. Chalo guys, moving on to the next question. Let us move on to the next question. Yes. The correct order of energy of absorption for the following metal complexes. Correct order of energy of absorption. Bache, energy of absorption. I think I can just tell you like this only. I can tell you like this. This is more stronger. Then it is this. A has the strongest ligand, isn't it? So A will be absorbing the strongest this thing. A will be absorbing the highest energy. Then this is NH3. Yes, then it is NH3. And then finally you have C, H2O. Water is the weakest ligand, isn't it? Just from spectrochemical series, you don't even have to calculate it. The correct answer is option A. Is that right or wrong, bacha? Now I'm teaching you tricks. I could have solved it in a very huge manner, but you know that from the spectrochemical series, ethylene diamine, En is what? En is a very strong field ligand. NH3 is quite a strong field ligand. H2O is sort of weak field ligand. It comes in the mid range, isn't it? So option A is your correct answer. Dekha bache? Yes, you don't have to lift the pen. Coordination compound is your secret weapon. You will be getting 3 questions from coordination compound. 3 multiplied with 4, 12 marks pocket mein in without lifting the pen, guys. Yes, do not pick up the pen. Do not pick up the pen. Inorganic chemistry mein, you do not pick up the pen. You get it? Chalo guys, A for Andhra Biryani. Correcto. Chalo. Next question. Next question is NiCN4 2- is a square planar and a diamagnetic complex with DsP2. ठीक है, square planar तो DsP2 hybridization only, ठीक है. But in NiCO4, it is a tetrahedral paramagnetic with sp3 hybridization. Is that correct, everyone? Who can tell me the answer? Who can tell me the answer? NiCN4 2- configuration, yes. Square planar, absolutely, yes. Diamagnetic complex, true. DsP2, that is also true, yes. In case of NiCO4, actually what happens, look at this, carbon monoxide, isn't it? Carbonyl. Carbonyl is what? Neutral ligand. So 4 multiplied with 0, nickel is in what? 0 oxidation state. If it is in 0 oxidation state, bacha, what is nickel's atomic number? Nix zin. So 28. 28 means 3d8 4s2. And it is a strong field ligand. So this is also going to be diamagnetic only, no? This is also going to be diamagnetic. It cannot be paramagnetic. It cannot be paramagnetic. It cannot be. Right? है ना? And what will happen, bacha? What will happen? This is also, how is it going to be sp3 hybridization? Is it going to be sp3 hybridization? Yes, it is going to be sp3 hybridization. Totally. Totally. Because it is D10, that means that the inner orbital, look at this here, 1, 2, 3, 4, 5, isn't it? So 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Now this S that you have and the P, this will have, this is the hybridization, sp3 hybridization will take it up. So what is the correct answer, bacha? What is the correct answer? And then in statement 2, they are saying that NiCl4 2- and NiCO4 both have the same d electronic configuration and have same geometry. This is also not possible. NiCO4, I've just told you that it is diamagnetic. NiCl4 is definitely paramagnetic. So the correct answer is that both the statement 1 and 2 are false. Option B is your correct answer. Thank you so much for answering it right. Kya baat hai? Okay guys, next question. Which of the following will have maximum stabilization due to crystal field? Who can tell me this answer or take this as a homework, guys? Take this as a homework. Who can tell me what is the correct answer? Bro, again, just look at the oxidation state or look at the ligand. Strong filled ligand will always stabilize it more, isn't it? Strong filled ligand will always stabilize it more. So what will happen? This is the correct answer. Cn is the strongest field. Option C is the correct answer. Do you have to pick up the pen? You should not be. If you pick up the pen, no. I will make you pulp. If you pick up the pen, you will become pulp only. I'll make you mango pulp and all. Plum pulp I will make you. Okay. Next, the crystal field stabilization energy and magnetic moment of an octahedral aqua complex of a metal ion M2 plus are -0.8 octahedral and 3.87 Bohr magneton respectively. बच्चे, yes. Can you take this as homework, guys? Can you take this as homework? I would like to finish your isomerism quickly. अच्छा, इस बार क्या वो जो आपके जो है, जो जिसके पीछे आप पड़े रहते हो, ये पीयूष जी, पैसे मिले क्या आप लोगों को? ऐसा लग तो रहा है, ऐसा लग तो रहा है कि आप लोगों को पैसा मिला है। पैसा मिला है ना? सच सच बता, पैसे मिले होंगे। आई एम प्रिटी श्योर आपको पैसे मिले। ऐसा कर ही नहीं सकते आप लोग, नहीं तो। थैंक यू अश्वन, थैंक यू सो मच बच्चे। So this you guys will do as a homework and you are going to tell me the answer in the comment section. Will you do that? आंसर मेरे को कहाँ बताओगे? You will tell me the answer in the comment section. और by the way, वो जो बोल रहे हो ना कि मैम वो बैच शुरू हो गया है, यहाँ आ जाओ, उस बैच में अंग्रेजी में नहीं पढ़ाया जाता। तो मेरे जो बच्चे हैं ना वो अंग्रेजी में पढ़ रहे हैं और उनको पढ़ने दे, ठीक है? तू हिंदी में पढ़। ओ भाई, चैनल देखा कितना नया है? अभी 5 तारीख से पढ़ाना शुरू किया है सबसे पहले, ठीक है बच्चे? इसे कहते हैं ना अल्प विद्या भयंकरी। लेस नॉलेज इज डेंजरस। व्हाट यू डोंट नो, ट्राई नॉट टू पुट योर नोज देयर। समझे? पीयूष द्विवेदी जी, द्विवेदी जी, हाँ जी, वेद 4 है, समझ रहे हैं आप? तो सारी चीजों को जानने के बाद ना थोड़ा बात कीजिएगा, ठीक है ना? 5 तारीख से शुरू किया है, अभी बहुत अच्छा चल रही है, ठीक है? तो इतना सर पे चढ़ के नाचो मत। होंगे, बहुत अच्छी बात है, बहुत अच्छी बात है, लेकिन कोई अगर पढ़ रहा है तो उनको पढ़ने भी दो। इतना पागलपना और हवा मत उड़ाओ हर चीज को लेके। चलो, next question is guys, अच्छा चलो, these questions we will do it a little later. Let's get into isomerism first, ठीक है? हाँ, तो isomerism everyone. Now isomerism everybody, what do you all know about isomerism? I know that I have taught you the organic chemistry isomerism as well, and in that you have learned that isomers are those compounds, 2 or more compounds that have the same chemical formula. But what is it that they have different? The difference is that they have different arrangement of atoms, okay? What is it that you know? They have different arrangement of atoms, yes, and they can differ in one or more physical or chemical properties. ठीक है बच्चे? Yes, so sometimes their physical and chemical properties may differ just a little bit, okay? Now if you take a look at it बच्चा, yes? तो हमें भी बनाओ ना इमोशन, इतना क्या हो गया है? हाँ, हमें भी बनाओ इमोशन, ऐसा क्या है? ओहो, नहीं, आप समझ नहीं रहे हो। You are talking about the batch. I'm not talking about the batch. I'm talking about the channel. This channel, this office, the company itself is just 1 year old. So wait up. Maybe someday we will also get there. Okay, chalo. All right guys, come back here, ठीक है? तो types of isomerism, so you have structural isomerism and you have stereoisomerism. Now in stereoisomerism, this is going to be very chotu motu. You have only 2 things, okay? In stereoisomerism, you have what? You have geometrical isomerism. What do you have? You have geometrical isomerism and you have optical isomerism. ठीक है? अच्छा, here in case of structural isomerism, what do you have? In structural isomerism, you will find ionization isomerism. What do you have then? Then you also have solvate or hydration isomerism. Solvate or hydration isomerism. You also have linkage isomerism, है ना? And last but not the least, what do you have? You also have what? Coordination isomerism, right? Yes. What do you have? You also have coordination isomerism, ठीक है? Thank you, Par. Thank you so much. Yes, you also have here coordination isomerism. तो चलो guys, now let's start with studying each one of them, everyone. Number one is ionization isomerism. So when the counter ion in a complex salt is itself a potential ligand, and if it can displace a ligand which can then become the counter ion. इससे तो कुछ भी नहीं समझ आया होगा. Did you guys understand anything? Did you guys understand anything? No. Let me teach you, okay? Let me show you one thing. One example and I think you will understand. Look at this. So, if I take CO, if I take then NH3, ठीक है? NH3, how many times should I take? You tell me, bacha, let's take 5 times, ठीक है? And here I am keeping SO4, ठीक है? Alright. Now, what if I keep here NO3? Possible? Possible, bache? Absolutely. But this is also possible. You tell me, is this possible, bacha? CO, NH3, let's keep it as it is. What if I take this NO3 inside? This NO3 is inside, and what if I take the SO4 outside? Now read the statement. The statement says that the counter ion, this is the counter ion. The counter ion in a complex salt itself is a potential ligand. What happened here? It became the ligand. And what happened? The ligand that was inside, this ligand came out and this became the counter ion. This, my dear student, is called as what? It is called as your ionization isomerism. Understood? Not understood? You tell me, is it easy peasy biryani tasty? This should not be any problem at all. Next, guys. Linkage isomerism arises in a coordination compound which contains ambidentate ligand. Yes, if there is an ambidentate ligand, then what do you call it? You call it as linkage isomerism. So, bache, take a look at it. Take a look at it. I think you will understand this also. Very simple, very easy, everyone. Look at this once again. Can I take it like this? CO. This time I am going to take NH3. Okay, how many times should I take NH3? You tell me, bacha. Chalo, let's take 4 times and let's write here NO2, okay, and let's write here Cl, okay. All right, is this possible? This is possible. Chalo, here I'll add plus also. Acha. This same thing, can I write it like this? Is it possible to write it like this? Look at this NH3 4 here, and what if I write it as O and O? That means that with the oxygen donor side, the ligand is attached to the metal. Yes, and here I can again write Cl and plus. Is this possible? Is this a possible? So this is your linkage isomerism. क्या बात है, क्या बात है. Okay. Coordination isomerism. This is also very nice. Look at this. Just look at the example. You will understand. Look at the example. See you. Let's say that you have NH3 here. ठीक है. CuNH3. How many times should I take it? Let's take it 4 times. ठीक है. Let's take it 4 times. Okay. All right. Now, what if you also have another one? Look at this. PTCl4. Is this possible? This is called as a coordination isomerism. But look at this. There is another thing that is possible. Okay, there is another thing that is possible. Can you also write it like this? PTNH34, PTNH34 and CuCl4. Is this possible? Interchange ho gaya? Yes, interchange with the ligand and the metal. Interchange with the ligand and the metal. Is it tough? Not at all. This is your coordination isomerism. Kya baat hai? Very good. Understood. Next is your hydration or solvate isomerism. So देखो, look at this here. Here what will happen? Look at this. CONH34 whole 4. ठीक है, NH34. All right, everybody. Now look at this. Here you can write Cl2. Absolutely. Yes, absolutely. Now look at this. Here there are no water molecule that is inside. But I can also do it like this, right? There is a possibility of this. Is this possible, guys? Is this possible? Can I do this H2O, Cl and here Cl? Can these two become a hydration solvation isomerism? Is that right? Is that right, everybody? Absolutely. Beta, whatever questions I have done, all of them are PYQs. Trust me. Beta, whatever questions I have done, all of them are PYQs. Okay? All right. Now, next one, everybody, is your geometrical isomerism. Okay? Now, geometrical isomerism, bacha, this can only arise in heteroleptic complex. Is that right, everybody? You tell me, bacha. You tell me, bacha. Okay? Hey, Piyush, मार खाएगा रे बच्चे, इतना मार खाएगा ना. तेरे को क्या लगता है कि मैं IIT नहीं हूँ? हाँ? क्या लगता है तेरे को? मैं IIT नहीं हूँ? क्या बात कर रहे हैं यहाँ पे? तब से ब्लॉक हो जाएगा तू. निकल यहाँ से. तो वहां अच्छा लग रहा है तो तू यहाँ क्यों आया? तू यहाँ क्यों आया? अगर तेरे को वहीं पे अच्छा लग रहा है तो वहां जा. तू क्यों यहाँ आया? बता. तू पता है क्यों यहाँ है? क्योंकि तेरे को पैसे मिले हैं ये करने का, है ना? ये जो टैगलाइन जो यहाँ पे मार रहा है ना, तेरे को पैसे मिले, बता सच सच बता, कितने पैसे मिले? ये देखो। यस हर्षित, व्हाट इज योर डाउट बच्चा? लेट मी नो व्हाट इज योर डाउट. हाँ अच्छा guys, see, this can only happen in heteroleptic complexes. तो बच्चे, you tell me, if I have homoleptic complex, suppose I have a homoleptic complex, you have metal here, ligand here, ligand here, ligand here, and there is a ligand here, here is a ligand, here is a ligand. अच्छा, now what is the possibility that you can have a geometrical isomerism? Geometrical isomerism means that you have a cis isomer and you have a trans isomer, है ना? है ना? Is that right everybody? Absolutely. So this though is a homoleptic complex. In case of homoleptic complex, you cannot have a cis and trans isomers. Is that right? Absolutely. So now what can we do? What can we do, bacha? Chalo. Let us take a look at coordination number. If coordination number is equal to 4, then what kind of isomers can we have? Look at this. You can have something like this: metal, ligand. This is a ligand and the X is also a ligand. So because the similar ligands are on the same side, what are you going to call them? You're going to call them as cis isomer. Okay? All right? Yes? Is that correct? Absolutely. Now, here what you can do is, you can also write it as, here this is a ligand, here this is a ligand, here is your X and here is your X. Now, because the similar ligands are on the opposite side, we are going to call it as trans isomer. Do you understand this? In case of cis isomer, you notice that the similar ligands have sort of, you know, 90 degree between them. Okay? Here they have 90 degree between them and here they have 180 degree between them. Do you get it? Do you get it, bacha? Yes or no? Everyone, do you get it? Yes? Okay, chalo. Now, the geometrical isomer can also exist in in case of a coordination number 6 also. In case of coordination number 6, let me show you how. Okay, so if you have coordination number is equal to 6, look at this. You can have something like this. Is that right? What will be this? This will be your trans. Okay, this will be your trans isomer. And not similar to this, you can have something like this. Is that right? Is that right? So here, what is this going to be? This is going to be your cis isomer. Correct hai bacha? Yes everyone, do you all understand this? है ना? Yes, do you all understand this guys? ठीक है? अच्छा. Now something that is very important everyone, please take a look at this. No geometrical isomers are possible for tetrahedral geometry. The question is why? Why is it not possible? Why is it not possible? It is not possible because all the 4 ligands, they are adjacent or they are equidistant to each other. Because I have come to Jaipur, I do not have my chemistry models with which I could teach. But try and understand it this way. See, if this is the metal, okay, if my hand is the metal here, so this is one ligand here, this is one ligand here. Yes, this is one ligand here. So from this position, from the middle position, going here or going there or going this side or going this side, these are all going to be equidistant from each other. What is it? These are all going to be equidistant from each other. So the relative position of donor atoms, that actually does not change whatsoever, and hence you will not be able to see a geometrical isomer here. Okay, can you, which Harshit? Which example, bacha? Which example? Which example? Let me know which example. Okay. Now let us take a look at geometrical isomerism for coordination number 4. But here I'm going to give you different types. Let's say that you have MABXL type. That means you have a metal. All right. The metal has a different ligands such as A. Let's say that I'm taking another ligand which is your B. Okay, then let's say that I'm taking another one which is here X, and then let's say that you also have your L here. Okay, and exactly similarly, bacha, exactly similarly, now take a look at it. You can also have M here. Okay, and you can have A here. Is that right, everybody? Can you do this? Yes? Haha. Can we do this? Can we do this? We can absolutely do it, right? Now, look at this. Can I have this? Here X. Here X, and then what can I do? My L can be right here, and the B can be right here. Is this possible, bacha? Is this possible, bacha? Absolutely. And very similar to this, I can again have what? This is my metal. This is my metal. And I can have, look at this, bacha. Look at this, everyone. Look at this. I'll keep the A position fixed, okay? I'm keeping the A position fixed. Now, what else can I do? What else can I do, everyone? What else can I do? Look at this. I can still keep the X position also same, okay? If I keep X like this, and then if I take L here, and if I take B here. Now, which one is cis? Which one is trans? Which one is cis? Which one is trans? Now, do you notice, everybody? Do you notice here that this and this and this and these both are cis? Yes, this is your cis isomer. This is also your cis isomer. Because A and X are on the opposite side, I have to call this as your trans isomer. Is that correct? Yes. Yes. Is that correct, everybody? Absolutely. Chalo. Now let's take a look at. Another one, okay? Let us say that we are taking MX2, L2, okay? If I take this, then here what will happen? Here you will have very easy peasy L, X, X and X, yes? So this is what? This is your cis isomer. And here if you notice, you will see L, X and X. What is this? This is going to be your trans isomer. Is that correct? Yes, guys, this is exactly what I just told you some time back. Hai na? Okay. Now, guys, let us go to your coordination number 6. Okay. If I go to coordination number 6, now this time I am going to have a MX2, L4. Can I have this MX2, L4? That means here I will have metal, X, L, L. Can it be like this? Yes, this is the one, right? Now, what is this? This is definitely your trans isomer. Absolutely. What is this then? Look at this. Is this right, everybody? Yes, then what is this? This is going to be your cis isomer. Correct, bache? Yes? Correct, bache? Yes, Manish, what happened? Manish, you have a doubt or what? Done? Okay. Now, next one is very important, okay? Next one is very important. Take a look at this, bacha. Acha. Here, can I take something like this? MA3, B3. Okay. If I take like this, then this is called as facial and meridional geometrical isomerism that you will get to see here. Okay, take a look at this. See, you can have something like this. You can have something like this. Okay, I'm going to show you. Please take a look at this, bacha. This is important. This is asked in JEE Mains as well. Okay, this is asked in JEE Mains. Now see, you can have A, B, B, B. Okay. All right, and here you can have A, B, B. Acha. Now, if you notice right here, what is the angle? The angle is 180 degree. Is that right? And if you picture it, then here you will also see 90 degree. Is that right? Yes, will you see that? Will you see that? So this is called as your meridional. What is this? This is called as your meridional. Okay? And here if you notice, you will only see 90 degree. Okay? This is called as your facial. So it is called as your fec and this is called as your mer. So this is your fec-mer type of geometrical isomerism. Okay? Alright, bacha. Yes, guys. Do you understand this? Clear hai? Any doubt here? I hope so not. Okay? Now, suppose you have a bidentate ligand. Okay? Suppose you have a bidentate ligand which is like this. You have MX2, LL2. Okay? Then what can happen? You can have it like this. This is your X. This is your X. Yes, you can have L. And here also you can have L. So what is this? This is going to be your trans isomer. Right? Absolutely. And here if you take a look at it, it can also look like this. This is your X. This is your X. Here is one L. And here is one L. Okay? So what is this? This is your cis isomer. Clear hai bacha log? Are you guys understanding? Are you guys understanding? Yes, Harshit, I'll give it to you, Baba. I'll give it to you. Again, you guys have to come from the beginning, bacha. I was also writing the mind map. I'll give it to you. It is there in this session only. You will get it. Chill. Okay. Thank you, Nanda. Thank you so much. Thank you so much. Okay. Acha. Now let us go to optical isomerism. Optical isomerism mein what happens, bacha? In case of optical isomerism, you see that where the plane of polarized light gets rotated to either right or left, then we like to call it as optical isomerism. So here, when it is rotated towards the right, what do we call it? We call it as dextrorotatory. And when it is rotated towards left, what do we call it? We call it as levorotatory. Is this understood, everyone? Yes or no, guys? Yes? Yes or no, everybody? Okay? So if the plane of polarized light is rotated towards right, okay? Plane of polarized light is rotated towards right, then we call it dextrorotatory. And if the plane of polarized light is rotated towards left, then we like to call it as levorotatory. Okay? Rotatory, it seems. Levorotatory. Okay? So chalo, for coordination number 6, let's take a look at it. For coordination number 6, suppose you have MLL3. Example, you guys want an example? Example, suppose you take CO. En is ethylene diamine. Ethylene diamine is a bidentate ligand, everyone. Yes, so En3, and here let's say that you have 3+. Okay? All right, everybody. Yes, guys. So here now look at this. So you can have CO. Okay? And you can also have it like this. Yes, now what is happening? What is this? This is your dextro. This is dextro. And what is this? This is levo. Can I say it like this? Yes. Can I say it like this, everyone? Ha, Baba, I'll give you question practice also. Let me finish this. Let me finish this, Manish. Yes. Yes, let me finish this. Give me some time. I'll do question practice. Haven't I been doing it? I have been doing questions also, no? Wait up. Okay? Acha. Next, what can we do? Next, let's say that we have MLL2X2 type. Okay? You have, let's say that MLL2X2 type. ठीक है, all right. If we have this, then suppose the example is, let's say PTEN2Cl2, ठीक है. If this is the one, then what will happen? You can write it like this, huh? So you can have Cl here, Cl here, right? Can you have this? And you can have one En this side and one En here. And similarly, you can have something like this also. Okay? You can have, look at this, look at this, look at this, everybody. Come on, come on, come on. Look at this, guys. You can have it like this also, Cl here, En here, and En here. Now, what is this? This will be called as a dextro. And this will be called as your levo. Okay? All right, everyone? Yes, guys. Okay, chalo. Moving on to the next one. Next one is some important points, everyone. Let me tell you once again that if your coordination number is equal to 4, yes, if it is coordination number equal to 4, then what is it possible? There are two things that is possible. One is your tetrahedral. This is your tetrahedral. And what other thing is possible? You can have square planar. This is your trick, bacha. Please note it down. Okay? One is your square planar. So in square planar, what happens is geometrical isomerism. Can you see geometrical isomerism? Absolutely. Geometrical isomerism is seen in square planar, yes. But optical isomerism is not seen here, okay? Optical isomerism is not seen in square planar. But if you have tetrahedral complex, then will geometrical isomerism be seen? Not at all. You will not be able to see geometrical isomerism. But will you be able to see optical isomerism, bache? Yes, you will be able to see optical isomerism. Okay? Alright guys, with this note everyone, we have come to the end of the session. This is once again your cheat sheet. Please go through this notes. Okay, please go through this note. You will be getting the notes as well. Now tell me, let us do some question practice. These are your previous year question. Okay, these are your previous year question, everyone. So let us start, guys. The question is, the primary and secondary valences of cobalt respectively is, bache, what is the secondary valency? Secondary valency is 5 plus 1 here. That means your coordination number is equal to 6. And this coordination number is going to be equal to your secondary valency. Is that right? This is going to be equal to secondary valency. Okay. Acha. For primary valency, what do you have to do? You will have to find the oxidation state. So x multiplied with x plus 5 multiplied with 0 plus minus 1 is equal to minus 2. This minus 1, if it goes this side, then what will you do? Yes, this minus 1, if it goes this side, you will find that x is equal to plus 3. So what is the correct answer? It is going to be 3 and 6. Option D is the correct answer. Is that right, everyone? Is that right, everybody? Is that right? Yes or no? Guys, hey, how is it option B? How is it option B? I just calculated the primary valency also and I showed it to you. It is going to be 3 and 6, okay? Yes? You can say that part, but I would always say that coordination number is always equal to the secondary valency. Okay, next question, everyone. Match the list, bacha. NiCO4, what is it going to happen? NiCO4 will have what hybridization, bacha? NiCO4, because it will have D10 configuration, electronic configuration will be D10, so this is definitely sp3. Is that right? Yes. NiCN4 2 minus, can you all calculate and tell me what is going to be NiCN4? Huh? What is going to be NiCN4? Everyone take a look at it. Ni, nickel is equal to 28. Find the oxidation state. X plus Cn is 4 multiplied with minus 1 is equal to NiCN4. This is what? 2 plus. So plus 2 here. Is that right? Now minus 4 will go that side. So X is equal to what, bachalo? Come on, tell me. Huh? Is it? Oh, it's 2 minus. Sorry, guys. 2 minus. This is minus 2. Hai na? So this will go that side. So that means that it will be in plus 2. Now nickel in plus 2 oxidation state. It will become 3D8 only. Hai na? 3d8 it will be. Now because this is a strong filled ligand, what will happen? Because this is a strong filled ligand, what will happen, bacha log? Yes guys, come on, can you tell me what is the answer? Since it is a strong filled ligand, all the 8 electrons will get paired up, so it will be dsp2. Yes, it will become dsp2. Okay. Next, everybody, what will you do? What else can happen, bacha? Definitely, because here pairing up will not happen, so that means this will be outer orbital complex, and here pairing up will happen, so that means this will be inner orbital complex. Is that right, everybody? Is that right, guys? Yes or no? Harshit, no. For advanced, I will have to launch a different session, no? For advanced, how mains and advanced, how will it be same thing? Next, everybody, arrange the following cobalt complexes in the order of increasing crystal field stabilization energy. So once again, bacha, do you even have to calculate this? I don't think so. Yes. Cobalt complexes in the order of increasing CFSC. Whichever has the strongest field ligand, so D will have the highest, then it will be C, then it will be B, and then it will be A. So DCBA. DCBA, option A is your correct answer. Is that right? Is that right, everybody? Arrange the cobalt complexes in the order of increasing crystal field stabilization energy value. Oh, no. There is an oxidation state difference, guys. There is an oxidation state difference. Here it is in 2 plus, here it is in 3 plus. So please check it out. Let me know. Done? Do you want me to take you through more questions, or can we wrap it up now? Do you want me to take you through more questions? Chalo, let's see. What other questions do you have? Next is 2 questions I have given you as homework, bacha log. 2 questions I have given you as homework, okay? 2 questions I have given as homework. Statement 1 says MnCN6. What is this? MnCN6. 3 minus. I can't see only. It's 3 minus. 3 minus. This is 3 minus. FeCN6 3 minus. COC2O4 3 minus are D2sp3 hybridized. Statement 2 MnCl6 3 minus. Is this again minus? 3 minus. Okay, 3 minus. And FeF6 3 minus are paramagnetic and have 4 and 5 unpaired electrons respectively. Chalo, let's solve this, guys. Shall we solve this, everyone? More question. Manish, Baba, can I go home also? कि नहीं जाऊं घर पे? यहीं पे रुक जाऊं आज? 11:30 हो गए बच्चे? What are you saying? More question. Give homework, everything, more question. I've been doing questions since the beginning of the session. Where were you all this time? Chalo, let's take a look at this. Statement 1 says MnCN6 3 minus, FeCN6 3 minus and COC2O4 3 minus are D2sp3 hybridized. What do you think? Are they D2sp3 hybridized? Chalo, let us take a look at it. FeCN6 3 minus. Let's solve FeCN6 3 minus. Acha, chalo, Mn also. Manganese. What is manganese's atomic number? 25. Correct? Yes. Acha. X plus 6 multiplied with minus 1 is equal to minus 3. So X is equal to what? It will become plus 3. So this is what? 3d5, 4s2. 2 electrons gone from here, 1 electron gone from here. This is going to be 3d4. If it is 3d4 and with the Cn, then what will happen? With the Cn, so है ना? So it is going to be 3d4, right? 1, 2, 3, and this will pair up. So it will be D2sp3. Yes, statement 1 is true. MnCN6 3 minus are paramagnetic. Yes, they will have, absolutely. So I think statement 1 and 2 both are true. right? Option D is the correct answer. Manisha, I don't know, bacha. I'll have to see my schedule and then tell you. Okay? Acha. Next question, everybody. Can you guys do this? Can you guys do this as homework? 3 questions. Can I give it to you as homework? The number of geometrical isomers found in the metal complexes are. Where will you find geometrical isomers, bacha? You need cis and trans. So here you will find cis and trans. Yes. This you will find cis and trans. In this one you will not find cis and trans. Then what do you have? RuH2O Cl3. Here you will find facial meridional. Yes, absolutely right. COCl2NH34. Yes, this one also you will find. Is that correct? Yes. So 2022. Is that correct? 2022. I think this is the correct answer. Option C is the correct answer. Is that right? 2022. Correct? Yes, guys. And finally, I think we have come to our end. We have come to the end, and here is your mind map, bacha. After doing nomenclature, what was the next thing that we have done? After doing nomenclature, we did your valence bond theory. In the valence bond theory, what is it that you have learned, bacha log? In the valence bond theory, yes, what did we learn? That valence bond theory's limitations we have learned. Valence bond theory cannot tell you about the color, it cannot tell you about the strength of the ligands, right? All of these we have learned. Is that correct? No, bacha. B cannot be correct. It has to be C. B cannot be correct. It has to be C. Okay? 2022 only it will be. Okay, after that, what else did you learn? You have learned CFT, crystal field theory, right? Then we have learned about organometallic compounds. You have learnt about organometallic compounds. You remember what you have learnt? Back bonding you have learnt. And finally, last but not the least, you have learnt about isomerism. Okay? You have learnt about isomerism. All right. So with this note, everybody, today's session is over. Your coordination compound has been done to 5 o'clock to 11:30 almost. I think we are done with the whole session, everybody. I hope that you all have understood everything. If you did, please do not forget to like this video, share this with your friend, and please don't forget to subscribe to Rankplus JEE English. This is your master teacher. This is your educator, Nabamita Ma'am, signing off from today's class. I'll see you all very, very soon, everybody. Let us quickly export this as PDF, and yes, you will get it soon. You will get it also, okay? You will get it in the Telegram channel by tomorrow. Okay? Done, guys. See you all. You can leave. Bye-bye. Yes, I will do that, Harshit. Bye, guys.